Hi, I'm Bob Tabor with www.learnvisualstudio.net. This series of lessons should provide an introduction to the fundamentals of the Visual Basic programming language and to programming in general. Now, if you're already an experienced software developer and you're coming from a different programming language or a different programming environment, then frankly, this might move a bit slow in some parts, so there might be some better resources available to you to use as a starting point. But if you're completely new to programming and you're new to Visual Basic, then this is a great place to start. We're going to walk through every action and every line of code that we're going to write together. I'll try to anticipate the problems that you might run into while you're working through these exercises and these videos based on my interaction with absolute beginners over the past 12 years of helping people learn Visual Basic and C# and .NET through video screencasts just like these. So the videos were recorded using Visual Studio 2013 Express for Windows Desktop, which is the free edition of Visual Studio that's available for download from Microsoft.com. And this is important since we're merely covering the basics of Visual Basic. The things that I'm going to cover in this series of videos will apply to all versions and all editions of Visual Studio. So this includes Visual Studio 2008, 2010, 2012, 2013, and whatever comes next, all right? It also means that you can use the Express editions of Visual Studio or any version that you have available to you of Visual Studio. In other words, and I can't more emphatically state that as long as there's a Visual Basic to learn, these videos will still be valid. So when new versions of Visual Studio and Visual Basic become available, the features that are added rarely affect the features that are relevant to absolute beginners, the basics, the fundamentals of Visual Basic in particular. So you can watch and you can follow these videos 10 years from now, and they should still be valid. So in the very next lesson, I'm going to walk you through the installation steps of Visual Studio 2013 Express for Windows Desktop. Feel free to skip that lesson if you already have Visual Studio 2013 or Visual Studio 2013 Express for Windows Desktop or any later version of Visual Studio already installed. Now, to get the most out of this video lesson series, you should be an active learner, meaning that you should attempt to follow along. I call this getting your hands dirty in the code. There's no better way to learn how to program than to follow along and write the code yourself. Don't just watch me do it. You need to do it as well. So pause the video, rewind the video if you need to. So I will make the code that I wrote available for download, and you'll be able to reference it, check your code against it if you run into some problems. You should really try to type it in yourself in your own copy of Visual Studio to build understanding and muscle memory and so much more. Furthermore, I would really encourage you to not be in a rush to just complete this course. If something doesn't make sense, then pause the video, rewind, watch it again, or ask me. There should be comments somewhere either in where you're currently streaming this video or somewhere on Microsoft's web properties, or you can write me personally. I'll give you my email address in just a moment, or find other articles or resources on MSDN or Microsoft.com or Channel 9 or Microsoft Virtual Academy or my own website, www.learnvisualstudio.net. That might be able to help you make that concept a little bit clearer in your own mind. So like I said earlier, if you're new to programming, I'm excited for you. You're embarking on an exciting journey that's immersive, it's rewarding, and the best thing is that you can do this. Even if you've gotten stuck in the past trying to learn how to program, I promise that if you put in the time and you and I work together on this, we can help build you a working knowledge of Visual Basic, and you'll be well equipped to move on to more advanced tutorials where you can learn how to build your own web, Windows, and phone apps. So if you ever have any questions about this series, or if there's any way that I can help you out in any way, please feel free to write me personally at bob@learnvisualstudio.net or reach out to me on Twitter with my handle @BobTabor. So after installing Visual Studio 2013 Express for Windows Desktop in the next lesson, we're going to create our very first program in lesson number 3. It's a simple program, admittedly, but we're going to build on that. We'll build on the fundamentals and get those under our belt so we can move on to even more advanced concepts. So I hope you're excited because I really am. Let's get started in the next lesson. We'll see you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need to get their first software development job building Windows and web apps for some of the world's best companies as quickly as possible. So in this lesson, I'm going to install the free edition of Visual Studio named Visual Studio Express that you can use to follow along in this series of lessons. Now, if you already have some edition of Visual Studio installed, whether it be the Express edition for Windows Desktop, like we're going to install in this lesson, or if you have Professional, Premium, or Ultimate, then you can skip this lesson and just continue on to the next one. Also, if you're already adept at installing your own software, then I'm willing to bet that you could probably figure this out on your own without my help. So feel free to continue on and skip this lesson. So like I said, the free edition of Visual Studio Express can always be downloaded from Microsoft.com/express. And the page may look different. The number of links, the number of tools that are available might change over time. Even the URL that you're forwarded to might change. But you can usually get to that page from Microsoft.com/express, and you may have to hunt around on the page to find the right edition of Visual Studio. And that's probably the first thing that you're going to notice. You're going to come to quickly realize that there's not just one free Express edition, but there are actually several. And you're going to choose the one that you should download based on the platform, or rather, depending on the type of application that you want to build. So for example, as we scroll down, there's Express 2013 for web, for building ASP.NET applications. Express 2013 for building Windows Store apps like the ones you see in Windows 8 and Windows 8.1, like these tiled apps, right? Scrolling down even further, this is the one we're going to ultimately download, Express 2013 for Windows Desktop. I'll come back to that in a moment. There's also Team Foundation Server 2013 Express. Not interested in that one. That's for teams, all right, for them to work together collaboratively. And then Express 2012 for Windows Phone for building, obviously, Windows Phone apps. And I believe that's about it. So this is vitally important. You need Express 2013 for Windows Desktop. If you do not have this installed, then you will not be able to follow along in the series. Now, again, Professional, Premium, Ultimate editions, all of these application types are available, so you're good to go with one of the commercially available versions of Visual Studio. But that's not the case with Visual Studio Express. They split them up by the type of platform. There are other differences as well, but you generally will only need the Professional Edition or greater once you learn Visual Basic and the .NET Framework, and you need some of the advanced features or when you're working with a team of developers. So a common mistake that developers make when attempting to follow along in this series is that they download Express 2013 for Windows instead of for Windows Desktop. You would use, again, this Express 2013 for Windows to build the Windows Store apps that you would sell in the Windows Store. And that's not what we're going to be doing in this course. We're going to be learning the Visual Basic language by building simple console applications. And you will need the templates that are available in Express 2013 for Windows Desktop. Okay, hopefully nobody misses that point. I've gone on and on about it now. So what we're going to do is click the little download link to continue on. And you'll see this little section on this page where you can change the download language that you want, and there are other download languages available. And there are two installation options for the English language. You can either install the what I call the little bootstrapper. It'll just install a tiny application on your desktop, and then that installer will go out and download the pieces it needs. Or you can download the entire DVD ISO image, which is useful whenever you're going to burn the entire install disk to a physical disk and then put it in your machine and install from there. So what I typically do is choose this little bootstrapper application. I'm going to click the install now. You're going to be asked to log in if you're not already logged into Visual Studio. Now, as you can see, I was already logged in, so it recognized me as Robert Tabor. I'm going to do this just briefly. I'm going to sign out and show you what this process looks like, and we'll go through it again. So I'll close this page now that I'm signed out, and I'll click Install Now again. This time it'll ask me to log in. It remembers my account credentials from a previous login, so I'm just going to click the Sign In button. You would type in your username and password or create a new Microsoft account. And now you're faced with two options. One is to install the Express Edition, or you can install a trial of the Ultimate Edition. You don't need that It's, I believe, a 30 or 90-day trial or something along those lines. What we really want here is Express 2013 for Windows Desktop. And Internet Explorer pops up the little bar. Do you want to save or run this? I typically just click run. I don't need to save it in my downloads folder. So now the Bootstrapper installer is running. It's going to ask me a few questions. Where do we want to install this? I generally leave the installation paths alone and go ahead and install it in the directory it wants to be installed in. I'm going to go ahead and agree to the license terms and privacy policy, and I'll go ahead and lead check the Join Visual Studio Experience Improvement Program. All these selections are up to you, but I'm going to go ahead and click the install button. User account control UAC pops up for Windows 8.1. It says, this is going to make a big change to your computer. Are you sure you want to do this? Yes. We're going to click the yes button. And so now it's going to go on the internet and download the pieces of Visual Studio and Visual Basic and the .NET framework that we need in order for Visual Studio to run on our computer. So this, on a fast internet connection, might take 10 minutes or so. So I'm going to pause the video here while we go through the installation process, and we'll pick it back up when we're almost complete. Okay, so once everything's been set up successfully, you'll see the setup successful message in the dialog, and then also the big launch button. Can't miss it at the very bottom of that dialog. We'll go ahead and click that. And there's one more step. You're asked to sign in to Visual Studio once again, so you'll use your Microsoft login. You can also choose not to, but there are some benefits from signing in. For example, your settings from computer to computer with regards to Visual Studio will be copied over. And so that's actually a very useful feature. So you can always have a setup that you're familiar with. So I'll go ahead and I'll use my login. As you can see, it remembered it. Again, it's copying the settings down from a centralized server so that I can have the settings, the UI changes that I've made specific to my version of Visual Studio available for me on the very first use. And after a moment or so, I see the Start Page tab loaded in the main area of Visual Studio, indicating that I'm ready to get started. So we're now ready to write our very first lines of code in the next lesson. We'll see you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. In this lesson, I want to show you how to build the most simple Visual Basic application possible, a Hello World application. It will simply display the message Hello World in a console window. So I'm not going to attempt to explain much in this lesson at all. However, you will get a feel for the workflow, in other words, how to create a new project, where to type the code, how to test the project that you created, and so on. So for now, just try to follow along and don't worry if something doesn't make sense immediately. Over the next few lessons, we're going to dissect this tiny little example, turn it inside out, and I'll explain every line of code that we wrote, why we wrote it, and what was going on underneath the hood while we wrote it. Okay, so I'm going to assume that you already installed the most recent version of Visual Studio Express or greater, and you're asking the question, what next? So this is the very next step that you should take. So the very first thing I'm going to do, as we left off in the previous lesson, I opened up Visual Studio. I'm actually going to close it because there's a shortcut that I want you to add to the Windows taskbar here on the desktop. So I'm going to go to the start page. In fact, I'm going to go to the little arrow in Windows 8.1 so that I can see all the apps. And I'm going to scroll over and find Visual Studio Express 2013 for desktop. I'm going to right click it and then select Pin to Taskbar. Now when I return to the Windows desktop by pressing the Windows key on my keyboard, you'll see that there's a little icon on our taskbar, and it'll be easy to launch it from there from this point on. All right, so that's the first little shortcut. So the first thing that we're going to need to do is create a new project, and there's several different ways to do this. The technique I'm going to use first is to go to the File menu and select New Project. And the New Project dialog will appear, and this will allow you to choose templates as a starting point for creating your project, your application. And you'll want to make sure on the left-hand side to select the Visual Basic template, since we're working in Visual Basic for this series. And then in the center, we want to select Console Application. And then I want to go to the name and change that from its default, which will be something like Console Application 1 or 2, if you've already built an application. We're just going to call this Hello World. Follow the capitalization, capital H, capital W, no spaces, and then click the OK button in the lower right-hand corner of the dialog. And it'll take a moment to set up this project. And it will create a new project based on the template that we selected. And you'll come to understand what a project template is and what it provides for you throughout the remainder of this course. But for now, let's keep moving forward. So after Visual Studio has finished creating a new project based on the template we selected, you'll see that the module1.vb is loaded in the main area. It's a little tab with the file name, and it allows us to have multiple files open at the same time and allows us to select different tabs in what's now this blue area because we only have one file currently open. And below that, in the code editor, you'll see in line number 1, module, module 1, end module. Now, in your edition of Visual Studio, your copy, you probably won't see the line numbers. You probably won't see the font sizes that I've selected. That's because when I logged in to Visual Studio in the previous lesson, it copied my preferred settings. And I'll show you where we can change those in the next lesson or the one after that. So don't be alarmed by that. This helps you see what I'm doing on screen. And I'll show you how to make those changes in your version of Visual Studio as well in just a little bit. But for now, what we want to do is position our mouse cursor between the sub main and the end sub, because this is where we're going to begin typing code. In fact, I'm going to hit the Enter key on my keyboard a couple of times. You'll note by default, Visual Studio puts our mouse cursor kind of at a tab as an indentation inside of the opening sub main and the closing end sub. And what we want to do here is begin typing the word console. So C-O-N-S-O. And notice that there's this little window that pops up below where we're typing. It's called IntelliSense. Don't let that distract you for now. Later, this is going to become our best friend. But for now, just ignore it and focus on typing the following code between this opening sub and closing end sub. So console.write, capital L in line, open parentheses, open double quotes, hello world, and you can put a space between those two. Now notice that Visual Studio already added for us the closing double quotes and the closing parentheses, and I can just retype those if I want to, or I can use the arrows on my keyboard to move to the end of the line, or I can use the N key on the keyboard to move to the end of the line, whichever technique you prefer. And I'm going to hit the Enter key on my keyboard and type in console.readline, and then an opening parenthesis, and Visual Studio automatically inserts the closing parenthesis for me. That's all I'm going to do. So now what I want to do is see the results of the code that I've actually written. And now, before I do that, I want you to inspect the code to make sure that what you typed looks exactly like what I've typed here on screen. Now, fortunately, Visual Basic is very forgiving, in so much that if you don't type the code exactly correctly, in some cases, the Visual Studio IDE and Visual Basic will correct the problem for you. And in other cases, the mistake is overlooked completely. So for example, if you forgot to capitalize the C in console, or the letter W or L in WriteLine, your code will still operate. For this reason, some people believe that Visual Basic is more beginner-friendly than, say, C# or JavaScript, which require exact capitalization in order to work correctly. All right, so this is important before I actually attempt to run the application. If you see any blue squiggly lines beneath what you typed, then you did something wrong. Take a moment to carefully inspect your work before proceeding onward. Pause the video if you must, but make sure what you have on your screen is exactly what I have on my screen. All right, so the first thing I want to do now is I'm going to save all my work by clicking the little Save All button on the toolbar. And then the next thing I want to do is actually run the application. I'm going to click this little Start button. It's the word Start next to a little green arrow. And this will allow me to execute the application and see it running. And it's a little anticlimactic, admittedly. If we did everything correctly, you should see a Windows command window open up and your hello world message displaying. And if you did that, you got that far, great. That's all we wanted to accomplish in this lesson. Now, it's possible that you ran into an error or two. So let me anticipate two problems that you may have had, and let me suggest some ways that you can correct them. All right, so if you see a message that there were build errors, then it's probably because you typed the code incorrectly or you put the code in a spot where it didn't belong, okay? So when you see there were build errors, would you like to continue and run the last successful build? Choose the No button. And when you do, an error list will appear at the bottom of the Visual Studio IDE. And this will give you clues as to what exactly went wrong. Now, the quickest remedy is to take a close look at what you typed and where you typed it and see how your code deviates from the code that I wrote a little bit earlier. And so I just wanted to give you a couple of possible error messages and their remedies. So if you see this message that I have on screen here, that a declaration was expected, it might mean that you typed the code in the wrong place. As you'll learn, you have to write the code inside the correct code block. Different commands belong in different types of code blocks, and we'll discuss what a code block is in an upcoming lesson. But for now, to remedy this problem, all you need to do is just select that code with your mouse. So hold down the mouse cursor, drag it to make a selected region around those two lines of code, hit Control X to cut those lines, and make sure that the code that you paste back into the Visual Studio IDE is between the sub main and the end sub, like so, okay? Now when you run the application, it should work correctly. Great. If you see that there were build errors and you get the message in the errors list that says hello is not declared, it might be inaccessible due to its protection level, or something about a comma or a parenthesis or a valid expression continuation was expected. Well, this is a little bit trickier. As I look at this code and I see those blue squiggly lines, that's my first signal that the code that I wrote is not going to actually run. That Visual Studio detected a problem when it was parsing out the syntax that I typed in. So in this case, the words hello and world had to be surrounded by double quotation marks. So to remedy this, I'm going to put one double quotation mark near the H in hello and one near the D in world. All right. The reason is because we want those two words to literally be written to the screen. And so we use double quotation marks to denote that those words represent a string literal. So we literally want that string, a string literal, printed to screen. We'll talk about strings and about string literals later in these lessons, but for now, just apply the double quotes around hello world, and that should remedy the issue. Now, hopefully those are the only two issues that you really could possibly run into. If you run into something else, by all means, ask me a question. I'll try to help you get started on the right foot here. But I want to emphasize that preciseness is the key. So let's go ahead and recap what we did in this lesson. Assuming that you got this to work, you're well on your way to building applications. As you may have learned while typing out this little example, writing Visual Basic code is an exercise in preciseness. Now, fortunately, as you saw, the IDE is going to help you write code correctly. Or at the very least, it's going to show you with that blue little squiggly line what you did wrong. So it'll point you in the right direction. So in the next lesson, we're going to focus on the syntax of Visual Basic. What did we write? Why did we write it? If preciseness is required, then you're going to need some explanation as to what those little words and symbols mean that we typed in. What's the period for? What's console mean? And things of that nature. So this is really easy once you get a few of the basics under your belt, and we'll start that process in the next lesson. We'll see you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. In this lesson, we want to start the process of dissecting this tiny little application that we wrote that simply prints hello world to the screen. So I want to spend a little bit of time and take a look at that module1.vb file that we were working in as a basis for future exploration of Visual Basic. So I didn't point this out in the previous lesson, but I can end the program in one of two ways. As you probably saw me do, I clicked the little red X in the upper right-hand corner. That's one method. The other way that I can end this particular program is just to hit the Enter key on the keyboard. and we'll discuss why that is in just a little bit. There's another way. Whenever you're running the application in debug mode, you'll come to learn that you can still work in the Visual Studio IDE, and you can still see how the application is executing. We can use the little red stop debugging button in the toolbar to stop it as well. All right, but at any rate, any of these actions will stop and we're back writing code again. All right, so I hope that you can see how the actions that you took while writing the code and the code instructions that you created are manifested when running the application. But what I really want to do is cement these ideas in your mind because they provide the foundation for everything that comes next. So what we're going to do is start on the inside and work our way outward. So let's start with the code that we actually wrote. We'll start with the basics. We used a programming language called Visual Basic. Now there are many programming languages in the world, but at this moment, Visual Basic is one of just 2 or 3 languages used to create .NET applications. Visual Basic is one of the main programming languages that Microsoft supports in Visual Studio. So if you're committed to learning Visual Basic, then I recommend that you learn as much about Visual Basic as you possibly can over the coming days and weeks through this series of lessons, through books, whatever the case might be. It's probably one of your better choices when you're just getting started in programming. If you're seeking a career in software development, you might want to highly consider learning C# as well, or maybe starting with C#. It just depends on what your goals are. Most developers aspire to master one programming language when they're first starting out, but once you master a single programming language, learning a second and subsequent language is a lot easier because many of the same concepts will transfer over even if the syntax is just a little bit different. As somebody who's been writing code for and developing applications for over 20 years now, I assure you that Visual Basic is a great language to start with. In fact, even though I took some programming classes in college, it wasn't really until I taught myself how to write Visual Basic way back in 1993, 92, somewhere along those lines, with this book. And if you take a look at it, it's all bent up and it's got food and hair in it. It's disgusting, and it's awesome because I spent every waking hour with that book pouring my heart and soul in learning how to program in Visual Basic. So that's how I got my start, and so I can recommend it on that basis. But today I typically use C# and other programming languages when I'm building Windows and web apps. All right? So you will change and your preferences may change over time, and that's okay. But Visual Basic is a great place to start. So when you learn how to write applications with Visual Basic, learning the syntax of Visual Basic, or in other words, I guess you could call them the nouns and the verbs and the punctuation of the programming language. Well, that's half of the battle. The other half of the battle is learning about the related pre-built functionality available to the programming language. Now, in our case, Microsoft has created something called the .NET Framework. I'm sure you've heard of it. And while that sounds kind of mysterious, and you may not actually understand fully what it does, I'll bet that you have at least some idea or some familiarity with it. For right now, just know that, first of all, it's not all that mysterious. It has a very specific purpose, and it has multiple parts to it, and we're just going to focus on 2 of those parts in this series of lessons. So the first part that concerns us is what's called the class library, the .NET Framework Class Library, also known as the FCL. It also is known by another name called the Base Class Library. I'm going to come back to that reference much later in the series of lessons. But either of those terms, or the BCL, FCL, Base Class Library, Framework Class Library, any of those terms describe this library of code that Microsoft wrote to take care of difficult tasks so that we, the developers who are building applications for businesses or for ourselves, we don't have to worry about those sorts of things. So there are library functions for just about everything you can possibly imagine as a programmer, for working with math operations, or working with text, or displaying things to the computer screen, whether in a console window or in a nice Windows form window, developing web pages, transmitting information over the internet, you name it. There's probably a function out there developed by Microsoft that will take care of it. Part of that library of code that you get whenever you build applications in the .NET Framework. So the second part of the .NET Framework that we're going to be concerned with is called the runtime. It's also known as the Common Language Runtime, or the CLR. You can think of it like a protective bubble that wraps around your application as you execute it on an end user's computer. I use the term or the phrase protective bubble to mean that the CLR takes care of the low-level details for you, so that you can focus on what the application should do and less about how to interact with the computer's operating system, how to manage memory, how to work with the hardware on that particular computer, and so on. Furthermore, the CLR provides a layer of protection for the end user so that you, the malicious evil software developer, you can't do much harm to the computer, to the user's computer, at least not without them knowing about it, without their approval. All right, so for right now, it's the .NET Framework class library that I really want to focus on. When we typed in the phrase console .writeLine, we were using some code in that library, and that code knows how to display text in a Windows command line window, like we saw, that black window with just the text printed out in white letters. All we have to do is tell it what we want displayed. Hello world. That's the important part. We don't care how it writes the text to the window. We just care that text gets displayed. And so when I wrote this code, I made sure to emphasize that you have to write the code in the correct place. Otherwise, the application will encounter an error when you try to run it. In fact, I demonstrated to you what would happen if we put that code outside of the proper code block. The correct place was actually inside between that submain and end sub, which again defines a code block. And that code block, this particular type of code block, is called a sub procedure because it has the word sub, end sub wrapped around it. All right. This innermost code, it has a name, and its name is main, and this main code is of type sub procedure. All right, that's a way to think about it. It's a special method actually that will be executed when the application is first executed by the end user. It will go to the main sub procedure first and execute that code. All right. So before I move past that sub main part, we also saw this, or we wrote this console.readline. Do you have any idea what that code does? Well, if we were to comment that code out, and I'm just going to talk about commenting in the next lesson or so, but I'm just going to put a single quote mark. It's right below the double quote mark. I'm going to put it next to the console.readline, and I'm going to, you'll see that it turns to green. Okay, so that's a note that this code will not execute. We're commenting it out. We're eliminating it from compilation. When I do that and I hit the run button or the start button, notice that our application flashed a screen and then went away, and we're back debugging our code again, or writing our code. All right, so this read line, what it does is it stops the execution of the code and it waits for the user to respond by hitting the enter key on the keyboard. Of course, we can circumvent that by hitting the X and the window and things of that nature, but that's its purpose, is to stop execution long enough so we can digest what actually happened on screen. And that's why we're going to add it to just about every code example that we write as we build applications here in the Windows console. Okay, back to the code. You can see that there's 3 levels of indentation. There's the module level at the very leftmost border, and at this point, mine has kind of gotten moved around a little bit, but there you go. You can see it now. There's one column, and then tabbed over another column is the sub main end sub column, and then inside of that there's the code that we actually wrote. So wrapping around that sub main is that module, module 1, end module. And so you can think of this as a series of containers. A module is simply an organizational tool, a way to keep your sub procedures organized. You put all of the sub procedures that are related together in a single module. So what do I mean by related? Well, that's really up for you. That's up to you, the developer, to decide. And as you get deeper into programming, you're going to come to understand that there are philosophies and approaches to writing code that will dictate where the code should reside in your code base, in your files, okay? So for now, let's keep it really simple. The main takeaway for now is that code is organized into sub-procedures and modules, and you have some blocks of code that reside in other blocks of code. And they have names, like this has the name module 1, this has the name main, and so forth. All right, so again, let's take a look at this line of code that we wrote, the console.writeLine method. Here we're executing what's called a method, and this method was written by somebody else at Microsoft. It knows how to display textual information to a command window like we've seen. At a very high level, modules and sub-procedures are roughly equivalent to methods and classes. Now, I cringe a little bit at that when I say it, because a class and a method are so much more than just the modules and the sub-procedures. It's so much more than just a mere organizational tool. Classes and methods open us up to a larger discussion of object-oriented programming, which is an important topic in software development. The .NET Framework Class Library itself was built using the principles of object-oriented programming, as well as techniques and constructs like classes and methods and other things like properties and events. So it's vital that you learn about using classes that other people wrote, like we did here, even if the first applications that you write are merely composed of sub-procedures and modules, all right? So we'll talk about how to create your own classes and methods a little bit later in the series, mostly as a means of just understanding more about the .NET Framework Class Library, mostly as a means of getting you kind of introduced to some of these ideas that you'll learn more about throughout your programming career. Just know that this word console is a class, and it's just one of thousands and thousands of classes in the .NET Framework Class Library that we can utilize in our applications. So each class has one or more methods that can perform a specific task, and each of those methods are loosely related to this idea of, in this case, a console, right? So there's the console write line, the console read line, and line number 2. Its purpose, as we said a moment ago, is to wait for the end user to type in information, and then when the user hits the enter key on the keyboard, it will continue to execute the remainder of that code. So in our case, again, we're using it to stop the application from completing and disappearing so quickly that we couldn't tell what was actually printed to screen. But as we'll see in a later example, it's also used to retrieve information from the end user that they type in so that we can evaluate what they typed and then take some action as a result of that. So both this write line method and this read line method are organized into a single class named console. Both methods deal with interacting with the command window, the console window. So it just makes sense that they're both organized and live inside of this console class, or are related or encapsulated inside of this console class. So we're utilizing, or we're leveraging code that's been written by somebody else merely by referencing the name of the class and the name of the method that we want to use. Notice between those, separating the class and the method, is a period or a dot. This period is called a member access operator, or a member accessor. In other words, we can access a member of the console class by using a period after the name of the class, and then typing the name of the member, or rather the method, the member of that class that we want to execute, right? All right, so next, both the write line and the read line methods have a pair of parentheses immediately following them. However, only the write line method has a value that we typed in between those parentheses. So that value is what's called an argument, and we're passing that argument into the method for its consideration, for its use. The value is an argument that we pass into the method as an input parameter. In other words, the write line method allows you to send it information that you want displayed on screen. So the write line method defines an input parameter, and then we pass in a literal string hello world as an input parameter argument to the write line method. We literally want those exact words displayed in the console window. All right? And so I keep using this term literal string. By this I mean a hard-coded sequence of alphanumeric characters. That's what a string is. We create a literal string in Visual Basic by using the double quotes that I keep doing air quotes here. By using 2 double quotes, and we surround any grouping of any sequence, any string with those double quotes, the alphanumeric characters that we want to define as a literal string. So as you learn, this is just one type of data that we could send to the write line method. In addition to just textual information, alphanumeric characters, we can actually send numeric characters that we intend to be used as numeric values that could be used in mathematical equations and so on, all right? And dates, and there's all sorts of data types. We'll talk about those more as we go throughout this series of lessons, all right? But the key idea here is that some methods can accept input values, such as a literal string in this case, which is then used by the write line method to display to the console window. We'll come back to the notion of methods in the future, but just know that whenever you see the parenthesis, that we are going to be calling a method, all right, that somebody else wrote, or maybe that we write, as we'll come to learn. So next I want to talk about the fact that we wrote 2 lines of code which are 2 complete instructions in Visual Basic. Now, unlike other programming languages, you can only put 1 instruction called a statement on 1 line of code. Now, there are ways to make a really long line of code split up into multiple lines so that it doesn't, carry off to the right-hand side. You'll see me do that throughout the series of lessons. I'll show you how to kind of circumvent that built-in 1 line per instruction, 1 line per statement rule. But in a sense, 1 line, 1 statement, 1 complete thought in Visual Basic. In other programming languages, you can have multiple commands on a single line, but you cannot in Visual Basic. At least you can't easily. And then also notice we talked about the indentation. That's completely optional. The computer doesn't need that indentation, but it's so important for humans that the IDE will add it by default. Why do you suppose that is? Well, doesn't it make it a little bit more readable? And now that I've explained what the different distinctions are between, submain and module 1 and things of that nature, it makes it a little bit easier for us to pick up and read what's going on screen. So most people think so, and that's why Visual Studio adds it by default. Along those same lines, Visual Studio color codes the text that we typed in. For example, class names and module names have this aqua blue color, all right, or green color. Special Visual Basic reserved words are in a bright blue or royal blue color. String literals are in this red, this dark red color. And so when you have those distinctions, it makes your code more human readable. All right, so expanding out from the code that we wrote, notice that we're working inside this file named module1.vb. It's this little label that we see on this tab at the very top inside the main area of Visual Studio. If we look over on the right-hand side, we're also going to see that file listed here, module1.vb. And actually, kind of to focus your attention out a little bit more, there's this window called the Solution Explorer. It has a tree view of several items. For example, at the very top, there's this solution called Hello World, and then second, an entry called Hello World again. This is actually the project entry. And then beneath that, we see a couple of icons, and then finally our module1.vb. In the next lesson, we're going to learn a little bit more about the Solution Explorer and about the other windows that are available to us all around and inside of the Visual Studio IDE. But simply put, the Solution Explorer is our main navigational device to find the other code files and the settings that, once compiled, will comprise our finished .NET assembly that we can execute ourselves on our own computer or put on somebody else's computer. So the end goal here is to compile up all these settings and all this code that we've written, and for there to be a final executable. So at any rate, to kind of delve into that a little bit more, files and other important settings are organized into projects, which are then compiled into a single .NET assembly. We'll talk about assemblies a little bit later, but an assembly is just a fancy word for either a .exe or a .dll file. All right, and you've probably seen those on your hard drive if you're familiar with working with computers. Furthermore, one project or one or more projects are organized into this larger container called a solution. In many cases, when you're getting started, you're only going to have one project inside of a solution. But as you build more complex applications, it's highly likely that you're going to need to manage multiple projects that are somehow related together. Again, the reason might not be obvious at this point, but as you continue learning Visual Basic and you're building more complex applications, business-oriented applications for large enterprises, this becomes a crucial code management strategy. So for now, just accept this extra layer of solutions that own projects, and trust me, it's important, but not until we move past the basics, all right? So the big question at this point is, where are your files actually stored? We see them in Visual Studio, but we know that they have to be somewhere on our file system. Where are they? So when you rely on the Visual Studio IDE to actually create a project for you, like we did when we went to File, New Project, the New Project dialog popped up, we gave it a name. There was also a path underneath that I didn't point out at the time, but that's where it actually will save all of these projects and all the settings for this given project, or all the files in the project, I should say, to our hard drives. So what we want to do now is open up Windows Explorer and navigate to that spot, just so you can see where your code is actually stored. So what we want to do is, this will be different depending on which operating system that you have. I'm using Windows 8.1. So I'm going to go to this PC, and I'm going to look under Documents. And under Documents, there should be a folder called Visual Studio 2013, or maybe 2014, 2015, 2020, I don't know, whatever you have, right? And if we drill into that folder, you can see that there are a number of subfolders. The one in the middle that I'm looking for is called Projects. If you double click the Projects folder, you can see that there is our Hello World Solution folder. If we open up the Solution folder, you can see it has a solution file. In fact, if we were to move this over, you can see that while the file extensions are not shown, let me change that real quick. Let's go to View Options, and we'll go, we're going to deselect Hide Extensions for Known File Types and select Apply and click OK. And so now you can see that the file extension .sln is a solution file for Visual Studio. All right, so we're going to drill into the solution folder's subfolder called Hello World, which this will be actually the project folder. And now we see that there's this hello world.vbproj. So that's going to be the project folder, or the project file, that contains settings that we can set, and I'll show you how to set those settings a little bit later. Then there's also this module1.vb. Okay, we know what that is. And then there's this app config, which we see represented here as well in our Solution Explorer. If you take a look in this bin directory, you're going to see that there is this folder called debug. We'll come back to that in just a moment. Let's go back out to this hello world.vbproj, and what I want to do is open it up and take a look at it. I'm going to right click it and select Open With. And this is very dangerous. I want you to immediately deselect Use this app for all VBproj files. Make sure that's deselected. Don't be angry at me if you leave it selected and you accidentally click something. Then I'm going to click More Options and choose Notepad, which should be one of the options. And all that I really wanted to point out here is that that this file format is just a bunch of XML, Extensible Markup Language. And it's frequently used in software development as a means of adding configuration settings to an application or a project. So this is sometimes known as metadata. This file contains file paths, the previous state of the project, like which windows were open when we previously were working in Visual Studio, and other important settings related to the project itself. So this is really important. Do not, under any circumstances, actually modify this file. Doing so might corrupt your Hello World project beyond repair, so please don't touch it. In fact, we probably should have closed Visual Studio before we even started dealing with this, but I'm too far in at this point. Let's not touch anything at this point. And you can feel free to scroll through it. I don't think that most of it will make sense at this point, but all of these settings as we look through it are very important to Visual Studio and to .NET as we compile our application into an executable. So I just wanted to demonstrate that there's really no magic going on here. It's just a bunch of configuration settings that comprise a project. It says what files belong to this project, okay, and then when you get ready to compile, the compiler is going to look at that, going to say, oh, I need this file, and I need this file, I need this file. Let's compile them into an executable, all right? And the same thing is true with the solution. We're not looking at that, but it's just a bunch of XML as well, just at a higher level to contain the projects that belong to the solution. All right, so I'm going to close Notepad. If it asks if you want to change, save any changes, don't save any changes. That would be a big mistake at this point, all right? If you accidentally typed something in, or your cat ran across your keyboard as you were looking at that file, don't save the changes. All right, what I want to do is continue on and talk about the bin subdirectory, and we see in here we have a debug folder. The word bin is short for binary, and it denotes the binary executable output created by the compilation process. So what I want to do is open that file, or that folder, to reveal its contents, and you should see that there are actually an exe, and then a number of config, PDB files, and so on, even an XML file, all right? So this is the debug version of the application that was created whenever we click the Start button on our toolbar. And the debug version contains not only the executable file itself, but also additional information in the form of some of these files that allows the Visual Studio IDE to keep track of what's currently happening inside of the executable as it's running. So as you're going to see, one of the most powerful features of the Visual Studio IDE is the integrated debugging environment, allowing us to watch code execute line by line as a means of determining where the problems with our code might actually reside. More on that later, but that's a very cool feature and one of the biggest reasons why you should use an IDE. So at some point, we're going to be finished working on our application. We're going to be ready to release this to end users, to our friends, or to our customers, whatever the case might be. And so we'll want to create a release version of our .NET assembly that we can distribute to others, put on their computers. And we don't want it to be bloated with all this extra information that's used for debugging in Visual Studio. We don't want the speed of the release version to be affected with all this extra information that was used during debugging, and therefore we want to create a release version of our code, and we'll do that in just a moment. So back here in our debug folder, you'll see that there's a hello world.exe. If you double click it, the application actually runs. I think that the last time I built it, I removed that line of code, that console.read line. So this time when we run it, it should actually stay on screen for a moment here. And so then the other files here have various jobs relating to the process of debugging, keeping the IDE in sync with the code that's currently being executed inside of the .exe, the .NET assembly. And we'll see this in action in the very next lesson. However, the key idea here is that this debug version is not optimized to be released to an end user's computer because it contains all this extra stuff, all this extra information that's used by Visual Studio for debugging purposes. And we don't need all that when we're ready to finish it and deploy it to somebody else's computer. So ultimately what we want to do is create a release version of the application for distribution to end users. And so we'll do that in just a moment. Actually, we're going to do that now. Let's go and to this little drop down that's next to the start button. And we've currently selected to debug, but if I were to drop it down, you'll see that there are some other selections as well. We already know that the debug option is going to create a debug version of the application for us. Obviously, the release option is going to create a release version of the application. And then there's this configuration manager ... Whenever you see the ellipsis at the end of a phrase in Visual Studio or any application, that generally means that there's going to be another window that's going to pop up afterwards. So when you select configuration manager, it opens up the configuration manager dialog, and it allows you to create different configurations. And this is applicable whenever you have multiple projects in the solution and you want to mix and match between debug and release versions for each project, or you're targeting a different platform for each project. So for example, right now we're set to run on any platform, but we can go specifically with the x86 platform or the 64-bit platform, specifically because we have code in our application that targets one of those platforms. And that's really an advanced topic, so I just want to ignore that option for now. Let's go ahead and just click out of that. And let's go ahead and just close this dialog, but we're going to go back here and select release. Now I want you to notice we're going to go back to our bin directory. And our bin directory has a release version. Somehow we actually created one. I didn't mean to do that. I'm going to go ahead and delete it. All right, so this is going to be a little anticlimactic because I've already created the release version and now I can't for some reason delete it. But what we want to do, if you haven't done this already, is select the release option and then choose build and then build solution, and that will create the release version of the application. And then when you open it up, you might notice that, well, there's a lot of files in there. I thought we were going to build a smaller, more compact, concise version of this assembly. Well, the truth of the matter is that in these simple examples in the console window, the output is going to be identical between the release and the debug version. When you get into advanced scenarios, however, you have the option as a developer to conditionally compile certain code based on the configuration that you've chosen. So how and why you'd want to do that is more of an advanced topic. Just be aware of the difference between the debug and the release version for now. Okay, so in this lesson we covered quite a bit of ground, right? Let's recap it just really briefly. We talked first of all about the code that we wrote in the previous lesson. First, we talked about the organization of the code, how code is organized within code blocks. So we added code to a sub-procedure code block called main, right here, all right? And that's executed automatically whenever a user runs the application. It has a special function within Visual Basic. We learned how related sub-procedures should be organized into modules. Similarly, through our use of the .NET Framework class library, we saw how methods like WriteLine and ReadLine are organized into classes. And so we used methods written by Microsoft to work with the console window. In fact, both of the methods that we worked with, the ReadLine and the WriteLine methods, were organized into the console class. We accessed that functionality, and we accessed the console class by using its name, console, then using its methods by first choosing the period as the member access operator, and then selected the member, the method that we wanted to use from that class. So we also, in our first line of code, we passed a literal string hello world enclosed in double quotation marks, which makes it a literal string, and we understood what a string was. It was just a collection of alphanumeric characters that were grouped together. We passed it as an argument to the WriteLine method. Now, we don't care how the WriteLine method actually works its magic. We just care that it can display in a console window whatever we tell it we want, okay? And we talked about the syntax of Visual Basic, specifically how we can only add one Visual Basic statement per line of code. We also talked about the lines and the spacing and indentation. These don't affect the code per se, however, they make it easier for we as humans to read and understand. Likewise, we noted how the IDE's code editor will color certain code to further assist in the readability of that code. We used the Solution Explorer here to understand the organization of our code. We talked about projects as a means of collecting files and other settings together that will be required to generate a compiled .NET assembly. And we briefly explained how multiple projects can be assembled into a solution. So that solution is the umbrella, but we said we don't want to talk about that just now because it's a little bit more of an advanced topic. Finally, we talked about where you can find all the files for your project, as well as the folder structure for the compiled versions of the .NET assembly debug version and the release version. So the good news is that we're finished with a lot of the tedious parts of learning .NET. At least from a practical perspective. You're well on your way to learning .NET now, and so now that we've sucked you in, you got to continue on. We'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. So in this lesson, I want to spend a little time investigating some of the additional features of Visual Studio. You know, in order to be productive, you're going to need to know a little bit about how to maneuver around inside of Visual Studio. So what I'm going to do in this lesson is simply highlight a few of the major features, but we're going to cover more throughout the remainder of the series. So in this lesson, I want to demonstrate how to open up a project that you've closed, how to set breakpoints and step through your application's source code line by line to watch it execute, and potentially discover problems in your code or help understand why certain conditions are happening. I'm going to explain the benefit of IntelliSense in the code window, how to customize the IDE's interface, code rollup features, and a whole lot more. All right, so let's go ahead and get started. You can see that I've started this lesson with Visual Studio closed. So if you haven't already done so, go ahead and close Visual Studio so you can follow along. You're going to need to know how to get back into projects that you've saved previously that you were working on. So whenever you open up the Visual Studio IDE, you can access your projects in one of several different ways. You can use the start page here that you see by default at startup in order to, for example, create a new project, and you can see that link here in the left-hand column. You can open an existing project or to get to the open project dialog, or you can use this recent list and it'll show all the recent applications that you've worked on or that you've opened up. There's also in the file menu a way to open a project, or we'll choose this one at the very bottom, recent projects and solutions. I'm going to go ahead and select the hello world.sln project. We've already seen where it's stored on our hard drive. I'm going to select it to open it up so that we can continue working on it. So there's a number of different windows and panes in the Visual Studio IDE. Some of them are hidden by default. For example, if you hover your mouse cursor, actually click on the toolbox, I guess it's spelled vertically along the left-hand column, you can see that the toolbox pops open, and we'll talk about it in just a moment. But if you click the little thumbtack, you can see that auto hide is currently turned off. If we click the thumbtack, it changes its state from like this to that. That means it's pinned down and that now it doesn't just auto hide. If we turn it off, you can see that it disappears. I'll activate it, but then when I click away, it goes away again. All right, so if I open it up one more time, you'll see this is typically one of the typical configurations of Visual Studio. Now, if you've been following along in the videos up to now, in the previous lessons, we've noted some of the major areas. For example, here's this toolbox area. The main area typically houses the code window where we actually type in the code. And it also will house different things like the property editor, other designer and property windows will be displayed here in this main area as well. We've already taken a look at the Solution Explorer. Below that is the Properties window, where we'll actually change attributes of things in our project, whether it be something visual like a button that we drag and drop from the toolbox onto our designer surface to create a Windows form, and we'll want to change maybe the text inside of it. We would change it here in this Properties window, or as we'll do later on, we may want to select a file and make some changes to it here in the Properties window. But whatever's currently the selection, the Properties window can act on that selection from within the rest of the IDE. All right, and then obviously we have our toolbar and menu here at the very top, and then at the very bottom there will be some information. For example, when I put my mouse cursor in the code editor, you can see that we have, for example, what line we're currently on, the column, which character, and whether we're insertion mode or not. And then a little ready message here on the left-hand side. So if there's some long-running process in Visual Studio, it'll give you an update on what it's currently doing in that lower left-hand corner. All right. Let's talk about this toolbox for just a quick second here. Console applications rarely have a use for the toolbox and the properties window for that matter. They're more suited for creating and working with project types that are used to create graphical user interfaces like Windows applications or web applications. In those scenarios, and we'll do this near the very end of the series, you drag and drop controls like visual controls like buttons and text boxes and combo boxes and things of that nature from the toolbox onto the designer surface, and then again, having one of those selected in the main area, you can make changes to its various attributes in the properties window. So since this series only focuses on the Visual Basic Programming Language, we're not going to need a graphical user interface for most of the series, so I'm just going to go ahead and deselect the auto hide, and now it disappears and we won't use it again for most of the lessons in the series. Okay, so we also briefly looked at the error list that pops up whenever we encounter a problem while compiling our application. So we're already familiar with that window, but there's also other windows that we'll see pop up in different situations. For example, in just a moment, we're going to see some new windows that will appear near the bottom of Visual Studio whenever we're debugging our applications. There's a locals and a watch window and a few others that become available to us in certain contexts. So what are these contexts that I'm speaking of? Well, I'm talking about the different activities that we perform while we're constructing an application, while we're developing an application. For example, there's the design time context. It's the context that we're in right now, where we're actually writing code and designing our application. Now, whenever we click the Start button on the toolbar, the Start Debugging button on the toolbar, then we'll be in a new context called Debug Time, also known as Debug Mode. We're going to be running the application within the IDE, potentially stopping momentarily, watching the execution line by line of our application, observing the values of variables and objects like I'll demonstrate very soon. There's also compile time, and that context happens whenever we're actually compiling our applications. There are certain actions that are being performed by the Visual Basic compiler, and admittedly, it's a very short period of time relative to our design time and debug time. However, it's a very crucial context and moment in the lifespan of our, or in the development lifespan of our application. And so Visual Studio will display different sets of information, different sets of windows, depending on the given context that we're currently in. They're windows and different pieces of information that support the activities of the current context, whatever that might be. So let's go ahead and talk about one of the most important contexts beyond just typing in our code, which is debugging our code. So one of the most important features of the IDE is the ability to help you find problems with the code that you've written. So there's several different ways that this is accomplished. You'll recall that when we typed in code incorrectly, for example, and we'll do this again in a moment, that Visual Studio will alert us to the fact that there's issues in our code. And we can see the blue squiggly line, the little red X. We'll come back to all that in just a moment. However, to begin this debugging process, say, for example, that there was a problem that the compiler couldn't catch, that it compiles correctly, but at runtime something's just not working quite right. We might want to set a breakpoint on a line of code, and our code will execute up into that point, and then it stops and allows us to take over the execution of the code and observe what's going on inside of the application, almost like X-ray goggles. Okay, and so let's go ahead and do that. We're going to set a breakpoint on this line of code, our console.write line, and the easiest way to set a breakpoint, as far as I'm concerned, is you click in the leftmost column next to, in this case, line number 5. And when I do that, notice that a little red dot appears in that gray column, that leftmost column, and then the entire line is highlighted in red as well. And so if you follow along in this series, there's a chance that you're still going to be in release configuration. Make sure that you change that to debug configuration here in the toolbar. And once you've made that change, then let's go ahead and click the Start button. So we're going to start debugging. All right, so you can see that the IDE is currently in debug mode because the toolbar has changed dramatically to include the process name, so the Windows process, hello-world.vshost.exe, and there's also additional information that shows up here at debug time. There's also a yellow highlight where the breakpoint was set. So the yellow highlighted line indicates that this line will be the next line of code to be executed. And then also we can tell that we're currently in debug mode, or we're in debug time because of the windows that appear at the very bottom of the Visual Studio IDE. So there's this locals window that'll show the value of variables and objects that are within the local scope. I'm sure that meant nothing to you, but it will as you continue in the series. There's a watch window where we copy and paste certain variables, specific ones that we're interested in keeping tabs on and observing throughout the execution of our application. There's also this call stack and immediate window, which we won't talk about much, but are also crucial to the debugging process. So now if I want to step through each line of code line by line, all I need is to either use the keyboard shortcut or one of these 3 icons at the very top. So from left to right, you have the step into, the step over, or the step out. Now for our purposes, we just need the middle button or the F10 key on the keyboard to step over this line of code. All right, so I'm going to go ahead and click the step over button, and you can see when I do that, the line of code that was currently highlighted in yellow executes, and the next line of code is highlighted. So if we were to take a look at the console window right now, which is hidden by Visual Studio, and I did that by selecting it in the taskbar here, you can see that it successfully printed the words "Hello World" to the window. So back in Visual Studio, we can see that the next line of code to execute is the console.read line. It hasn't executed this yet. It's about ready to as soon as we give it the OK, as soon as we click F10 or this step over button on our toolbar. So at this point, I can either click the step over button one more time, or the F10 key on my keyboard, or I can click the start button. It's changed names now. It's called the continue button to continue executing. So I'm just going to click that, and you can see now the console window pops open What is it waiting for? Well, it's waiting for the application to execute because it's actually executed that line of code to read line. It's waiting for user input. Now I can hit the enter key on my keyboard and it exits out of the execution path. So we're back in design time, all right, and back into development time where we're actually writing code. Now, again, I think I showed this a little bit earlier. While we're in debug mode or debug time, I can also click the stop debugging button to actually stop the execution, and we're back into design time. All right. So now that we're done with this breakpoint, we've kind of illustrated everything we need to talk about for now. There's a couple of different ways to remove the breakpoint. I can either click the button in the left-hand column, the little red dot, or making sure that my mouse cursor is on the line of code that I want to remove. I could also hit the F9 key on my keyboard, or I can go to the debug menu and select toggle breakpoint, which will turn it on or off. All right, so a couple different ways to accomplish that. All right, so moving on, let's talk about code comments. Several times throughout this series, I'm going to comment out some code, a line of code, and replace it with a different line of code. Or I'm going to create a line of English text that I don't want the compiler to consider while it's compiling the code into a .NET assembly. I just want to leave it as a note to self, all right, a to-do item maybe. And so to do this, what I'm going to do is just use the single quote on the keyboard. It's the character underneath the double quote. On my keyboard, it's next to the enter key, all right? So once I type that, I can type anything in a code comment, and it won't be compiled into my source code, into the .NET assembly, all right? Another way that I can do it, if I needed to comment out multiple lines of code, is to select multiple lines and then select this comment out selected lines button on my toolbar to comment out everything that I want to in one fell swoop. Or I can select those lines of code that I want to uncomment out and make them, again, active by selecting the button that's right next to it, the uncomment the selected lines, and now you can see that they are recognized again by the IDE as being real lines of code. All right, so it's more convenient, I think, to just go down the line in some cases and just add comments that way, but you can choose either method. Okay, so now that we're talking about the code window, let's talk about IntelliSense. You'll recall that as we were typing that first line of code, let's go ahead and duplicate what we were doing. As I was typing, this little window popped up underneath what I was typing with filtering out the different classes or options that I could type next in a little window called IntelliSense. And after you master it, it can change the way that you write code. You can write it much more quickly, and it helps you to remember what it is that you need to type next in some cases. You can type more accurately because you're not typing out the entire word. So first of all, it lets you know which options are available to you contextually. So in this situation, what could I possibly type next? Well, it gives you all the options that in this case start with CONS, all right? And in this case, as I keep typing letters, it's going to help me find the console class. And then, now that I've found what I'm looking for, I can just hit the next logical part of what I need. In this case, I know that I'm going to need the dot operator because I want to go console dot write line. Now, when I hit the dot on my keyboard, notice that it finishes typing console for me and it types it correctly. Now, let's say, for example, I just type in 3 letters con. It doesn't put me in the right spot. It wants to create a const or a constant, and I don't want that. But I'm not sure exactly the spelling of what it is that I need. I can use the up and down arrow keys on my keyboard to find console, and then once I've highlighted it in the IntelliSense window, I can hit the dot or whatever would logically come next, whether it be a parenthesis, a space, whatever the case might be, and it will type out the rest of it for me. Pretty awesome. Not only that, but then it shows me all of the members of the console class. So in this case, readline is a common selection, but I want to use my down arrows to look for writeline. Now, if there are too many selections left, I can filter that list by typing WR, and now it's shortened that list to just 2 possible options, write or writeline. And there's another thing that I want to I want to point out here is that Visual Basic has a special feature that you don't find in C#, for example, in so much that they give you a common list, not necessarily all the options at this point. So if you were to click the little all underneath this, it will show you, in this case might be kind of a bad, because there's not that many things to choose from, but it'll show you more options if you choose all, but in common it'll filter them down even more to those that are common in this situation in Visual Basic based on what you've probably done in the past recently. Okay, so it's a neat feature to help you reduce down the complexity and only see those things that make sense in this context. So I can do right line like so. And then one last time, Visual Studio's IntelliSense will give you another window. In this case, remember how we typed in hello world in double quotes because we wanted to pass that literal string in as an argument, as an input parameter, which we'll talk about later, to the right line method? Well, in this case, there's a little, as we have our mouse cursor, our caret, between the opening and closing curly braces, it's going to tell us what we can type here. Now, at this point, it might not make a lot of sense, but as we continue through this series of lessons, you'll find this very helpful. So, for example, I can pass in nothing to the right line method and essentially get an empty line, or I can pass in a Boolean data type, which is a true false, a char or a character, so one letter or alphanumeric character at a time, a string of characters, a decimal value, which is like a monetary value, a double, and I can find keep going until I find strings. So this is one version of the right line method that I want to use for my application. But you can see here that it gives you a little explanation of what that method does, and also below it, what does it expect as an input value for this version of the method. I realize this means nothing to you. I'm just highlighting what IntelliSense will do for you. And so as we continue through this series of lessons, I'm going to point out to you that IntelliSense is explaining to us what we can do next and how that's helpful for us as software developers. All right, let's go ahead and just get rid of that. So with IntelliSense, I rarely type more than just a couple of letters, find what I'm looking for, and then hit either the space bar or the period or a parenthesis and let it type the rest. So I can type very quickly, and I will sometimes for longer passages of code throughout this series. But it also helps me type accurately because I'm not relying on myself to fat finger something. I just let Visual Studio type the rest of it for me. And once you get used to it, it's very effective. Now you see these little helpful windows pop open several times in the code window, in fact, even when you're not typing. For example, if I were to hover my mouse cursor over or just put my mouse cursor on a given method name or class name or keyword, I will get these little windows that pop up and explain what it is that I'm currently hovered over. All right, so that can be helpful in some cases as I'm inspecting the code. And finally, with regard to the code editor, it'll give you different types of clues as to what could be wrong with your code. We've already seen this, but if I were to remove the first double quote in hello world and moved kind of away from that line, you can see that it puts two blue squiggly lines under hello and world. And then under the O in hello, if I hover my mouse cursor over it, you can see a red X icon appears. If I click on that red X icon, a little context menu will appear. And it will ask me, would you like to do this? Would you like to try that? Would you like to try something else? We could possibly resolve this for you. Unfortunately, in this simple example, in this case, none of these are going to be the right solution for us. However, in some cases, it can be extremely helpful. And we'll see how that manifests itself a little bit later when we use it to add an import statement. Again, much later on. All right, so let's go ahead and put that double quote back in the right spot and watch those blue squiggly lines disappear. And they do. Great. Visual Studio is highly customizable. There are two configurations that we're actually going to modify in this lesson. But feel free to customize the environment to your liking so that you can feel productive. Whenever you encounter some annoyance, something that doesn't feel quite right as you're typing or working in Visual Studio, chances are you can probably change that default behavior somehow. So again, in this video, we're going to make two modifications. The first thing that we're going to do is turn on line numbering. Now you might say, well, Bob, you already have line numbering turned on. That's correct. I have line numbering turned on because when I logged in as my sub, you can see my name here, and that I'm currently signed in, it downloaded my preferences from previous installs of Visual Studio. It knew that I like to have the line numbers turned on, and it also set the size of my fonts. It would have set the background colors and all sorts of things too, had I used that normally or in the previously as I used Visual Studio. So if you want to turn on line numbering for Visual Studio so you can follow along with me and I can say, hey, look in line 5 and you look in your line 5, then the way that you do that is you go to the Tools menu and you select Options, the Options sub-menu item at the very bottom, and it'll pop open the Options dialog. And you can see there are quite a few tabs listed on the left. They're actually embedded in some cases. You can kind of drill down to get even more options within these higher level ones. But if you take a look at, and we scroll down and go to the text editor and select basic, you can see that I have line numbers currently turned on. So if I were to deselect that, or if you were to choose it, either way it's going to affect that left column where we saw those line numbers. Let's go ahead and turn that back on. So I'd like to have my line numbers always turned on. And so I'll select it now and hit OK, and they should appear again, and they do. Now let's do this. Let's go to Tools Options, and I'm going to go up to Environment, Fonts, and Colors, and this time what we'll do is change the foreground and the background. You can already see that I've set the font size to 16. If you want to set your font size a little bit higher, because in some screens those little tiny fonts after a long day of coding can be a little bit rough to see on old eyes like mine, feel free to change the size. For now, all we're going to do though is change from the default foreground, which was black, to white, and the item background from which was automatically white, we'll change that to black, and I'll click OK. And now we've inverted the colors for the most part. And we could go in and change all of the colors for things like that royal blue color or that green color or that red color if we really wanted to customize it. In fact, some people have done that and created these themes. You can download a theme and apply it, and some of those themes they claim are easier on the eyes or they help things stand out. I kind of just prefer the original color scheme, honestly. I would prefer to set this back to the automatic colors and click OK, and we're kind of back where we started from. Okay, but feel free to do whatever you want to. I want to talk about the code rollup feature in the code editor. It allows us to show and hide passages of code, or rather show and hide code blocks. The reason for this is to reduce the clutter as we search through our code that we've written. Now, in this short example, we've only got like 6 lines of code, but what if we had thousands of lines of code? Sometimes it's helpful to make a comment and then roll up a given passage of code or block of code so that we can kind of get it out of our way and quickly scan through our code, open up, make a change, close it back up, and then save the file off. And it's just an easy way to navigate. So if you take a look here, there's a little minus sign next to sub in the sub main, and when I click that, notice that now it's rolled everything up from line 3 to line 9. So we go from 3 to line 10. And inside of there, we can see that submain is now kind of grayed out. As I hover my mouse cursor over it, a little window pops up which shows me all of the code that has been rolled up and hidden from view currently. Very neat. And I can do this actually one more time at the higher level code block, which is the module. And so by doing that, I hover my mouse cursor over, I can see both the module declaration and submain and all the code inside. So again, this helps us to clean up visually our code and be able to scan through it very quickly at a high level and see what's inside of certain code blocks without actually having to scroll through pages and pages of code for a given file. All right, let's talk about code state for a moment. You'll see here that there's a little asterisk next to the name module1.vb in the tab in the main area. And that little asterisk means that we have changes to this file that need to be saved. Also, if you take a look at this little yellow line along from lines 4 to 7 in my case, that also indicates that these are the lines of code that have not been saved since the last time that we've made changes and saved them. All right, so to remedy this, I'll click the Save All button on my toolbar, and notice that the little asterisk goes away and that yellow line turns into a green line. So now I'm going to close down this tab. I want to remove it from the main area, and I want to then go to the Solution Explorer and double click and open it back up. Now you see that there are no bars down this column next, kind of in between our numbers and the little roll up area here. But if I were to, for example, just add one more enter key on my keyboard, it has made changes to the file and the little yellow space appears again, and I can save that, and you can see it changes its state back. So it's either going to be, there's going to be nothing there, or it's going to be yellow because changes need to be saved, or green because you just saved some changes to these lines of code. All right, and that's about all for this lesson. I went through things very quickly, but hopefully you can see how these little visual cues, these little windows that pop up, the layout of Visual Studio in general, really help you as you're developing to get all the information you need and to access the operations that will allow you to build applications more correctly, to fix problems in the application, to do things that are appropriate given the current activity you're undertaking, those contexts that we talked about. And so hopefully you've learned enough to navigate through Visual Studio, to be comfortable with Visual Studio, and you'll learn more as we go throughout this series. So you're doing great. Hang in there. We're going to see you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. So in this lesson, we're going to get back into the Visual Basic Programming language itself, and we're going to talk about variables and data types, declaring variables, converting or casting from one data type to another, and so on. So you've probably, at some point in your life, you've seen a simple algebra problem like this. 5 plus 7 equals x. Now, without a lot of thought, you can obviously figure out what the answer is. How do you solve for x? What's the answer? Well, using that same thought process, take a look at this Visual Basic code. X equals 7, y equals x plus 3, console.writeLine y. So what would you expect to be displayed in the console window? Well, the value 10, right? Well, you just read Visual Basic on your own without my help. It's just common sense, right? Now, honestly, there's probably a little bit more to it than just that. But let's start with this and move on from there. First of all, in this context, x and y are called variables. And a variable is simply a bucket in the computer's memory that will hold or contain a value. You can put stuff into the bucket, you can read things out of the bucket, or rather out of the variable. You can put new stuff in the variable, new stuff in the bucket to cover up the old stuff. So in this case, these buckets are just holding numeric values, but you can create buckets that are just the right size to hold dates and times, or strings like long passages of text like hello world, or really big numbers, or numbers that are after the decimal point, and a lot more. So in the case of our little code snippet here, we would expect both x and y to hold numeric values. Now we know that, but we have to use the Visual Basic language to express this to the compiler in the .NET Framework runtime. So remember, the runtime is what does the hard work of managing the execution of our application, and part of its responsibilities is allocating memory in the computer for our data. So here we have two data items, and we have to tell the runtime to allocate some space in memory large enough, two buckets in memory large enough to hold these numeric values. So let's begin by creating a new application to learn a little bit more about variables. We're going to write a little code, then we'll break it down and explain what's going on, then we'll add a little bit more to it after that. But as we move forward in this lesson, the big takeaway is that a variable is simply a bucket, my terminology, a bucket in the computer's memory that you can put data into and retrieve data out of, as long as the application is running. So let's do this. We're going to create a new project. There's several different ways to do this. I'm going to just select a new project on the start page, which will open up the new project dialog. And what we want to do is call this variables and click OK. And so I'm going to begin typing in some code. What I want you to do is to follow along. So if you don't already have Visual Studio Express 2013 for Windows Desktop open, please open it up right now. And this is really important. Watching a screencast tutorial is different than watching a sitcom or a sci-fi movie. You need to be an active learner. The only way you're really going to learn how to code is to actually get your hands dirty writing the code yourself. So follow along with me and actually type in the code. It'll help build muscle memory. Pause, rewind the video, watch it a couple of times if you have to, but make sure that you follow along. It's the best way to learn. And then the second thing I want to say is that the same rules apply here that applied in that second or third video where we created the Hello World application originally. You have to type it in exactly. If you don't, you're going to experience some errors. You're going to see those little blue squiggly lines appear. So you'll try to run the application, it won't work. You'll be like, oh my goodness, what do I do? It's broken, I can't figure it out. Well, look at the error messages. Make sure, compare what I've done with what you've done, and make sure every single character is right. Several times, almost daily, somebody says, Bob, I did exactly what you did. I watched your video and I did it myself and it doesn't work. What do I do now? And I don't know of a nice way to say this, but if it worked for me, I didn't edit this magically or whatever, and it didn't work for you, then you did something wrong. So double, triple check if you have to. Make sure you got it exactly the way that I have it if you want to get the same results that I have on screen, okay? But if you get stuck, let me know. I'll try to help you out, okay? So, all right, here we go. We're going to type in the following code. Make sure you're in between, your mouse cursor or your text cursor is in between the sub main and the end sub. And I'm going to stop talking and start typing. Okay, so let's talk about what this code is doing. The first two lines of code here in lines number 5 and 6 are where we declare our variable. So to borrow from the explanation earlier in this lesson, we're asking the .NET Runtime to allocate a space in the computer's sufficiently large enough to store numeric values. We'll have a value called X and a value called Y. So we're asking it to create two buckets that will hold these numeric values that we're going to eventually drop into them. So after we've created these buckets, or rather we have dimensioned these variables, we can begin to assign values into those variables. And most importantly, you can see that I've described the type of data I expect to put into those variables, X and Y. I'm using the word integer. So first of all, dim is a shortened term for dimension. You dimension a variable. In other words, you provide the dimensions or the size and the width, okay, of the new variable, and you're telling that to the .NET Framework so it knows how big of a space in memory to create for the data that you're going to put inside of it. And there are many terms to describe this process, including declaring your variables or to create a variable. I use all these terms synonymously, but Visual Basic uses the term dim to dimension a variable. So the next part, or the last part, is the as integer part. It's the data type. So part of dimensioning a variable is to tell the .NET Runtime how much room in memory to reserve for this new variable. So in this case, an integer is a mathematical term that refers to a pretty big number that has no fractions or decimal values. So it can contain numbers between negative 2,147,000,000 to a positive 2,147,000,000. So if you need a larger number than that, there are other data types that you can use, and it'll create a bigger bucket in the computer's memory to store those types of values. But this is where we tell the .NET Runtime what the size of the data we expect to use is. And integer, there are smaller ones, but this is usually a standard. I don't want to go into the reasons why, but it's a common data type to use, even if you're only going to use like 7 and 3 and not 2 billion, okay? So there are many different data types. There are simple data types, complex data types, and later on you're going to be creating your own custom data types as well. But because I don't want you to be overwhelmed at first here, let's just keep it simple for a moment. We're going to talk about just the integer data type, and then we'll talk about the string data type in a little while. Next up, after we've declared these variables in lines 5 and 6, and we've given them names that we want to call them by. So the first variable is x. That region in memory, that bucket in memory, I'm going to call that one x. This bucket in memory, I'm going to call that one y. So now in code, whenever I want to refer to my variables, I'll just call them by name, x and y. So next in lines number 8 and 9 is where I actually assign values to those variables. So I can access them by just calling their name. So x equals 7. I'm taking the number 7 and I'm assigning it in memory to the value x. And then I'm going to read that value back out. What is x? It's 7. I'm going to add 3 to it. I'm going to assign that into the variable y. And then finally, I'm going to say, what is the value of y again? It's 10. I'm going to print that to screen using console.writeLine. Okay, so the equal sign is the assignment operator in Visual Basic. So in English, that line of code, we're basically saying in line number 8, set the integer called x to the value 7. All right, pretty easy. So let's go ahead and see if this will actually work. And it does. We simply print the number 10 to screen. Okay. So let's click the Save All button on the toolbar. Save our changes. And since we're going to make a number of small examples here, we need to comment out the work that we've just done. So I'm actually going to remove this space. I'm going to add a space here. I'm going to select all of this code, and I'm going to use this comment out button that we learned about in the previous lesson. Make some more space for myself here. And just as a side note, I want to leave this code here. I could completely delete it from this project, but I'm leaving it here for you to reference. If you wanted to download the code that's associated with this video from wherever you originally downloaded it from or where you're currently streaming it from, it'll be available. And so I usually leave this code for you, but often I take this approach as well whenever I'm writing code. I'll comment out some old code that I've been working on, and I want to keep it around for reference while I'm writing some new code to replace it. And then after I'm 100% sure that this code absolutely works, I can go back and I can delete the old code. So this is just one of the little habits that you develop over time when you make some mistakes and like, what was I? You're writing code, somebody comes to your cubicle, you start talking with them, and you're like, what did I just do? What did I delete? Oh no, I got to start all over from scratch again. Okay, so you develop these little habits over time, and it's a habit that I would encourage you to get into as well. Don't delete things right off the bat. Comment them out first, rewrite. Once you're convinced that it works, delete the old code. All right. Okay, so let's create another example, but this time let's work with a different data type. So let's do this. Okay, so notice that we're using the as string this time as opposed to as integer. String is the key word for creating a bucket in the computer's memory that can hold textual information, alphanumeric characters. Also notice that I can name my variables anything I want to within certain limits. So as a convention, because most programmers do this, I use a lowercase m to begin, or a lowercase letter to begin the name of the variable. So my first name, okay, followed by, so I use the lowercase m, capital F, capital N, so capitalize each additional word after that. So this is called camel casing, and you should get into practice of doing this as well because many developers name their variables this way. So for now, let's just use strings and integers, but there are probably, again, another dozen different data types that we'll want to know eventually and we'll use throughout this series. So now let's go ahead and run our application, and you can see it simply prints Bob in the console window. So at this point, our code example is just a glorified variation on the Hello World application that we wrote back in lesson number 3. The only difference is that we've introduced a variable to hold that literal string, in this case Bob, as opposed to the literal string directly that we passed to the console write line like we did in the Hello World example. All right. So one more thing that I want to point out, you can actually condense your code from this, and let me rewrite this a little bit more succinctly. All right, so here we're both declaring the variable and then initializing its value all in one line of code. All right, so experienced developers like to write less code. So they're always looking for a convenient way to reduce the number of keystrokes that they have to type and reduce the amount of code that they need to look at and understand. And so you should get into that practice as well. Now, using one of the techniques that we learned earlier, let's go ahead and comment out the code that we were just working with here. Go ahead and comment that out. Now, starting in Visual Basic 2008, I can even shorten that further to what you see now. I guess I could have just done this. Like so. All right. So make sure whatever you end up with, it looks like this. All right. The idea is this. The Visual Basic compiler is smart enough to see that you're initializing the new variable to contain a literal string. So why not just let the computer figure that out, the compiler to figure that out? It's important to know that in this case, the variable my first name is of data type string. It's not an unknown data type. Once we declare my first name like we've done right here, from that point on, my first name can only contain strings. It can't contain numbers or dates or anything else. All right. Just be aware that this is an even shorter way that you can now write you can now declare variables by implying what the data type is by what you initialize the variable to contain, as long as you do it in one line of code. All right. So what happens if we were to do this? Let's just comment out everything after the dim first name. What happens in this particular case when we don't give it a data type like string, and we don't give it an initial value like equals Bob? So in this case, you will not get an error message. Instead, you just created a variable of type object, which is the most generic data type in Visual Basic. It can hold anything. However, this is a horrible idea because it gets around the comfortable restraint of using a strongly typed programming language. Well, you might think, what? I can store anything I want in there. However, I assure you that what seems to be freedom is actually a noose because it'll lead you to errors that are difficult to track down. Trust me, stick with defining your variables with actual data types or initializing their values at the outset like we just did a moment ago, and stay away from object for now as much as possible. All right, so let's go ahead and get rid of this because I don't want you to even try that. Okay, so I want to comment out these two lines of code now, and we'll continue on from there. All right, so let's do this. Dim x. Okay, so let's walk through this. We have dim x is integer equals 7, dim y is string equals Bob, and so we have a numeric value and a string, which can be alphanumeric, and then we're going to create a new variable called myFirstTry. It'll be of type string, and then we're going to initialize it to x ampersand y. So this ampersand character is a string concatenation character, meaning that it'll take two strings and put them next to each other, all right, and it will make a new string out of it. All right, so in this case we would expect it would myFirstTry to contain 7 Bob, no spaces, all one word, I guess you could say. All right, so what we're doing here though is we're implicitly converting this data from integer into a string by, well, we're just implicitly doing it. We're not explicitly saying you should be a string now. We're saying that whenever we're using the number 7, but we're using this ampersand, which is a string concatenation character, and we've already declared myFirstTry a string, which will be the result of concatenating a string to an integer. The .NET Framework knows that, well, I guess I can take a 7 and I can make it an alphanumeric. I can make it into a string. I mean, I don't have to treat it like a numeric value that you can add and subtract and do those sorts of things with. So I guess I'll go ahead and implicitly convert it, and I won't raise any red flags. I won't complain. We'll just let it happen. So first of all, let's make sure this works. It does. So we see 7 Bob on the screen. So that is an implicit data conversion. There are certain data types that can be easily coerced or converted into another data type that's a little more forgiving and open, like a string is. Alphanumeric, it can handle just about anything. It can handle a date and time. It can handle entire paragraphs, numbers. Why? Because it's just a collection of individual alphanumeric characters, all kind of put together to look like a date or a number or a paragraph or whatever the case might be. However, some conversions are not possible, and we'll talk about that in just a moment. Now, what's really going on behind the scenes, I guess, is that we're taking x.toString, and after we have converted x to a string, we're concatenating y to it. And you might be like, wait a second, whoa, where did that .toString come from? Well, most data types, even simple data types like the integer in the .NET framework, have methods defined that perform some basic tasks like type conversion, like you see here. So as a result of declaring a variable to be an integer data type, we get a bunch of add-on features for free, whether we need them or not. They're kind of like baked into our variables. We'll talk about that more later. But you got to admit that's pretty cool, right? That you can just say, here's my variable name, dot something, and have it perform some cool tasks. And we'll see a lot of examples of that throughout the series. So don't be surprised if we do a dot, to upper in this case, and now look at what happens. 7 capital B-O-B, all right? Ignore I did that. We'll come back to upper later. Okay. So we can rely on .NET to perform implicit conversions of the data. However, I recommend against this. You should never rely on implicit data conversions. I encourage you to always take control of your code and explicitly perform conversions. Otherwise, you're likely to introduce subtle, hard to find bugs in your applications. So what I would recommend that you do with this line of code is probably get rid of this and use something that's a little more Visual Basic friendly, CSTR, which is convert this number into a string and then append this other string to it. And let's make sure that still works. And it does. It's just more expressive using the Visual Basic language with this built-in method called CSTR, convert to string, okay? All right, so let's do this. I'm going to comment out this line of code. And I'm actually going to comment out this line of code. And below it, I'm going to do this. All right, so let's start debugging the application, and we get an invalid cast exception occurred. And it says conversion from string Bob to type double is not valid. All right, so what happened? Well, in this case, you can see that my second try should be of type integer. We know we're going to take the value of x, which is an integer, and we're going to use the plus symbol, which is the addition operator. So we want to add numbers together. We want to add 7 plus another number, but we don't have a number here. We have a variable which is of type string, and it can't easily be converted into a numeric value because it's set to Bob. So I could try something like cint. Cint would be kind of the equivalent of the CSTR. Convert this string into an integer, all right? However, even at that, if I try to run the application, I'm still going to get the error that conversion from string Bob to type integers is not valid, all right? But that's perfectly understandable. So On the plus side, we have taken control of trying to explicitly convert our data types. On the downside, this scenario will never work because Bob can never be converted into an integer value. But we can do something like this, where we take dim y as integer, and set that equal to 5. And then rerun our application, and it will work just fine. All right. So we saw the number 12. What if we were to go back to this example here and see if we could implicitly convert those two numbers together? They are of value 7, 5. Not 75 because it's not numeric. It's just 7 and 5, and they're concatenated together and put next to each other. Okay. All right. So I strongly recommend that you do not rely on implicit data conversion. Some people would even call it evil type conversion. All right. So instead, take control of the conversion and be purposeful in the code that you write. You'll experience fewer defects in the software you write if you do not depend on the .NET runtime to handle these types of situations for you. Instead, you should use those two built-in Visual Basic helper methods that we demonstrated in this lesson. CINT or CINT will convert a string into an integer, and we could actually achieve the same thing with a built-in .NET function called integer.parse. All right, but I would recommend that you use the Visual Basic CINT instead. All right, so I'm just going to go ahead and delete that. You might see it used, and then use CSTR like we used here in order to convert an integer or some numeric value into a string. So it performs the same action as that toString that I talked about a little bit earlier that's baked into the .NET framework. Okay, so the key idea in this lesson is how to declare, initialize, and then work with variables and data types. In the .NET framework, even simple data types like string and integer have some powerful helper methods that are kind of baked in or built in to convert one data type into another data type whenever you need that functionality. However, from a stylistic perspective, I recommend that you use the built-in Visual Basic helper methods like CSTR or CINT, and there are others like them, in order to perform these explicit data types. But hopefully you understand the need for data conversion, how sometimes data conversion can be performed for you implicitly, but why that's sometimes a bad idea to rely on that. All right, so you should attempt to never rely merely on implicit data conversions whenever you're working with different data types. Take matters into your own hands and convert them explicitly. Okay, so we talked about a lot in this lesson. If you've got all that, you're doing great. We'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. So in this lesson, things start to get a little bit more interesting. First off, I'm going to demonstrate how to accept input from a Windows console application. Then based on the user's input, we're going to write some logic to execute different blocks of code. And I'll demonstrate two different ways in Visual Basic to accomplish this. But let's get started by creating a new project. I'm going to show you a different way to do this. We'll go File, New Project. And from the New Project dialog, I want to make sure to select the Visual Basic console application. We'll call this Decisions and click OK. And now I'm going to type in the following code, so make sure you follow along. All right, I'll go ahead and move that, and I'll auto hide that as well so you can see everything. Great. All right, so the key to this example is in line number 7, user value equals console.readline. So previously we've used console.readline to stop the execution of the Windows console application so we can actually see what gets the results before they flash on screen and then go away as the program executes throughout the remainder of the program, and the console window is no longer visible. However, you can see that in line number 7. This time, we're using this line of code so that we can retrieve the value that a user types into the console window. And then next in line number 8, we're merely concatenating or appending a literal string, you typed, colon, to whatever value that the user actually typed in and that we've retrieved in line number 7. So let's go ahead and start debugging the application to see it in action. It says type something and press enter. Well, as a literalist, I will type something and then press the enter key on my keyboard, and it said you typed something. All right. So we're going to use this technique to add logic to our application. Now that we know we can retrieve a value from a user, we're going to now evaluate that and then branch. Either this code will execute or that code will execute depending on whatever the user types in. And we'll do this in stages, so this might take a little bit of time to kind of see through, but I'm going to select everything first of all, and I'm going to select the comment out the selected lines, and we'll start over below it. And so here, follow along as we create the second example. And there we go. Okay. So first of all, take a moment to just look at what I've typed out here, or what you've typed out here, hopefully. Again, pause the video, rewind if necessary, but make sure that you're typing in these code examples too. And guess what's going on here and what you would expect to happen. So what does this code do? Well, whenever a user types in a value at the command prompt and presses the enter key, then we're going to evaluate whatever the user typed in. If the user typed in the alphanumeric character 1, then we're going to display a literal string using console.writeLine, you want a new car. So the most important lesson for our purposes in this example is the syntax of the if-then statement. It's called a decision statement because based on the condition that we set up, if it's true, if it is indeed true that user value is equal to 1, then we want to actually execute the block of code that's immediately below that condition. So in line number, looks like number 13, the statement begins with the keyword if. Next is the condition that'll be evaluated. User value equals 1. So we're evaluating the string username, or user value rather, that was retrieved from the console.read line. If that value is 1, then the next line of code will be executed, which calls that console.write line then in line number 14. So this is another reason why Visual Basic is beginner friendly. It reads like an English sentence. If user value is 1, then do this, all right? At least it's a little bit more user-friendly, or a little reads like English more so than other programming languages like C# or JavaScript. So the equal sign plays two roles in Visual Basic. We've already seen how we were able to do an assignment. For example, take a look in line number 12. Dim user value as string equals console.read line. So we are setting user value equal to whatever the user types in. We've seen it used previously where we set dim x as integer equals 7 or something along those lines, where we were setting the value of x to a value, so assignment. But here we're using it in a different context or in a different way. The second way that we use it is to determine equality. We're asking for an answer, true or false. User value is equal to 1. Is that true? If so, then perform this code block immediately under it in lines number 14 and 15. All right. Now, if that expression evaluates to false, what do you suppose will happen? Well, then the code block beneath the if statement is ignored, and what else comes After that, well, really nothing. We would expect the application to just exit out. So we'll start the application. What do you prefer? Would you prefer what's behind door 1, 2, or 3? So this first time I'm just going to type in something and the application automatically exits. Why is that? Because if this condition is not true, there's no other code that would stop it like we would expect to see in a read line. That's only in that scenario where we typed in the number 1. So let's go ahead and start the application again. This time we'll hit 1 on our keyboard and hit enter. You want a new car, program's paused, we hit enter again on our keyboard to continue executing, and then the console window goes away. All right. So the problem here is that we've only handled one possible outcome. If we don't enter that code block, then the application is free to exit by moving outside of the main method's code block. So let's expand our application, and in doing so, we're going to learn a little bit more about the if statement. So we want to revisit the main procedures code, and we want to make sure it matches what I'm going to type here on screen. All right, so there's a few items to take note of here. First of all, in lines number 16 and 19, you can see I use this else if statement, and it allows us to evaluate additional conditions. So while we could simply use individual if statements, we do an if, and if and if and if. This keeps everything kind of together and makes it obvious that we're still evaluating the same types of conditions, okay? So in line number 22, you can see I finally used the else statement by itself. If no other conditions are satisfied, then execute this block of code, what's below the else statement before the end if. So when you start the application this time and you enter a value other than the number 1, you should see a new message. For example, whenever we type the number 2, you want a new boat. Let's run it again. Type in door number 3, you want a new cat. Okay, and then let's finally do the number 4, and then it said, sorry, we didn't understand your response. You lose. Okay, great. Let's go ahead and exit out of that. All right, so I'm looking at this code, and something comes to mind here. Now, often, developers want to write concise code. So this often improves the readability when it's concise and when there's less code to actually look at. By removing extraneous characters that would draw our attention to them, or at least detract our attention from the things that are important. Also, developers have learned that if they find themselves writing the same code more than once, it might be a good idea to take a closer look at your code and see how you can refactor the code. So refactoring, that term, is kind of unique to software development. It's an advanced topic. Entire books have been written about it. It's about improving the quality of your code by applying some rules designed to improve its quality, one of which is to never repeat yourself. All right? And so this is a little bit of a... I guess I'm taking it to an extreme here by suggesting that we're going to be doing this massive refactoring. And however, I just wanted to point out the fact that generally when you're doing the same thing over and over and over, it's better to extract those things that are common and move them to a different part of your code, leaving what's different. All right, so let's do this. We can see that each block of code in our if and else if statements essentially have the same commands. We're console.writelining and we're console.readlining in each of those 3 situations, and even in the else statement too. We simply need to extract what's common, the console.writeline, the console.readline, and focus on what's different in each of those code blocks in order to make it a little bit more compact, a little more expressive. So let's rewrite this, it'll only take a moment, and make it smaller, more compact, and more expressive. So here's what we're going to do. We're going to introduce a new string variable. So dim message string equal to an empty string to start off with. And then what we're going to do all right. And now let me just make sure that this works before I brag about it. Okay, so look what we did here. In line number 14, I created a variable called message. And the intent is for that variable to be assigned whatever the ultimate message is we want to print to screen. And now each code block merely sets the value of that message accordingly. So in line number 42, or actually line number 26 here, we are merely printing to screen console.writeLine that message, and then we call the console.readLine once to pause execution. So making those changes, I've significantly cleaned up my code and made it clearer what the code is trying to accomplish, at least in my opinion. Of course, whenever I change the code, I want to test it to make sure that it's still working the way that I originally intended for it to. In this case, whenever I ran the application immediately after making those changes, it still seemed to work, at least with a brief test that I created. You'll notice that whenever I'm writing software, I write a little code and then I execute it to make sure it works. And then I write a little more code and then I execute it to make sure that it works. And I do this very often. I strongly recommend that you avoid writing long passages of code before you then test your work. Keep your additions small and tidy and test them before moving on. If you only write a few lines of code before testing, then you're more likely to remember what you just introduced to the application now that a bug has popped up or throws a new exception. Okay, well, I only changed these 3 lines of code, so it could only be one of these 3 things, right? So just take a look now at the if, then, else if, then, else if, then, else, end if, that structure, okay? And memorize that, including that evaluation operator. And there's other types of evaluations that we can use. We'll learn about them, I think, in the next lesson or the one after that. It's simply too fundamental to constantly be looking up with a cheat sheet or on MSDN. It needs to be as familiar to you as typing any combination of words that make up a sentence in English. You're only going to memorize it if you get your hands dirty and you write your own applications a lot, okay? So before we conclude this lesson, let's take a quick look at one more way to perform this if, then, else type of functionality. This is a shorthand syntax. It's a little bit more limiting, but it's short, okay? So when you just need a simple either or comparison, you can use this conditional if statement, IIF. And it not only works well in those scenarios, but it also kind of fits our write concise code advice. Okay, so what I'm going to do is actually select the entire if statement that we created. And actually, let me grab the right line of message, this if all the way down to the end if, and then the dim message as string. I'm going to comment all of that out using the comment out selected lines button on the keyboard, on the toolbar rather. And so that leaves us with lines 11 and 12 still intact. We're still going to use those. And I'm going to add the following code. Dim message string equals if user value equals 1 car cat. All right, that looks odd, I know. We'll come back to it. So then console.writeLine All right, so here we're going to type in U1A, and then I'm going to do an open angle bracket, an open curly brace, the number 0, and then the closing curly brace. And those braces are found above the square brackets on your keyboard. All right, and I'll put an exclamation mark after that. So I've got this weird sequence of characters here. Just make sure you get that exactly right. With the curly brace 0, it has to be the number 0, not the letter O, the closing curly brace, and then an exclamation mark. Then after the double quote, I'm going to hit comma, and then I'm going to type in message. All right, and I'll explain what all this does. Let me just run the application, and I'm going to choose door number 1 the first time. You want a new car, or you want a car. And then I'll run it again. I'm going to type in the number 2, and you want a cat. All right. So this if method, I guess you could say, is it creates a condition. Is this user value equals 1 true or false? If it's true, then set message equal to car. But if this is false, then set message equal to cat. Now, the next line of code, I'm going to display that message. I'm going to use this string replacement code, I call it, this merge code of 0, which means the first item, and we could add additional items here if we wanted to, but this merge this item with whatever the value of message is to create a new literal string called U1A car or U1A cat, depending on the value of message. Now, just to mix this up a little bit, you picked, and I'm going to put 1. So I'm going to do the curly brace 1, curly brace. So you 1A, whatever, okay? And then after message, I'm going to hit comma, and this time I'm going to type in the actual user value that the user typed in. So now let's run this application, and I'm going to type in number 3, and then click the enter key on my keyboard. You pick 3, so you want a cat. All right, so you can see that this is 0 based, and that these replacement codes, as designated by this open and closing curly brace, they're 0 based, so we're going to replace 0 with the first item, 1 with the second item, and we can continue on with multiple items beyond that as well. Very cool. So this conditional operator, let's see what they call it here. It's a function if. So the if function is a little bit less flexible than that full-blown decision statement with the if, else, end if. However, whenever you need quick, inline conditional logic, it will shine like it did here. All right. So the key idea from this lesson is how to write logic using 2 Visual Basic constructs: the if, then, else if then, so on, and this IIF function. And there are others as well, but I just wanted to keep it simple to start off with. So you use the if-then statement to evaluate conditions, and you add to its utility by adding more else-ifs, and then finally an else statement at the very end to account for additional scenarios that you need to handle in your code. You use this conditional if function in order to facilitate simpler scenarios like we demonstrated, where it's either true or false, and based on that, it should either be this or that. All right. And we talked about formatting strings and using the string replacement syntax. We're going to expand on this whenever we talk exclusively about strings in an upcoming lesson. Also, with regards to decision statements or conditional logic, there's a third way, and probably more than that, by using the Visual Basic select case statement, and we're going to cover that near the end of this series of videos. So stay tuned for that. You're doing great. Hang in there. See you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills that they need to get their first software development job, building Windows and web apps of the world's best companies as quickly as possible. So in this lesson, I want to spend a bit more time talking about some of the smaller syntax elements in the Visual Basic programming language. And you'll need to master these to really understand how a properly formed line of code is constructed. So in one of the previous lessons, I said something to the effect that in Visual Basic, an entire thought is expressed in a single line of code called a statement. I may have even briefly referred to Visual Basic syntax as having nouns and verbs and so forth to kind of extend the analogy of it being like a sentence in English. And I want to elaborate on that and clarify what I mean by that in this lesson. So let's start off by describing the basic building blocks of the language. First of all, statements are complete thoughts, or complete sentences, if you will, in Visual Basic. Statements are typically made up of one or more expressions. And expressions are typically made up of operators and operands. And so we've seen several expressions already in our work together. We've seen expressions like the ones on this slide. Console.WriteLine, hello world. Another expression, if user value equals 1, then, and then goes on from there. Y equals x plus 7. Or my first string equals Bob. So there are many others, but each of these expressions have two things in common. First of all, they consist of operators and operands. Operands are things like objects, and for now just think of classes like the console class, or variables, or even literal strings. I suppose you would call these our nouns. And then operators are things like the plus operator, which when working with numeric data types indicates that you want to add the values together. And then another example was the ampersand operator that we use to concatenate strings together, like we saw in one of the previous examples where we concatenated Bob and 7 together. I suppose you could call the operators our verbs. And then there's the equal sign, which we already noted means variable assignment, but it also, when we worked with the if statement, you'll recall that we noted it tests for equality. So there are several operators that have more than one job, depending on the circumstance. And there are operators that we've seen, but you may not typically think of as an operator. For example, we talked about the opening and closing parentheses. And this is the operator for method invocation, like console.readline, open and close parentheses, which says I want to execute or invoke that readline method. So what happens if we were to ignore the parentheses? Well, first of all, it changes the meaning of our code, and the Visual Basic compiler wouldn't understand and would probably raise a compilation exception. Now, in our case, in the case of Visual Studio and Visual Basic, Visual Studio, the IDE, is nice enough to actually insert the parentheses in there for you if you forget them. And that's another reason why Visual Basic is sometimes seen as more friendly than other programming languages, because it really doesn't allow you to make some of these mistakes. Another operator that we've already seen, and you may not think of as an operator, is the period or the dot, which is the member access operator. It's the way that we get from console to read line. We are able to see all the members of the console class by using the period or the dot in order to show us all of the methods and the properties of the console class, for example. We're going to learn a lot more about these sorts of ideas when we talk about object-oriented programming a little bit later in this series. But the key idea for now is that the dot is, in fact, an operator. It's the member access operator. And there are quite a few operators, but as you start out, you probably only need to know a handful of them, and you can learn more as time goes on. So I want to focus on just a few. These will come in a rapid-fire format. You're going to need to memorize this list eventually, and you'll add to this list as time goes on. For now, you can refer back to this lesson. It wouldn't hurt to make a cheat sheet if you're following along with this lesson. And you can see on screen right now that I actually created a little application called, or a project called Operators, Expressions, and Statements. You can download it wherever you've downloaded the source code or this video that you're currently watching, or from wherever you originally downloaded it from or currently streaming the video. I wouldn't recommend that you type this in by hand necessarily, but if you'd like to, you can. The project itself is nonsensical. It doesn't really do anything. It just allows me to type in some of these operators. Kind of, you can see what they do. But at any rate, as we start at the top here, you can see that we have this dim x equals 0. Here we are, this is a declaration statement where we're defining or declaring, dimensioning a new variable and then assigning it to an initial value. Then we have the assignment operator, which is the equal sign, the addition operator, the plus sign, subtraction, the multiplication, and the division operator, as you might expect them to be. The division operator is a /. The equality operator is, again, the equal sign. So to test if this is true, then you perform that block of code. There are others that can be used in a similar sort of way, like the greater than. So if x is greater than y, or if x is less than y, or if x is greater than or equal to or less than equal to. There are also the conditional and or operators. So if this is true or that is true, then perform this block of code. And then there's the conditional and operator where you have to have both this and that true in order for then this block of code to execute. And we've already talked about the member access operator, the period, and the method invocation operator, the opening and close parentheses. All right. So again, not an exhaustive list, just a few, but you'll probably need to memorize these. You can use a cheat sheet to start off with, but you'll be using these like 99% of the time as you're typing code. So you'll want to expand your vocabulary and add more to these as time goes on, as well as some of the keywords that Visual Basic has as well. So in each of these cases that we just saw, an expression is made up of a combination of operands like the literal string or variables x, y, or objects like the console class, and operators like those we just looked at, the greater than, the less than, the and, the or, and so on. All right. And you use expressions then to form statements, which are how the actions or the instructions of an application are expressed in Visual Basic. And we've already seen some great examples of statements so far as we've been writing our applications. And you might wonder, well, okay, what are you talking about? Which ones would qualify as statements as opposed to just expressions? Well, if you revisit the projects that we've created so far, there are declaration statements like dim x as integer, or like we've seen at the very top where we've actually did dim x equals 0 and just allowed the compiler then to figure out what data type x is. And then there are expression statements like my string equals my first name plus my last name, or some value equals 3 times x divided by 100. And in this specific case, notice that we're using the parentheses kind of as an order of operations operator, much like you would use in any algebra problem where I want to do this first and then perform all the work on the innermost parentheses first and then work your way outwards like you would in a normal algebraic equation. There are decision statements. We've already seen an example like this so far. The if-then statement, for example, where we test some condition, could be x equals y. There are iteration statements, which I'm going to show you in just a lesson or two from now. And there are a couple of others, but basically these are the syntax rules of Visual Basic. So now why am I telling you all of this? Because the syntax rules actually matter, and they'll help you understand why you can't do something like this in Visual Basic. Like if I were to type this as a line of code as an instruction and hit the enter key on my keyboard, you'll see that there's some reformatting. It put the plus closer to the y, and then you get the blue squiggly lines underneath. If you were to hover your mouse cursor over them, it would say under the x that the expression is not a method, and it would say under the y that method arguments must be enclosed in parentheses. It's completely confused. It says, well, what do you want me to do with this? I have no idea what you're trying to say here. So that's why grammar matters, because in order to properly form a Visual Basic instruction, it has to have certain pieces or elements to it. So for beginners, understanding that there's a proper syntax, just like there's a proper grammar in the English language, it's a big step to solving your own problems or phrasing Visual Basic instructions that the Visual Basic compiler will accept. All right? So let's recap what we talked about in this lesson. First of all, statements are complete instructions in Visual Basic. They consist of expressions. And a statement is like a sentence in the English language, and the expressions are things like nouns and verbs. Actually, expressions are made up of operands and operators. So operands are things like objects, or for now, just think of classes like the console class, or variables or literal strings. I suppose you could call these our nouns. And operators are like verbs. They act on the operators. So we spent a lot of time looking at, I don't know, a dozen or so different operators, and we've been using operators for all sorts of purposes up until now, even if we didn't quite identify them in that way. And so you combine these together in order to create expressions that then create statements, entire complete instructions for Visual Basic. So you have to memorize the operators. To start off with, you might use a cheat sheet just to memorize a limited number of them. However, in most cases, I think you're going to be able to just reason out what you need to type next in order to make a line of code into a proper statement. So I want to add these two variables together. I guess I should use the addition operator, and then I want to assign them to this other variable, so I guess I'm going to use the assignment operator, the equal sign, okay? And so you can kind of reason your way through and use what would logically come next as you express it in the English language, and it will usually work. So operands are things like variables and classes and strings, and they're easy to remember the names of because you create those names yourself. You have to memorize the operators because they're the way that you do something meaningful with your operands that you define or that you have to use that were created by somebody at Microsoft, like console or WriteLine, things of that nature. So I just wanted to make these distinctions and help you get a firmer grasp of the language, that there is a grammar, a proper usage of the syntax, and that should help you understand why you might encounter problems with the instructions that you write. Just always think in terms of a complete instruction, a complete sentence in Visual Basic, and then if you get an error, an exception, maybe you'll get some helpful advice, but you might want to back up and say, this isn't really doing anything. I'm adding two things together, but where does it go? It's not being assigned to anything. It's not being evaluated to anything. And then you can make the proper corrections. Okay? So hopefully that helps. We'll pick it up in the next lesson. See you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development jobs, building Windows and web apps to the world's best companies as quickly as possible. So in this lesson, we're going to focus on iteration statements. We're going to focus on a single iteration statement called a for next loop. So sometimes you're going to need to loop through, or rather iterate through, a sequence of items and perform maybe a series of checks to find a match, or maybe to, like we'll do in the next video or the one after that, read through an entire file and retrieve the contents of the file line by line into memory so that we can display it on screen. Or there's a number of different things that we could possibly do with an iteration statement. We're going to use this actually a lot more than you might anticipate. So while it might not seem all that useful at first, believe you me, you're going to need this in your box of tricks. So let's start off with a new project. I'm going to create a new project from the start page, and we're going to call this for iterations. And I want you to follow along as we write the following code. It's really simple. All right. So as you take a look at this code, what do you think it does? Well, here we're instructing Visual Basic to execute the block of code between the for and the next. Now, it just so happens that we only have one line of code in this code block, and its only responsibility is to write out to the console window the current value of the index. So each time we complete an iteration, each time we execute the code in the code block, we want to increment the index by 1, and we'll do it over and over again until we've incremented it 10 times, and then we'll exit out of our for next loop because we have reached the end, and then we'll fire off our console.readline. So let's go ahead and run the application, and you can see how it works. We just print out simply the index value from 1 to 10. Great. Let's do something slightly more interesting. This time we're going to add an if statement. So if index equals 7, then console.writeline found 7, and then we'll call exit 4. All right, so now what do you suppose this does? Well, we're going to continue to loop through the code block in the for next statement. Each time we loop through, we're going to check the value of index. When we find a successful match, when index does equal 7, then we're going to write out a message, hey, we found 7. And then we're going to reach this exit 4. And when we reach this, it will drop us completely out of this for next statement. So we will skip writing to screen index number 7. We won't loop through 8, 9, and 10. Instead, we'll be pause then at the read line. So let's go ahead and run the application. And as you can see, it worked exactly how I anticipated to, just by reading the code. Great. So now what I want to do is to kind of show you that, that flow of the code. I want to set a breakpoint. And I'm going to step through the code. And it will actually help us to understand a little bit more about debugging in our applications with a more interesting case than what we've used up to this point. So I put a breakpoint on line number 6 where we're checking to see if index equals 7. And so now I will start debugging. So the very first time that we reach this line of code and we perform the check, we'll take a look at the value of index. And you can see that currently it's set to 1, as we would anticipate. So what I want to do is actually put my mouse cursor on this little window that popped up, and I'm going to use this little pin to the right of the current value of the index and pin it down. And so now we see off to the right-hand side the current value of index, which is 1. Also, I'm going to make sure to have my locals window open, and you can see that I can see the current value of index listed in the locals window as well. And it will actually list out the value of all variables that are currently in the scope of the code blocks that are currently executing. All right, so if we were to step through the lines of code, you can see that we did the check for index equals 7. It was false, therefore we jump down to the end if, and we continue on and write to the console window the current index, which we would anticipate to be 1. And we can see that it indeed printed 1 to the window. And so now we go hit to the next, and it jumped back up to make the check again for index equals 7. Now, notice this, that index is set to 2 and it's in red text. Whenever we see it in red, that means the previous line of code changed the value of that variable just in that previous line. So in the previous line of code, index was set to 2. You can also see it represented here where the value is set to 2 and it's in red. That means its value just changed, and it's calling our attention to that. Again, another helpful debugging tool. Now I'm going to select the continue button, and I'm going to hit it actually several times and just keep an eye on and watch for index equals 7. This will allow me to continue working through this example without having to step through each line of code. I just have to hit continue, it changed to 3, continue, it changed to 4, continue, it changed to 5, continue, it changed to 6, continue, it changed to 7. And at this point I'm interested again. I want to get back into executing this line by line to watch the execution path. So this time index is equal to 7, so we would anticipate it to go into the if and if statement. It'll print found 7 to screen, and now watch what happens. We're about to execute the exit 4, and notice that it jumped from exit 4 directly to the console.read line. At this point, I'll go ahead and hit the continue button. It brings up our console window, and I can just hit enter on my keyboard to end the application. So I thought that was an interesting exercise for you to see the practicality of debugging whenever you're working inside of maybe a little bit of a larger code example. And there are other ways to avoid stepping through line by line 1,000 times until you find the exact situation that you want to then investigate further. Great. All right, now the 4 next statement's not all that difficult to remember. However, when you're getting started, everything's a little bit difficult to remember. So I want to introduce this notion of code snippets. It's yet another way that Visual Studio helps you write code in a consistent manner, helps you remember the syntax, and so on. So instead of having to memorize the exact syntax for the 4 next, or just about any code structure that we cover in this series, and without having to type it all out by hand, I can use code snippets in Visual Studio. In fact, we're going to use code snippets often throughout this series in order to save code to keystrokes and write code more accurately. So what I'll do is I'm going to type the word 4 on my keyboard, and when I do, notice that it pops up IntelliSense. Off to the right-hand side, you can see that it introduces a loop that's iterated a specified number of times, and then look at the note below that. It says tab twice to insert the 4 snippet. Tab, tab, bam. It creates 4 index equals 1 to 10, and then there's an empty line, and then the next statement. It just spit all that out for us. Awesome. So now I can use the tab on my keyboard to go between 3 replaceable parts. I'm hitting tab over and over and over and over. And I could rename this something like X. So instead of index, I'm just going to call this X. And instead of 1 to 10, I'm going to do something a little more interesting. I'm going to go from 10 to 5. Now, how can I go from 10 to 5? Because we'd be going backwards. Well, I'll introduce another thought. We can step through backwards if we use the step -1 instruction. So now we'll go from 10 to 5, decrementing 1 each time. And once we get past 5 and we move to 4, then we'll exit out of the for next loop. So here we'll just do console dot write line x, and just so we can see this, I'm going to get rid of our breakpoint, and I'm going to comment out the previous lines of code like so. So we should only have 4 lines of code in play, and I'm going to go ahead and hit the start button. And you can see we go from 10 to 5, and then it exits out into the console.read line. Awesome. Okay, so it was a brief lesson, and you can tell that it's not complex. But it's pretty neat that we're able to iterate through a specific number of times that we preset using the for next statement. There will be other iteration statements that allow us to change the number of iterations based on what's inside of the code block. So the for next statement, up front, we knew exactly how many times we were going to iterate through. We'll use other types of iteration statements to make that variable based on, for example, the number of lines in a file that we want to look through every single line. So we iterate through until we get to the end of the file, and then we exit out. We'll use a different iteration statement for that purpose, and we'll talk about that later. But in this lesson, we learned several important things. First of all, how to use the for next statement to iterate through a code block a number of times until a particular set of criteria are satisfied. We demonstrated a simple conditional if statement in our code example, and we could expand on this in future lessons. We looked at how to combine an if-then statement inside of a for next iteration and add some logic to evaluate certain conditions. This was a pretty silly example, but hopefully the principle and the idea is more powerful. We talked about how to use a break statement to jump out, or rather an exit for statement to break out or jump out of our for next loop. We looked at the practical use of several built-in debugging features of the Visual Studio IDE. We looked at how to use a code snippet to save keystrokes and to write code more precisely. And then I also demonstrated how to not only loop forward through a certain number of times, but we also looked how to step backwards a certain number of times as well using the step keyword. Okay, so we're doing great. See you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. In this lesson, we're going to talk about arrays. Now, previously I compared a variable to a bucket in the computer's memory that holds a value. To extend that analogy from earlier, you can think of an array as a bucket that contains other buckets. Another way to think of an array is a sequence of data. And I hesitate to use the word collection of data because that has another meaning in .NET to .NET developers. But you can think of it as a grouping or a collection of data that you can iterate through, you can store values in, you can retrieve it out, you can assign values to it, and so on. So you declare an array just like you would any other variable, starting with the data type that you want to use, and then you tell it how many elements that you want in your array, or how many buckets inside of your bigger bucket that you want to save in memory. And you can access any single item in that array using its index, which is its ordinal position within that array, to retrieve it out, or rather its position inside of the sequence that you want to access. So let's do this. We're going to create a new project, and it's going to be called Understanding Arrays. And I'm going to type in the following code. Please follow along. Okay, well, first of all, let's examine the declaration and the assignment of values inside of our array. First of all, you can see that here in line number 5 that we're defining an array of integers. The numbers in the parentheses are the bounds or the boundaries of the array. So in this example, there will be 5 values, starting with the number 0 and all the way through the number 4. So to access then an individual element of the array, you use the name of the array variable. So in this case, the word numbers that we declared here, and we'll use it throughout to access the individual items in the array. So we'll say number sub 0 equals, and we'll assign that to 4. Numbers element 2, so index 1 equals 8, and so on. So then in lines number 7 through 11, as you can see, we're setting the individual elements of the array to an integer value. And there are a number of different ways that I would say this in English in order to explain what's going on in these lines of code. So I might say, like I did earlier, number sub 1 equals the value 8. Or the numbers array at index 1 equals the value 8. Or I might even say the second element of the numbers array is set to the value 8. Okay, any of these are acceptable nomenclature to use. And it's extremely important to remember that arrays are always zero-based, meaning that you count the element of the array starting with 0 as the first element. Now, quite honestly, this causes those who are just new to software development a little bit of confusion at first, and it's hard to remember. We're going to see what happens if you forget this in just a moment, and you think, oh, I've got 5 elements in my array, so I'll start with 1 and I'll go to 5. You'll experience a runtime error when you do that. So also, I just want to point this out. Whenever you use the parentheses in this capacity, we refer to them as the array or the index access operator. It's what we'll use throughout to access a specific element of the array. So then in line number 13, we're retrieving the value that we placed in the third element of the array at index 2, or in other words, the third element of the array, and then displaying it alongside of a literal string that I spelled incorrectly, there we go, in order to print out the value of the third element in the array. And then finally in lines 17 through 19, I'm just doing a simple for next statement that we learned about in the previous lesson to loop through each element of the array and then print the value of the item in the array. And so why do I have to take the length and subtract 1? Well, first of all, what's the length? It's the total number of items in the array. So if we go from 0 to 4, that means there's 5 items in the array. However, we can't go from 1 to 5. We have to go from 0 to 4. So we'll take this length, which is 5, and we'll subtract 1, and that will give us the correct counting so that we can go through and use this variable index to index into a given element of the array. Okay? So let's go ahead and run it and see what gets printed to screen here. First of all, the third element of the array contains the value 15. Is that correct? 1, 2, 3. It does indeed contain the value 15. And now we're just going to iterate through the array 4, 8, 15, 16, 23. Great. Okay, so now what happens if we were to add a line of code that references an element that's not actually in the array? So let's try to set numbers element 6 at index 5 equal to 42. All right, let's go ahead and run the application. When we do, we'll get a system.index_out-of-range exception. Additional information, the index was outside the bounds of the array. In other words, we're trying to stuff 6 values into an array that was only designed to hold 5 values. So we're out of bounds. It's important to note that you can't expand or shrink the size of the array, the length of the array, after it's been defined. If you need that functionality, there are fancier alternatives to arrays that we're going to look at later on in this course, like collections. Talk about those later. You can also, let's go ahead and continue on this and comment this out. You can also declare and initialize the array in a single line of code. And so when you do that, we don't have to declare the number of items up front. Before I do that, let me show you one other shortcut we can take here that I didn't think to point out before. Instead of doing this, there's a new shorthand. You can just do that and it'll work just as well. Okay? You just have to remember that it's from 0 to 4, even if you only put the number 4 here. All right? All right, so let's comment that out. And we'll comment all of this out. And we'll take this more succinct syntax to do the following. Like so. Okay, let's try to run this and see if we get the same result as before. And we do. So just take note that, first of all, we are creating an array of integers called numbers. We didn't define the number of items in the array, but it's initialized using the equal operator to this grouping, this sequence of numbers, values that are integers that are separated by commas. And this means that we have 5 items in our array, even though we didn't specify it here, okay? It's also important to know that you can create arrays that hold virtually any data type, not just integers. So just to prove that and to show you how this works, let's go ahead and comment out all of this. And I'll create another example right before the console.read line, like so. We'll use that new style here. And then I'm going to use a different iteration statement. Now this iteration statement is called a for each, and you'll see how useful this is. Okay, let's run the application and see it merely prints out each of the names in our array, 1 line per item. How did this work? Because first of all, we created a new array of 4 items because we initialized our new names array to have these initialized string values. And we used the the for each item in the names array that we created. Take one item in the array, and we're going to create a variable called name as a string. And we're going to retrieve the first item into this name variable. And then we can use that in the body of the for each iteration statement to print it out to screen or do whatever we need to do with it. So for each name as string in names, we'll iterate through once for each item in the names array, and we'll merely print them to screen. Pretty neat, right? Okay, so let's comment this out, and we're going to do something even more interesting this time. So make sure you're following along. All right, that's an awfully long string, right? So what would be really neat is if we could split it up into 2 instead of having to scroll over the right-hand side every time we wanted to use it. So I have an idea. Let's break it right here. I'm going to put a double quote, and then I'm going to put the ampersand and then an underscore character. That underscore character is a line continuation character in Visual Basic. So I'm basically saying take this literal string, and I want to concatenate that to this literal string, and we'll do it on essentially 1 line of code, but we'll use this line continuation character to kind of say it's really just 1 line of code, and we'll paste them together with this ampersand character, all right? So that's how you're able to get around that restriction of only 1 statement per line of code, 1 instruction per line of code in Visual Basic. All right, so let's continue on with our example here. Okay, so let's take a look at what we've done here. First of all, we created a really long literal string with a famous quote from one of my favorite people in the world, Zig Ziglar. You can get what you want out of life if you help other people get what they want. Now that I have that as a literal string, I'm going to use this toChar_array built-in method to the string data type. And what this will do is create an array of individual characters. And you can see here that I'm using this char data type. And the char data type is essentially, it's like a string except it's only one alphanumeric character. So we're going to create an array of alphanumeric characters. And we're going to save that as an array of alphanumeric characters called char array. How many items will it have? Well, we could count up each of these individual letters and spaces inside of this literal string, or we could just use the length property of the char array if we really wanted to know. But at any rate, what we're going to then do is use a built-in function of the array data type called reverse, and we're going to pass in our char array. So what do you think that'll do? Well, it's going to take our entire array of chars and reverse the order. So if you were the first in line, you're going to be the last in line. If you were the second in line, you'll be the second to last in line, and so on. So it reverses everything. So we'll essentially be going, looking at this string backwards, all right? And then we're going to, for each individual character, individual char inside of our char array, we'll loop through, and inside the body of our for each, we're going to simply write that character to the current line. Now, notice that I didn't use write line. I'm using write. I don't want a new line for every character, otherwise it would span, maybe what, 70, 80 different characters or lines, one for each character. Instead, I wanted them to appear next to each other. And so that's what the write method will do instead of the write line method. Okay? So let's go ahead and run our example, and we see what we might expect. Reading from right to left, you can get what you want out of life if you help enough other people get what they want. Awesome. Okay, so in this lesson, we primarily learned about arrays as a means of storing groups of data like numbers or strings or even individual characters with our char array. Along the way, you learned about a few other important concepts and techniques. First of all, you declare arrays by defining the data type, the zero-based number of elements in the array, and optionally, you can initialize the values in the array by using those opening and closing curly brace syntax like we did right here, right? And right here, okay? And use parentheses like we did here and here and a few other places in order to access each individual element of the array with the index inside that we want to actually access. And arrays are always zero-based, and attempting to access an array element that's outside of the boundary of the array's length, or rather the number of elements contained in the array, will cause an exception to be thrown like we saw. You can use the length property of an array to find out just how many elements are inside of the given array. And you can use this information to iterate through each element in an array using a for next iteration statement. Or if you prefer, you can use what we've done here with the for each iteration statement to iterate through each element of an array, which will also extract out the current item and put it into a variable that we can then use inside of the body, inside of the code block for the for each iteration statement. And then we also learned about the array.reverse method to reverse the order of elements in the array. And there are many other members of the array data type that allow you to perform operations on all the data inside of your particular array. And I even noticed that there was a resize. And if we take a look, it allows us to change the number of elements of an array to the specified new size. So there is a way to get around that limitation. It's a built-in helper function to the array data type that would allow us to resize or change the number of items. Even though I didn't demonstrate that, I'll bet you could probably figure out how to do that on your own. It's not built in, it's not part of the array necessarily, but you can resize it using that helper method. Okay? And we learned a bunch of other stuff too. It was a great lesson. So hope you're enjoying this. We'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development jobs building Windows and web apps at the world's best companies as quickly as possible. So in this lesson, I want to show you how to create simple methods which allow us to split up our Visual Basic code into multiple code blocks. Now, a little bit of a caveat before we begin here. In this context, I'm using the term method, but I could easily use the term sub-procedure or function. You'll see that I'm using those terms synonymously. When we actually start building our own classes a couple of lessons from now, when I use the term method, I'm going to be using them to refer to both sub-procedures and functions inside of the context of a class. Whenever you're building a sub-procedure or a function inside of a module, like we've been working with up to this point, then you usually just call them sub-procedures or functions. I realize it can be a little bit confusing. I wouldn't make too much of it at this point. Just understand that we're talking about similar ideas. It's just the code block that you put them inside of, whether a module or a class, might give them a little different feature set, okay? But at any rate, simply put, a method or a sub-procedure or a function is just a block of code that's given a name so that you can execute that block of code from some other block of code. It's one of the basic building blocks to creating larger applications. So we're going to look at other building blocks like classes in an upcoming lesson, but we're going to start simple with talking about methods, or rather sub-procedures and functions. Okay, so why would you ever want to split up your code into multiple methods or sub-procedures or functions? Well, there's actually many reasons why. First of all, it's a good idea to never write the same code twice. We talked about that earlier in a previous lesson. And if you ever find yourself cutting and pasting the same basic code template in a number of different places, that might be a wake-up call to say, wait a second, what am I doing here? I need to actually to take that code and put it into its own method. So cut and paste is usually the sworn enemy of a software developer. It's a necessary evil sometimes, but you should really stop yourself dead in your tracks whenever you realize that you need the same code in a second, in a third place, and so on. Oh wait, I need that same code over here. I should copy and paste. Wait, whoa, I'm not going to copy and paste that. I'm actually going to create a method, and I'm going to put that code in that method, and then I'll call that method from everywhere I need it. So when you write a method and you call that method from each place where you need that functionality, you're delegating the responsibilities of that functionality into this one spot. If you ever need to change that functionality, you change it in one spot. If you ever have a bug with that functionality, you update it, you fix it in that one spot, and it'll be fixed everywhere. Okay, so that's the value of using a helper method. Okay, so we've already been working with methods. For example, we work with the submain in just about every lesson. We called it a sub-procedure. It is a sub-procedure. It's also known as a method. It's just a very special kind of method, that particular one, that's triggered when the application first starts up. We've also been calling or using methods that were written by Microsoft whenever we called the console.writeLine method or the console.readLine method, and so on. Okay, so to get started, what I want to do is create a new project, and I'm going to call this helper methods. And I'm going to write the following. First of all, I'm going to start below the end sub. So there's submain, end sub. We're not going to write any code there to begin with. We're going to write code below that code block, but still inside of the module 1 end module. So here I'm on line number 7, and I'm about to create a new sub called display with a lowercase d, capital the, capital M, and message. Open and close parentheses. And now I'm going to type in console.writeLine from display the message. All right. It's a very, very simple helper method, a very simple sub-procedure, but to execute it, what I'm going to do is call the display the message helper method, and then we'll call it console.writeLine, or I'm sorry, console.readLine. All right. So what do you suppose this will do? Well, because Visual Basic reads so well in the English language, we're going to literally call that display the message helper method. When I do that, it'll execute all of the code inside of the code block that has the name display the message. And then once it's finished, I assume it will just continue on to the very next line of code, which is our console.readline, and we know what that does. So let's go ahead and run the application, and indeed that's exactly what this does. Great. It's a very simple idea, or a very simple example that demonstrates a powerful idea. You can delegate certain responsibilities of your application into reusable sub-procedures like we've done here, reusable helper methods. So what do I mean by the term reusable? Well, here again, if I need that functionality that's encapsulated by the display the message sub-procedure, I can call it a second time like so. In fact, I'm going to show you a different way to call the display the message sub-procedure. I'm just going to call it like that. Either of these ways work. You might still see some people use the old call keyword from Visual Basic 6, 5, 4, way back in the 1990s. But most of the time, when they're calling a sub-procedure, you'll just see it called like this with the name of the sub-procedure and then the method invocation operators, the parentheses, right? So now when we run the application, we would expect to see that message twice, and in fact we do. We were able to call into that code twice. Now again, very simple, even silly example, but it shows the power of being able to call any code that we've created inside of this code block multiple times by just calling it by name and then expecting it to actually perform its function. Great. Okay, sub-procedures are self-contained units, meaning that they can perform a task like console.writeLine and then exit quietly. But what if we want the procedure to perform some operation, some calculation, and then return that result back from the procedure to the code that's calling into it here? So in that case, we wouldn't use a sub-procedure, we would actually use a function. So let's do this. I'm going to create, below the sub-display the message, I'm going to create a function called super secret formula, and it's going to return a string. So I'm going to call as string. And so in this case, we're going to use the return keyword to return a simple message, like so. All right. And now, back in our main, I'm going to comment out our previous calls to display the message. And here, I'm going to create dim message a string, message equals, we'll call in super secret formula, and then I'll do a console.writeLine with the message. All right, and I'll go ahead and run this application, and we'll see the message hello world. Boy, that's a lot of work just to print hello world to screen, isn't it? Well, again, simple example, powerful concept. In fact, let me do this. I'm going to go ahead and comment all of this out because I use 3 lines of code to do what we could simply do in 1 line of code. So console.writeLine, and I'm just going to call super secret formula, like so. So we don't need to create an additional variable to hold the return value from the super secret formula. Instead, we'll just call it, expect it to return the message as a string, and then we know that WriteLine can print out a string. We'll count on the .NET Framework to perform these in the correct order in order to get this printed out correctly to screen. We run the application and we get the same result. Okay, great. Okay, kind of taking this in a different direction now. How does console.writeLine accept an input parameter like a string or an integer or whatever the case might be? Well, all we need to do is define an input parameter. So let's add one to our super secret formula. So we're going to make it this helper method that we've created here, this function super secret formula, more flexible and useful by allowing it to accept an input parameter. So when we create our methods, we can choose to accept 0 or 1 or more input parameters. And then in the body, or rather in the code block that's defined by the function end function, or the sub end sub, we can use that input parameter in the body to perform a calculation, to do some manipulation on that value, and then return it back. So in our case, we're just going to keep it simple. We're just going to accept a single input parameter that we'll use to append to the literal string hello. So here we go. I'm going to start with function super secret formula. You might be asking yourself, how can you name this super secret formula too? Don't get ahead of me. We'll get to that in just a minute, okay? All right, and then I'm going to type in this mysterious word byval, and we're going to give our input variable a name called name, a string, and then we're going to return a string from our function. And so here we're just going to do a return string.format hello, and we're going to use that string replacement syntax that we saw earlier. Okay, and then I'm going to use the comma on the keyboard, and I'll pass in name as the replacement for the first item in our kind of merge codes, all right, in our string replacement code, all right. So we would expect to be passed in a name, let's say Bob, and then we'll merge hello, and then name will equal Bob, and we'll replace this replacement code with the word Bob and return that back out to super secret formula, and we'll pass in Bob. Or actually, let's do this. Let's pass in world. Okay. And we'll go ahead and run the application. We get hello world again. All right. And we can basically copy this line of code and change it to hello sunshine. Right. And we can now execute it multiple times, passing in different values as an input parameter. Right? So I hope you found it odd that there were two functions by the same name, super secret formula, one that accepted 0 input parameters and one that accepted this input parameter of type string called name. All right. Well, this is called an overloaded method. You've overloaded it. You've given it multiple meanings or multiple ways of calling it. So you can create 2 or more methods, or rather 2 or more subprocedures, or 2 or more functions like we have in this case, with the same name, as long as each version has a different number of input parameters or accepts a different type. So we could create a third version of this super secret formula that accepted byval name as integer, okay, and then used an integer inside of the code block. So as long as we have a different number or different data types of input parameters, we can use the same name for our functions. So in IntelliSense, when we go to use it, if we go back up here and just call super secret formula, you can see now that IntelliSense has one of 2 super secret formula with no input parameters, and when I use the down arrow on my keyboard, super secret formula with name as string as an input parameter. Okay, so I can just go back and forth, 1, 2, 1, 2. Great. So whether you realize it or not, we've been using overloaded versions of the WriteLine method. You see there's 18 different versions of WriteLine. I think we talked about this early on. We can take different data types, a double, an integer, a long, an object, a single, a string, format as string with arg0 as object, or an array of parameters, or, and it goes on, the different ways that we can call WriteLine. And so by having one method name with several overloads, it makes it more convenient for the consumer of the method to call it, passing in what I have available or what I need at that moment. I mean, we've been able to throw just about anything at console.WriteLine and it's been able to handle it. So isn't that a lot easier than if we had to wade through 18 different versions of the WriteLine method? I mean, we might have to call console.WriteEmptyLine, console.WriteStringLine, console.WriteIntegerLine, and so on and so on. And that can become very confusing and overwhelming. It's much easier to have it with the same name, since they essentially do the same things, but what we give it, the input parameter, is simply different. So that's the justification for overloaded helper methods. Okay, so the key takeaway in this lesson, however, is the use of methods. And we're going to be using subprocedures and functions, also known as methods, often in the coming videos for various purposes. I just wanted to make sure that you had some exposure and explanation to how to create your own subprocedures and functions. What's the difference between the two? Why are methods kind of called, used as a blanket term for both subprocedures and functions? Understand how is it that we're able to pass input parameters or retrieve values back from methods. How is it that we have some methods that are overloaded and have so many different versions? Okay, hopefully we've answered all those questions in this short lesson. So hang in there, you're doing great. This is meaty stuff, at least as you're getting started in Visual Basic, but you're doing great, and we'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. So in this lesson, I want to take kind of a roundabout way of showing you another iteration statement, the while iteration statement. And so to demonstrate this, what I'll do is open up a text file and read each line of the text file and print the values that we read from the file to our console window using console.writeLine. So beyond the specifics of using the while iteration statement and then beyond the specifics of reading data from a text file into memory where we can process it or work with it, there are several other key ideas that we're going to cover, like how to add files to our project, how to work with nothing, which is an unknown or indeterminate value. Sometimes, for example, a variable will be nothing, which means that we don't know what the value is. It's really null, or it doesn't have a value that we know of, okay? And then we're also going to talk about how to change properties of things using the properties window. So let's start by creating a new project. I'm going to show you yet another way to create a project. Here on the toolbar, you can see that there's a button called New Project. If I click on that, it'll open up the New Project dialog, just like all the other ways that we've used up until this point. Making sure that we're in the Visual Basic Console application template, we're going to create the read text file while project. And the very first thing that I want to do is making sure that my Solution Explorer and Properties window are open, or at least the Solution Explorer. I want to add a new file to this project. I want to add a file that'll contain ASCII text that we will read in. And so there's several different ways to go about this, but I'm just going to right-click on the project name in the Solution Explorer, and I'm going to select the Add submenu and choose New Item. And in the New Item or Add New Item dialog, there are a number of different types of files that we can add to our project, and we'll add a couple of these, like the class, for example, in an upcoming lesson. But for now, I'm going to scroll all the way to the bottom and select Text File. And I'm going to rename this from textfile1.txt to values.txt, and I'll click Add. And you can see now that the values.txt file has been added to our project in the Solution Explorer, and it's been opened up into the main area of the IDE. So now what I want to do is just type in some values, and we could use anything here. We could use some of our favorite quotes, or maybe what's on television tonight, okay? But instead what we're going to do is type in the following sequence of numbers, one per line: 4, 8, 15, 16, 23, and 42. And I will save my work, and I'm going to close the values.txt file. We shouldn't need to edit it for the remainder of this lesson. Great. So the next step is to write code to open up that values.txt file and read each of the lines in. So some of this code is going to look familiar, some of it's not going to look familiar. We're going to talk about those parts that are not familiar, but it's important to know that you will see blue squiggly lines as we type this code, so that I can demonstrate another idea that we haven't talked about up until now. So just follow along for now. It won't work right off the bat. We'll have to work through some issues, and in the process, hopefully you can learn some things about how the .NET framework and projects work, and how the class library works, and things of that nature. Okay, so here we go. We're going to auto hide some of these things. Okay, as displayed, the code is not going to run. We can see that the word stream reader has a blue squiggly line under it, indicating that we're going to be unable to compile this application until we fix that problem. So the problem is that Visual Basic can't resolve the word stream reader. In other words, it has no idea what we're referring to here. We seem to be talking about a class that doesn't exist as far as Visual Basic is concerned. So the problem is that the stream reader doesn't live inside of any of the default namespaces for our project. So a namespace is the formal name for a class. So just like many of us have first names, middle names, last names, or we might have a surname and a forename, classes also have names, and their long names are called namespaces. So I'm going to explain why namespaces exist in a lesson that's devoted to that topic. But for our purposes in this example, the stream reader lives in the system.io namespace, and currently we haven't told Visual Basic where to look for that class name. So before we fix this, what I want to do first is just explain what this code is attempting to do, and then we'll come back and fix it. All right, so we're going to start with line number 5. We're attempting to create a new instance of the stream reader class. We're going to call that instance myReader. So when we create a new instance of the stream reader class, we have the option to pass in a parameter as the name of the file that we want to actually open and work with. So in this case, it's going to be the values.txt file. And a stream reader class, once we get it all working and hooked up correctly, it's going to work like a straw into a glass, okay? So little by little, line by line, we are going to suck data out of the values.txt file into our program where we can process it, or we can simply print it to screen like we will using the console.write line. So in the next line, we are going to actually create a variable called line, and it's of type string, and we're going to initialize its value to an empty string. So then in line number 8, we're going to evaluate the current value of the line variable. So as long as the line variable is not nothing, then we'll continue iterating through the code block that's defined between lines 9 and 13 there. So there's this built-in Visual Basic helper method called isNothing. And nothing is a difficult concept for beginners to really remember. A nothing value means that it has an unknown or indeterminable value. An empty string is not unknown, it's just empty string. But there are values that are unknown. Okay, we just don't know what to set it to. So we're going to see that in this very next line, in line number 9, we're going to set line equal to myReader.readLine. Now typically as we work through the file and we read each line of the file, we're going to retrieve back either 4, 8, 15, 16, 23, or 42. But when we get to the last line, or the 42, and we go beyond that, the file has ended, and I happen to know that readLine will return back a nothing value. So that's what we're checking for. We're checking for the point at which we reach the end of the file. That readLine method I have highlighted will return back nothing. And so now we're checking to see essentially if we are at the end of the file. Were we successful in reading another legitimate value from our text file? If not, isNothing line then. So if there's something inside of the line variable, then go ahead and print it to screen. But if not, then we're not going to execute this code. In fact, as we iterate through, isNothing line will be true. If not, isNothing will be false. And when that happens, we will exit out of the while statement. Okay? So again, this is going to return true or false. This built-in isNothing, and we're checking to see if line is nothing. We're going to come across this notion of nothing again when we work with object references, instances of classes called objects, and when we are no longer working with a reference in memory to an object. We'll set the variables that hold that reference equal to nothing, and that will allow that instance of the object to be removed from memory by the .NET Framework runtime. We'll talk about all that a little bit later. So I just wanted to introduce you to this notion of nothing in Visual Basic. All right. All right. So I think I've explained pretty much everything except this line number 15 here. So after we've finished working with the file, we're going to need to close it. Failure to close the file could possibly leave a reference to the file open, and prevent other users or application processes from accessing it, at least until the computer is rebooted or some similar drastic action is performed. So line number 15 accomplishes this by calling the stream reader's close method. All right, we opened it up here, and we started working with it throughout the remainder of the program, and now we want to close it and relinquish all control of that file back to the operating system and say, we're done. We don't need it anymore. Go ahead and use it. Do whatever you want with it. All right. All right, so before we can execute this application, we need to resolve the blue squiggly line. You know, if we try to start the application, we're going to get a compilation exception. So as I mentioned earlier, the problem is that the Visual Basic compiler can't resolve the word StreamReader to its full name, which is system.io.streamreader. So to easily fix this problem, what we'll do is place our mouse cursor over the little red dash under the letter R in StreamReader, and that'll pop open a little red X icon. And as I kind of move my mouse cursor down a little bit, I can select the little down arrow next to that red X icon, and it'll give me some options to fix the problem. So in this case, what I want to do is choose the top option. I want to import the system.io. I'm telling Visual Basic, oh, by the way, when you come across the StreamReader, I'm actually talking about the system.io.streamreader class. And when we do that, notice that the blue squiggly line has gone away. Notice that StreamReader is now in that aqua green bluish color, meaning that it has recognized it as a legitimate class. And we have added a line at the very top of our code file called import system.io. So we're telling Visual Basic, hey, if you don't recognize one of the names of the classes, you might also look in this namespace. This is the last name of our StreamReader class. And so make sure you look there to find the definition inside of the .NET Framework class library. So I guess one of the first takeaways is that by default, whenever we create a console window application, not all the namespaces that we need in our project from the .NET Framework class library are available to us. We're going to talk about why that is and why Microsoft made that decision to do it that way in a later lesson, but there's a very good reason, so just hang on to that idea, okay? All right, so I think we're pretty much ready to get started. Let's try starting the application. This time, unfortunately, we're going to hit another exception. This time we hit the system.io.filenotfound exception. And if we look at the additional information, you can see that we're looking for that values.txt file in the bin/debug directory. Now, I happen to know, as I look at the Solution Explorer, that this values.txt file is definitely part of our project, so we would expect for it to be in the project folder, but recall the bin subdirectory of the project folder has both a debug and potentially a release version, and it doesn't seem to be getting copied to that folder. And so since we didn't qualify this with any folders, and we're just saying look in the same directory as where you're currently executing, and you should expect to find that values.txt file, I am going to assume that that file is not properly getting copied over. Now to confirm this, I'm going to open up Windows Explorer, and I'm going to look in the Documents directory in the Visual Studio 2013 folder, in the Projects folder, in the Read Text File While Solution folder, in the Read Text File While Project folder, the bin directory, in the debug directory, and as I look through these files, I cannot find that values.txt file. All right, so this is easily remedied. I'm going to remove auto hide from both the Solution Explorer and the Properties window. I'm going to make sure to select the values.txt file in the Solution Explorer, and I can look at properties about that file in the Properties window below. Now there's one property in particular that we want to focus on, this copy to output directory. What this will do is say this is a resource file. It's not getting compiled into our application. It's just a resource file that needs to be there whenever our application executes. And our application would expect to see that file in the same folder, since we, again, didn't tell our application to look in any subdirectory or any parent directory. Okay. So at any rate, what I want to do, you can see that by default it's set to do not copy, but we want to change that. There are two other values here. Copy if newer, which means anytime this values.txt file changes, we want to copy it from the project directory into the debug directory, but only when a change is made. And then copy always, which is the one we're going to select. There's no harm in it in this particular case. We want to move that file into the debug directory every time we create a new version of our application. Every time we hit start debugging, compile the code, creates the assembly, also copy that values.txt file over. Now that we've made that change, I'm going to hit the Save button on the toolbar. I'm going to go ahead and click the Start button on the toolbar, and we can see the result that we were aiming for, 4A 1516, 2342. It seems to have paused at the very end for us to hit the Enter key on the keyboard to exit gracefully. Awesome. Okay, so that's really all that I wanted to talk about in this lesson. I know that there's still some mystery surrounding this import system.io line of code at the top and the whole notion of namespaces. At least for the moment, you know how to resolve these types of namespace issues when they pop up, and they will throughout the remainder of the series. The why this happens, we'll have to wait for a future lesson where we'll talk about namespaces at length. All right, so a couple of important concepts in this lesson. Hopefully, you've got another iteration statement under your belt. The while, end while iteration statement will loop an indeterminate number of times that you'll need to iterate through the code block contained inside of the while statement. Unlike the for next statement or the for each statement, where we knew for sure up front how many times we were going to iterate through, once for each item in an array or collection or whatever the case might be. In this case, we are going to allow what happens inside of the code block to affect whether or not we continue to loop through this particular code block. So when we're done reading through the file and we hit the end, now it's time to exit out of our iteration statement, okay? So you can see that there's a need for both of these situations, and that's why all of these different iteration statements exist. So we also learned about the string reader class. I compared it to a straw that sucks data in line by line from a text file using its readline method. We also learned how to open it by passing in the name of the file at the time we create a new instance of that class through a constructor. I realize all that terminology is new. Very soon we're going to talk about creating instances of classes and what that means. So just kind of let that roll off your back for the moment. We saw how we need to help Visual Basic resolve references to classes by providing an import statement at the very top of the code file. Now, and I haven't told you the full story about all that just yet, but we're not going to be able to put it off much longer. We talked about nothing values in Visual Basic, which is an indeterminate or unknown value, and how it's different from, say, just an empty string with nothing inside of it. And we also learned how to add files to our project. We added a text file. We learned how to set properties of that text file using the properties window, specifically how to set the copy operation to that file to the output directory, either debug or release. Okay, so that wraps up this lesson. Doing great, hang in there. We're going to look at strings in the next lesson. See you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. So many types of applications involve managing text, whether it be a customer relationship management system where fields of data and notes are stored about individual customers and sales opportunities, or content management systems where entire paragraphs of text are published to a blog or some other web-based presentation application. Mastering string manipulation is a vital skill. So in this lesson, I'm going to demonstrate several common string manipulations that are made easy by the .NET Framework Class Library string class and some built-in features and functions of Visual Basic as well. So to begin with, I'm going to create a new project called strings, and we know that we need to surround a literal string like this, dim my string equals my so-called life, with double quotes. But what if we needed to put double quotes inside of the string itself? So we want something like this, but you can see when I do that, I get a blue squiggly line. Visual Basic is confused. It thinks that there should be the end of the line, but we kept on typing after this first closing double quote. So how can we remedy this? Well, fortunately, you can escape the double quote sequence by just providing two double quotes next to each other. This will create a single double quote in the string itself. And doing that twice will produce the results we want. So now let's just print that out to the screen with our common answer to all problems, console.writeLine and console.readLine. and you can see what the result is, my so-called life, and it's formatted properly. And so there are several occasions where things like this will happen. For example, let's show another example where we dim my string equals, what if I need a new line in between of this little paragraph here. Now this makes it easy if I just use WriteLine twice, but what if I want to store that value or use it in some other capacity? I want that new line to be embedded inside of the string. So what I can do is this. There's actually a couple of ways to do it, but I'm just going to choose one. There's a constant called VB new line, and I'll just kind of insert it in there using a ampersand, then the VB new line constant, then another ampersand, and then the rest of my string. And it will look like this whenever we run the application. Okay, great. And similarly, what if dim my string? What if I need a tab in my string or in my line? Well, then again, I can insert VB tab, another constant built into Visual Basic. Let me get rid of this. That allows us to format our text correctly. So whenever I run the application again, I add a tab, I don't know what, 5, 10 spaces, a blank space in between what if I need a and tab in the line. All right, great. So there are constants for lots of purposes in Visual Basic. There's actually a full list here. If you go to this URL, it will take you to MSDN, where there's a full list of Visual Basic constants. Some of them are used for formatting strings like we've seen here, and some of them are used for lots of different purposes. At least you can kind of see the scope of the built-in constants in Visual Basic for these sorts of purposes. All right, let's go ahead and move on and talk about string.format. We've done something like this before. So dim my string equals string.format. So yes, the string data type has some built-in features. The format is one of them, as we've seen before. And we used this kind of string replacement code in the past to, I guess we could call it, do a merge between arguments that we pass in and the template, the very first argument that we pass in. And we use these curly braces with a number to indicate a zero-based set of arguments that will come after that template for the remainder of whether it's console.writeLine or string.format. So we know what this will produce if we run our application. We are familiar enough with that. But what you may not realize is kind of the extent to which you can go with this. Let me demonstrate one other example here. And we saw something like this before, but for the sake of building on this idea, let's put a make, a model, and maybe something else there. So we'll do a BMW 745 Li, and we'll give it the year as well. So we can mix data types and still depend on the string.format to merge them in nicely, like you see here, where we have this template with the make and the model, and we're actually able to pass in strings and integer values or numeric values. All right, great. But we can even go beyond that and do some advanced formatting. So let's set up another quick example here. So dim my string equals string.format. And here I'm going to use open curly brace 0 and then a colon. And what I want to do in this case is format these numbers, 23.35, as a currency value. So notice that it puts the $ before 23.35, which is a decimal value. And so this formats the number as a US dollars and cents format, since that's the preferred language on my computer. So you can set the language preference programmatically for your application. Otherwise, the .NET Framework runtime will use the language preferences from the computer to properly format numbers for the given country where your user is executing the application. All right, so there are several of these little pre-built formatting codes, I guess you could call them. And so let's take a look at a few of the popular ones. Say, for example, we have, we'll come back to that. We have just a long number. I'm just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And what if I want to format that as a series of, as a decimal value, all right, with 2 values after the decimal point. So I would use the N formatting character to do that. All right, so you can see it formatted it with decimal places, but then also with commas every 3 numbers. So what is that? 1,234,567,890 units or whatever's, okay? Great. Let's kind of take that same idea. I'm just going to copy that line of code and paste it in here. And what if I want to use this same format, but let's just put a period in there and see what we get with regards to the P code. You can see that it formats this as a percentage, a very large percentage. Maybe we need to, and notice that it rounded this up from 0.78 to 0.9, okay? So that's interesting. What if we just wanted to do something like 0.123? Let's see what it gives us in that case. 12.30%, all right? So it essentially multiplies our number times 100 and then applies the percentage sign, okay? So what if we need to format a series of numbers into a string, such as a phone number or a social security number or a tax ID or something along those lines? Well, you can create custom formats by using the pound sign to represent the next number in the sequence. Now, I'm going to do this twice. I'm actually going to mangle this formatting the first time. So after the colon, I'm just going to start adding pound signs to represent a phone number in the United States. And I'm going to actually leave off 1 digit. There should be 4 pound signs there, but I'm going to leave it off. And I'm going to attempt to run this the first time, and I would expect it to leave off a character, but notice that it doesn't. It formats kind of from right to left. So it goes 098, 765, 432, and it has nowhere to put the 1, so it puts it at the very beginning of that string. Now again, that's not what we want, but I wanted to illustrate what happens whenever we format the string incorrectly. To remedy this, I'm going to add 1 more pound sign, and then it will look correct on screen. Area code 123-456-7890. All right. So that's how we can do some advanced formatting. And there's a small set of examples here, but it's a very large topic. And so if you want to learn more about the different types of formatting that you can perform on numbers using string.format, take a look at this MSDN article where they talk about these different formatting codes that you can include after the colon for a given replacement value inside of your arguments for string.format or console.writeline. Great. Let's comment that out and move on. So previously we showed examples of string concatenation using the ampersand operator, and we've used it quite a bit up to this point in our series of lessons. So the code example that we're going to write next will take this to the extreme, and we're going to use an iteration statement to just keep on appending strings to see what we get. And we'll talk about what happens in memory when we do that. So here we go. Follow along. Great. Okay, so let's run the application and see what's happening here. All right, so we might expect this to be the result, where we have dashes and then each index from 1 to 100 in between the numbers, because again we are concatenating the current value of the string and 2 dashes and whatever the index I is in the current for next iteration statement, and we're assigning that back into string. So this operation of string equals string and something new is actually very memory intensive. Now in a small example like this, it's nothing to worry about. But if we had lots of strings to work with, lots of string concatenation or replacements of characters and things of that nature, it becomes kind of problematic. See, strings are immutable, meaning that whenever you create a string, it's like an array of characters. That array is fixed in size, and it can't be just the size of that bucket in memory can't just be expanded without there being some impact in the system. So what's happening behind the scenes is that the .NET Framework is managing the memory for the myString variable. And it says, okay, myString is this size. Okay, got it. We're going to create a bucket memory for that size of a variable. Oh, wait, you want to take that variable and add more to it? Well, what do we do now? Well, I guess I will temporarily create a new place in memory. I'll take the old variable value, I'm going to attach this new stuff to it, and I'll put it in this other place, and I'll get rid of the old one. So now we've got the new value. Great. Oh, wait, you want to add more to that string? Oh, we got to do this dance again. Okay, I'm going to create a new area in memory. I'll take that value, append more to it, and stick it in there. And so we keep doing that over and over and over, and that's very memory intensive and very processor intensive. And so there's actually a better way to do this, and I'll talk about that in just a moment. But before we do, I want to show you one quick improvement to this code using a new operator that we haven't talked about yet. Let me show you the plus equal operator, which says take what I currently had and append this to it. So I can just do this. And this will work with integers as well. So I plus plus or I plus equals will work with that value as well as an integer, right? CSTR I. All right, so when we run this example, we get the same result, but we did less typing because we didn't need to do this whole little dance right here. All we need to do is myString equals plus equals means take what you currently got and add all this other stuff to it, all right? But as I said earlier, that's memory intensive. So let's take a look at another way to kind of remedy this. There's a preferred solution to the scenario that I described when you're working with lots of strings and you're doing a lot of string manipulation. Maybe not something as simple and silly as this example, but something larger scale. There is a class in the .NET Framework to build strings, to handle strings, and do it in a more memory efficient manner. And so let's go ahead and rebuild this example with working with the String Builder class. So here we go. Okay, so notice that okay, so we get a blue squiggly. We'll come back to that. We know how to resolve that, right? So in this case, let's go ahead and resolve that now. We're going to import system.text where the string builder class resides. We'll import it so that we can use the full name. Notice it adds the import system.text line of code to the very top of the code file, and now it sees the string builder. So now we can do something like this: myString.append. And we'll just add dashes, and then we'll go myString append value of I, and then we'll print out myString. All right, and so we get the same result. However, it is much more memory friendly in this particular case. All right. Let's take a look at this where we've actually created a new instance of the string builder. You might wonder about the purpose of this new keyword in line number 26. We're going to talk about that at length. Actually, line number 21. We'll talk about that at length in an upcoming lesson about classes and objects. For now, just accept the fact that we need to use that operator, the new operator, to use the string builder class, at least in this capacity. All right, and so again, the result will be the same with this little code snippet as what we saw earlier. However, the impact on the performance of the application on your computer will be dramatically reduced, especially when you're dealing with a lot of text, not just the silly example, but I'm talking about a lot of text. And so it's generally preferred to use a string builder rather than a string whenever you have a lot of string concatenation or string manipulation work to do, okay? So finally, we're going to look at how to work with some of the built-in string methods to manipulate strings. Again, there are a lot more than what I'm going to demonstrate in the next couple of moments here, but these will at least get you familiar with what's possible. So let's take a look at this. I'm going to actually comment all of this out. and start over again. And you can use any string that you want to here. I'm going to quote the line from one of my favorite songs. And notice I've added some extra spaces before and after that sentence, okay? And now what I want to do is, first of all, I want to capture just a subset or a substring of that longer string. So I want to analyze maybe each individual character or individual words or phrases, and so I can find strings or parts of strings inside of the larger string using the substring method. So the first argument that we're going to use is actually the starting index, the zero-based index. If we were to look at this as an array of characters, where do we start inside of that string, and then how many characters do we pull from that string into our new substring? All right, so we're going to start at position 14, so we're going to use index 13, and then we'll take 15 characters and then print that in a console.writeLine. So we were able to take the phrase out called "we took threes" from the longer string using the substring method. Okay, let's comment that out. Next, let's look at, I think we've already done this one time. We're going to use another method called toUpper, and that will put our entire string in uppercase. There's also a toLower, which will make the entire string in all lowercase. And you might be wondering, why would you want to do that? It's because whenever you try to compare two strings against each other, if you have a one that's uppercase and one that's lowercase, those strings will not be equivalent in Visual Basic. So to prove this idea, take a look at this. Let's just do if upper equals upper, then console.writeLine yes, else console.writeLine no. All right. So when we do this, you can see that no is returned. That's because lowercase and uppercase are not equivalent. And so we use toUpper or toLower to take, like, for example, input that the user types in to your application. We want to compare it against some string that we're expecting. And so to compare apples to apples and oranges to oranges, we want to either use the toUpper on both strings and compare them, or the toLower on both strings and compare them. Okay. Either way will work. Great. All right, and so next, we'll do something like this. My string equals my string dot replace. And suppose we want to replace all those empty characters, all those spaces, with another type of formatting like double dashes. Then we can use the replace character. Now we've taken and gotten rid of all the empty spaces and replaced them with double dashes. And this is actually much more convenient and much more useful than you might think, because whenever I'm massaging data, say I open up a file from one system that was produced on a Unix system, or for a different program that was created in my company, and now I want to massage the data, I want to change some things around about the data and put the file into a new format that can be utilized by a different operating system or a different program in my enterprise, I might want to use the replace a lot to to move things around and massage data and so on. So I use that replace method quite a bit. Okay, and so for the last manipulation I'm going to perform, I want to demonstrate kind of the use of two methods together. So let's do this. All right, so that's my little template, and now I'm going to pass in, first of all, what is the length of my string? And then the second, I'm going to do the length of my string. I'm actually going to call trim. So there's several of these trim functions. There's, I think, trim start. there's trim end. And so we can either trim off the trailing characters or the preceding characters that are spaces, so that we can kind of remove all the blank spaces. So that's why I intentionally put blank spaces at the beginning and the end of the string, because I knew I was going to eventually trim them off. So we're going to look at the original length of the string, and then we're going to trim off one character at the beginning and two characters at the end, and I would expect that the new length of that string, how many items are in that or characters are in that string, would be reduced by 3 for the after. That'll be replaced into our string.def format. So before, there are 47 characters, and then afterwards there are 44 characters. All right? Great. So as I said earlier, these are but a smattering of all possible string manipulations. However, this short list should serve you pretty well. I would encourage you, before you go off and you start writing lines of code to work with strings, take a few moments and review the methods of the string class and what's available to you. Chances are that there's probably already a method or two that can, at the very least, provide a very good starting point for you. I've seen people write some elaborate code to perform some string manipulation when all they needed to do was call a single method on the string class. And so it's just sometimes you're not familiar with what's even available to you from Microsoft. So take a few moments before you start working with strings and think, I wonder if there's already something built in that will handle this string manipulation I want to do. And then do a little bit of research using IntelliSense, using MSDN, and that should help you find some clues as to what you can kind of piece together to get the result that you want. All right, great. So we're going to look at that date and times much in the same way that we've looked at strings in this lesson. So we'll see you there in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job, building Windows and web apps at the world's best companies as quickly as possible. So in our previous lesson, we looked at string manipulation. Often, you'll also be working with dates and times in your application. So in this lesson, we're going to look at both the basics of working with the date class, as well as doing date math, formatting the date to be represented as a string in different ways, and a whole lot more. So let's go ahead and start by creating a new application called Dates and Times. And to begin, I'm going to create a new date. So dim my value as date equals now, console.writeLine. Okay, so in line number 5, notice that I use a class named date. I create a new instance of it and set it to the value of a built-in Visual Basic helper method called now. The now method returns a new instance of date that's set to the current date and time that this variable was created in the computer's memory. And then I obviously use the console.writeLine here. I can actually print or send dates to it. There's a default way of formatting dates as far as the WriteLine method is concerned, and so we'll see what it spits out for us whenever we run our application. So it will print out the date, month, day, year, again in US English time, as opposed to how Europe may use the day, month, year format, right? And then we see 11:54 and the seconds 01 a.m. So the full date and time are printed out according to the settings of my computer as to the format, the typical format that a given country would use to format a date and time. Great. And so there's actually a large number of helper methods that will help format a string in many different ways. If we were to use the dot and then type in 2, you can see that we can format it, the date as a binary. That there's local time, long date string, long time string, short date string, short time string. So let's try a few of these out. Let's do what I typically use, which is the to short date string, and you can see that it only prints out the month, date, year. let's do too short time string, and that prints out just the hours, minutes, and AM or PM. And let's try the long date string. And you can see that it prints it out in a very friendly format, Saturday, January 25th, 2014. Okay, so you can experiment with all the two, formats for a given date if you'd like to spend some more time on this and learning those different formats. But I want to continue on for now. So in addition to displaying a particular date or time, you can operate on it by using built-in methods that are available from the .NET Framework class library. So I just want to talk about a few operations that you can perform on a date. So for example, let's paste that line of code in again, and we'll do an add. And you can see that I can add a time span. We'll talk about a time span later, but there are other things that we can add. For example, add days, add hours, add milliseconds, add minutes, add months, add seconds, add ticks, add years. All right, so let's add some days. I'll add 3 days to the current date and then display that to screen. In fact, I'll do this, too short date string. And you might say, well, how is that possible that you're able to call too short date string on add days? Well, this technique is called chaining, and it's popular in programming and popular in .NET. So we know that my value is a date. The add days method will actually return a date as well. If you take a look at the definition of the public function add days, it returns a date, as date, at the very end there. And so now that I know I'm getting back a date, I can continue to chain on another method to that. I can format that date to the short date string format. So 3 days from now will indeed be the 28th of January. Great. So just keep in mind that chaining, we may have seen it earlier and I didn't really point it out to you. Let's continue on. We can add hours. So let's take that tact as well. Add hours. Let's add 3 hours from now. Too short time string. Same idea here where we're chaining together, we're getting back from add hours a date, and so we're going to format that date using the too short time string format. So 3 hours from now will be almost 3 o'clock in the afternoon. Great. And what if I wanted to subtract time? There is no subtract version of these methods. If I go to subtract, I can subtract a date, but I can't subtract just individual hours or minutes or days. So what you can do is add days minus 3 dot too short date string. And 3 days ago, it was the 22nd of January. Okay, so that's how you can get around that limitation. All right, let's also talk about retrieving various date parts. So if I were to start with my value here, in fact, let me just go ahead and copy this. And I wanted to, for example, just determine what the month is. I can print that to screen. So 1 represents January. These are typically integer values that are returned back. I can retrieve all sorts of things. If we take a look here, there are, the particular minute, the hour, the day of year, day of week. What day of week is it? Let's go ahead and comment that one out. Run this example, and it's the 6th day. So I guess this is counting Monday as the first day, and Saturday would be the 6th day, which I guess there's some way to change that to Saturday should be the 7th day of the week. That's just me. And there are many different ways to get at parts of the date, and you might need that depending on what you need to pass into another method, or to determine the amount of time elapsed between 2 dates, or how many months have elapsed, how many years have elapsed, or things of that nature, depending on the logic of the application you're trying to build. Again, these are just ways that you can get at certain pieces of a given date. All right, let's go ahead and move on. There are several ways to create new dates whenever you need to work with a date that is not now. Up to now, we've only been working with now, the current date and time. But what if we want to work with some date in the past or some date in the future? Well, the way that we can create a date without using the new function is through, there's a couple of different ways. There's a couple of different ways to do that. Let's start with my birth date, and which is in the past. So dim my birth date as new date, and then look at what I can pass in. There's 11 different ways that I can call this. And one of these ways is to pass in a year as an integer, a month as an integer, and a day as an integer. So let's do 1969. The month would be December, so 12, and the day would be the 7th. And now I would be able to print that out, console.writeLine my birth date, like so. And it represents, notice, midnight, because we didn't give it a specific time of day. So it will just default to midnight on 12/7/1969. Great. So the second way to create a date that's not now is to create it like so. Dim my birth date as new date. My birth date equals date.parse. So there's this parse method, and we can pass in a literal string. Whoops, 69. There we go. And let's go ahead and run it. And it will look like the same date that we created before, but notice that we passed in a literal string that we know represents a date. And then there's, just like there's literal strings that we surround with double quotes, there are actually literal dates as well. And to create one of those, all you need to do, we can go dim my birth date equals, and I can just use 2 pound symbols and 12/7/1969 and run, and we get the same result. So any of these will work. All right, so let's go ahead and now talk about how to determine the difference between two dates. I want to know how much time has elapsed between now and when I was born. How many days have passed? So I would do something like this. In fact, I'm going to go ahead and I'll create a new version of this to show another way to create a date. It's almost identical to what we've done before, but there is one little wrinkle here. Okay, and then I'm going to create my age, and I'm going to create a time span object. And so a time span represents the amount of time that has spanned. So in this case, we want the difference between two dates. It's not a specific point in time, it's rather a number of years, months, days, minutes, seconds, whatever the case might be. So we want a span of time. It's a different data type in Visual Basic and in .NET. So what we'll do is date.now.subtract. So there's our subtract method, and we need to pass in a specific date. So we're going to subtract now, we're going to subtract my birth date from now, and we should be able to do a console.writeLine with the number of days. So my age dot, and we can display it in total days, total hours, total minutes, or whatever the case might be. Let's go ahead and display it in the number of days. And let's run the application. And so that's how many days I have lived on Earth, 16,120 and a half, 0.5 days, which is about noon, okay? So I'm feeling pretty old, first of all, but I could use some combination of properties and methods on the time span object to determine exactly how this translates into years, months, and days, given the possibility of leap years and so on, if I just do a little extra work here. But there's a lot that we haven't covered in this lesson, but I felt these were the common uses of the date and the time span objects. And so I'm going to give you the same encouragement at the end of this lesson that I gave you at the end of the previous lesson. If you find yourself writing a lot of code to manipulate dates or times or spans of time, then you might want to stop and you look through MSDN or look through IntelliSense, because chances are the .NET Framework Base Class Library has something for you already built into it. All right, so writing applications involve working with data, and as we've learned in this lesson and the previous lessons, the .NET Framework Base Class Library can help you with all types of manipulations on all types of data, not the least of which are dates. All right, so now we're going to do something interesting. We've been talking about object-oriented programming and classes and objects, and we're going to discuss that fully beginning in the next lesson. So we'll see you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. So I've hinted at the idea of classes and methods and properties throughout this series already. I've noted that the .NET Framework Class Library is written using classes and methods, and we've benefited from classes and methods many times already. Now it's time to dive deeper to really understand the role of classes and how they differ from objects, and how to define your own classes and create new instances of those classes in memory. As you'll come to learn, virtually everything in the .NET Framework is a class or a part of a class. That's really the purpose of this lesson. Not so much that you can create your own classes necessarily, create your own framework, although that probably will be required to some extent as we move through the rest of these videos. The intent is really to use the classes that were already built by Microsoft and that are made available through the .NET Framework Base Class Library. The truth of the matter is that I couldn't possibly cover everything there is to cover about classes because it's a vast, vast topic. If you really want to learn about the power of classes, then you're going to need to learn more specifically about object-oriented programming. That's a topic for another day. I just want to present enough information for you to become comfortable with the basics of how to use existing .NET Framework class libraries, as well as how to create super simple classes as a means to coming to a more full understanding about what's going on in the .NET Framework class library. But again, I suspect that as you move past this initial series of videos, you'll want to start thinking about your business rules and how you represent the logic of your application in terms of objects that interact with each other. Okay? More about that later. So let's do this. We're going to start by creating a new project called Simple Classes. So suppose that I want to create an application that works with cars. I may have a car lot, and I need to keep track of an inventory of all the cars that are for sale on my car lot. So to keep all the related information about a single car kind of in one container that I can keep kind of self-contained, I might want to create a class that represents a car. So I'll create a car class. And so we're going to define a car class in a class file called car.vb. And the way to do this in Visual Studio, there's actually a couple of ways to do it. What I prefer to do is right-click on the project name in the Solution Explorer and select Add. And I could select New Item, but there's also a shortcut just to select Class. You can see there's even a shortcut, Shift-Alt-C, if you remember shortcuts, to create a new class file. Either way, it'll pop open an Add New Item dialog with class already pre-selected. And here we'll just want to rename this class1.vb to car.vb. And when we do, we see we have the new car.vb in our Solution Explorer. We have car.vb open in the main area, and we have this public class car with an end class kind of to define this, this code block. And so the keyword class will tell the compiler what type of code block we're attempting to create. We're going to give this code block a name called car. And so we'll see how this is used in a later step. And so we're going to add new properties and methods between this public car class and car class. And properties and methods are simply the members of the class. So classes can contain lots of different kinds of things, other kinds of members, but these two are the most popular, properties and methods. There's also fields and events and maybe some others. So in this lesson, we're going to create 4 properties that describe the car: the make of the car, the model of the car, the year the car was built, and the color of the car. Now, we might model more of these if we were to really flesh this example out. This will suffice for our purposes. A property defines an attribute of an object or an instance of the class. Now, how do we describe a car in this particular case? Well, there are many ways to describe a car, and you can choose those attributes that make the most sense for the type of application that you're building. Since this application is going to help us to manage cars on a car lot, we don't need to model all of the attributes or all of the actions that describe a car. In other words, we may not care about its fuel efficiency. We may not care how fast it can accelerate. We may not care or we may not model the fact that it can take the action of accelerating or decelerating. So other types of applications related to cars might need to model this information or these actions. But again, for our purposes, we really only need to model those attributes and actions, or rather those properties and methods, that'll help us keep an inventory of cars on our car lot. All right? So what do you do with a property? Well, a property is a lot like a variable. You can set the variable, or you can retrieve values from the variable. So you can set an attribute or a property in code, or retrieve the attribute or the property's value in code. Exactly how you would work with variables. It's just that this variable is defined inside of a class. Okay? There's a little bit more to it than that, but that's basically it. So that's a property. A method defines a named body of code and typically represents something the class can do, an action that it can take. So we've already seen subprocedures and functions. It's exactly the same, except in the body of this car class definition. There's a little more to it than that, but that's basically the idea. We've created helper methods in the previous lessons to do something meaningful, like perform some super secret formula calculation, right? In our car class, we're going to create a method that will determine the market value of the car based on some criteria, some business rules that we're going to come up with off the top of our heads that will help us determine the value of the car on our car lot. That makes sense in the context of a car lot inventory management system, right? All right, so we're going to start by creating some simple properties. And there are different ways to define a property. I'm going to take the easiest approach to defining property called auto-implemented properties. I'll show you the long form in just a moment, but let's start really simple. In fact, let me capitalize the M in make, and I'll describe why I do that a little bit later. Great. All right. There's also a longer form. These are auto-implemented properties. There's a longer form that you might wish to employ in more advanced scenarios. I really just want to show you this exists, and then after I show this to you, I want you to completely forget about it, okay? Again, advanced scenarios, but you might see this defined in code examples that you look at out on MSDN or out on the internet at large, so I want you to be aware of it. Fortunately, you don't have to memorize the syntax because the Visual Studio IDE has a built-in code snippet called prop, short for property. So if you do this, you type in prop, you can see that tab twice at the very bottom of that little box that pops up. Tab twice to insert the property snippet. All right, tab, tab. Wow, it expands out to quite a bit of code. And all of those yellow areas are replaceable. You can use the tab key in your keyboard to kind of tab in between which one you want to change. And so let's go ahead and modify this, and I'll explain the different parts of this. What we're going to do is, and I'm going to throw this away, but we'll create a property called Blue Book Value. So that'll be there's the Blue Book that tells you the real value of cars out on the car market, I guess. I don't know much about it, but okay, here we go. I'll use an underscore, Blue Book Value, and then I'll use the tab. And since I want this to represent a monetary value, in Visual Basic you use the decimal data type to represent both whole numbers and decimal values. That will give you dollars and cents. So we'll go decimal, tab, and I want to call this Blue Book Value, tab, tab. All right, it looks good. Okay. So what we've done here is define two structures. The first will actually hold the value. It will be what's called a private field. And a field is usually a backing value for a public property. A public property in this context is a gatekeeper that restricts or enables access to the actual value that's stored and hidden, encapsulated behind these gatekeepers, these gets and sets. And get and set are the two actions that you can take on a variable, or rather a property. You can get the value that's currently stored inside of the property, or rather in the field. You can see where we return what's ever in that private field called underscore bluebook value. Or we can set whatever the value is will be passed into the set. So I want to set bluebook value equals 2000. 2000 would be passed in as the value and set to this private member underscore bluebook value. All right. Why this occurs again is advanced. That's why I didn't really want to talk about this much, but think of these as gatekeepers. I can control access to bluebook value, underscore bluebook value, by writing more code in the get and the set. So for example, a car's value should never be a negative number. So we might want to restrict that in the set. We check value if value is greater than 0, then we'll allow the bluebook value to be set. Otherwise, we'll just ignore whatever they attempt to set the value to if it's a negative number. Okay, that might be one way that we do this. The get, we can control access maybe by checking the permissions of the current user. Do they have access to the current bluebook value of the car? Well, if not, we're not going to let them have it, right? We'll just return nothing, or we'll return 0, or something to indicate, or we'll raise an exception. You don't have access. Why are you asking this question? All right, now everything I just told you, completely forget about it, okay? We're not going to talk about that much more in this series of lessons, but this is the notion of encapsulation. It's one of the tenets of object-oriented programming, okay? And we control access a number of different ways, through getters and setters, through public and private, and therefore you see these two keywords, public and private. You saw public here, right? It even affects how we name things. For example, I changed the M in make from a lowercase m to a capital M because a naming convention in Visual Basic and most programming languages is to have public properties represented with a capital letter in the camel case. So the capital letter is the first letter, as opposed to a lowercase letter, which would indicate a private member. Also, the underscore represents a private member that shouldn't be accessed directly from outside the class, and therefore that's why it's marked as private, and there's an underscore within the naming convention. All right, now forget everything I just said, okay? We'll either come back to it or we won't, but either way, it won't really be pertinent for the remainder of this. All right, so let's continue on. The application we're building here is going to keep an inventory of all the cars on our car lot. So as the developer, I need to collect some basic information about each new car on my car lot. So now to make this a real application, I might pop up a user interface to the end user who's taking in an inventory of all of our cars and allows them to type in information about the make, the model, the year, and the color of a given car on our car lot. We could make that in the form of a web page, as a Windows application, a Windows Phone application, whatever the case might be. But for now, we're going to keep it simple and just use our car class and hard code some values directly into our submain. Okay, and so what we'll need to do is to begin that process in my program, I'm going to create a new instance of the car class for each new car that I want to work with in my application. So I will do the following. All right. So here I'm creating a new instance of my car class. So an instance of a class is called an object. An object is not a class, and a class is not an object, although you'll hear people, even me, kind of use those synonymously or maybe even confuse the two terms. The class is the blueprint. An object is instantiated from the blueprint. You can think of the class as a pattern, and an object is an instance of that pattern where you actually cut out the fabric according to the pattern and you sew it together and you have a dress or a pair of pants or whatever the case might be. So once you create a new instance of a class and give it a name like this, my new car, uh, it creates an area in memory sufficiently large enough to hold an instance of the car class, and now I can manipulate the properties of that class by using its moniker, its variable name, my new car. So let me explain this difference between the class and the object so you get this firmly cemented in your mind. In the real world, you can use the same blueprint to create many new houses. On my block, there are several houses that look exactly like my house, okay? They have the same layout, they have different color bricks maybe, but they're essentially the same house. So you can use the same blueprint to create many instances of the house, or you can create the same article of clothing over and over by using the same pattern. Or you can use a recipe many times to create the same cake or casserole for different meals. So each time you want to build a new house, it'll be at a new address. There's only one instance of this house at this street address, okay? It's not possible to put two of the same houses on the same address, right? That wouldn't make sense. Each time you follow the pattern, you create a new instance of clothing that can be sold to a different customer. Each time you follow the recipe, that new instance of the recipe can be offered at a different meal. So the same is true with classes. Each time you create a new instance of the class, you have a new object that's distinct and separate from other instances of that class that are all in memory. So think of a class like a cookie cutter. You can't eat the cookie cutter. You can eat the cookies that are made from the cookie cutter. So when you instantiate a class, you create a cookie, the instance, based on the shape of the cutter. In this case, it would be a finger shape. But imagine a heart shape or a star shape or whatever the case might be, and then you have instances of those, many of them potentially, right? So as you take a look at this line of code, we have this keyword new. So think of the new keyword as a factory. It uses the blueprint, the car blueprint, to create a new instance of the car class. So think of it as it's a factory that uses the pattern to create a new article of clothing. It uses the recipe to create a new casserole. It uses the cookie cutter to create a new heart-shaped cookie. Okay, that's what the new keyword does. It's the factory that pumps out a new instance of whatever the pattern is, right? So it brings the class to life in the computer's memory and makes it available and usable now. So you can create many instances of that class, so you can create many objects, all based on the same class, but each one might be distinct from the others based on its unique settings in its properties, okay? So in my code, I'm going to set each of the properties of my new instance of car, called my new car, to the appropriate values. Admittedly, in this case, I'm just going to hard code the values in here. In a real world application, I would present a graphical user interface like a web page or a Windows form to collect this information from an end user, or I might pull it from a database or whatever the case might be. So as I type out this example, notice that the dot operator, the period, is the way that you get to the properties of an instance of a class, or it's the way that you get to the properties to set them or get them for an object. And when we do that, my new car, you can see that we're now able to see all of the members of that instance of that class that are available. So before I actually do this, let me kind of back out of that 1 second here, and I'm going to show you a shortened version of this. We can simply represent my new car as car equals new car, like so. And this does essentially the same thing, and we can lose the equal sign, okay? All right, now I'm going to set all the properties of my new car. Great. So let's take a moment to dissect this code and really understand what's going on. First, I use the name of the instance of the car class, my new car, to access each of the properties of the car class that I'm going to set. And I use the equal sign, just like I do with variables, as the assignment operator. I'm assigning a new value to each of the properties of an instance of the car class. These new values for each property are maintained in memory for this instance of the car class, and as long as I have a reference, in other words, as long as I hold on to my new car, that instance of the car class will be maintained in memory, and so I can retrieve values from the properties that I set or change them again, whatever the case might be. So once I have a new instance of my car class and I've set its properties, I can do some useful things with this instance of the car that I've named my new car. For one thing, it's a nice collection of all the related properties that define a single car all in one container, in this my new car container. And so here I've set the properties. Let me show you that I can also retrieve the properties, and I'll just print them out to screen like so, using console.writeLine, and we'll use that string formatting, characters like we've or replacement characters like we've done in the past. So my new car dot make, my new car dot model, my new car dot year, console. Great. Let's run our application just to prove that it works. And it does. All right. So think about what's going on here. Again, in lines number 8 through 11, I'm setting the properties. In lines 13 through 16, I'm retrieving the properties for use to print out to screen. So that's why we saw the get and the set in the full property definition just a moment ago. They describe the two actions that you can perform on properties. So when I create a custom class, in other words, whenever I create a class myself, as opposed to using a class that's already been created in the .NET Framework base class library, I've really created a custom data type, just like any other data type that I've been using in my applications up to now, like string or integer. Therefore, I can define method input parameters like on helper methods, or I can define return values for helper methods that use that new custom data type. So let me do this. I'm going to create a helper method. I'll do this below the end sub, but before the end module. And I'm going to call this function determine market value. And I'll return a data type of decimal, which I'll use for monetary values. So if I want to represent money in Visual Basic, the typical way you do it is through the use of the decimal data type, right? And what I'm going to do is I'm going to allow the user of this helper method to pass in an instance of type car, not type string or type integer, which are built-in data types, but of type car, which is my custom data type. And I'll do that like so. And I'll just call this input parameter my car. Let me come back to that idea in just a moment. All right, let me hide that. Great. So I'm going to need to perform some super secret formula that'll help me determine the market value of a car. I tell you what I'm going to do. I'm going to just do something extremely simple and just return some value, $100. Every car is worth $100 on our car lot. Okay, obviously silly. We'll come back to that and change it a little bit later. All right. So the key idea here is that you can use your new class that you've defined, car.vb, anywhere you would need a data type, whether that be in defining a function as an input parameter, defining the return value. We could return a car from our helper method if we wanted to. All right, I don't know why we would, but we could do that. Let me address this use of the term my car here. Many times input parameters use an underscore with the same name as the data type itself. So it might be more proper to do something like that, at least as some people are concerned. I've also seen people who describe the purpose of the input parameter like so, something like car to be evaluated, all right, and then we could use that variable in the body of our code block. Now, I prefer using the my prefix in Visual Basic because underscore has another meaning to many developers. Like you saw a moment ago, we used it to define a private member field Blue Book value, underscore Blue Book value. But these are known as naming conventions, and there's a bunch of them, and developers get into heated arguments about it. So my suggestion is use whatever your teammates want to use if you get a job and you're working with others, especially at first. It really doesn't matter which naming convention that you choose, as long as you apply it consistently in your application and everybody who's working on it understands that naming convention. All right, so back to the matter at hand. Whenever I want to call this helper method, I just simply pass an instance of the car class to it, and it will do the rest. So let's comment this line of code out, and I'm just going to do console.writeLine, and I'm going to call determine market value. Which car am I going to determine the market value of? We'll pass in my new car and see how much it's worth. And we already know what the answer to this will be. It'll be 100 every time. Okay, but hopefully you get the idea. Again, the key idea here is that you can use your data type, your new class, as any type of data type that you want to for any purpose. So I said that classes are comprised of properties and methods, but we haven't created any methods yet. So let's create a new version of this determine market value. I'm going to copy this and I'm going to paste it into my car class definition. And let me change some things about it. First of all, I'm going to change its name from lowercase d to uppercase d, and I'm going to mark this function as a public function for all the reasons that we talked about before when we were talking about private and public, and we'll discuss that at much more length in the future when we discuss visibility modifiers, and we'll devote almost a whole lesson to that topic. But for now, let's comment out our super secret formula, and let's give it a more interesting set of business rules. So dim car value as decimal, and then if, and I want you to notice how I'm going to access the year for a instance, this instance, whatever this is, of the car class. So I'm going to say, what is my year? If my year is greater than 1990, then do something else. So here, let's set car value here. If it's before 1990 or greater than 1990, rather after 1990, we'll set it equal to $10,000. And if not, then we'll set car value equal to 2,000. And again, pretty simple super secret formula, but it's a little bit better than just returning us one value no matter what. But again, the me keyword here, first of all, it's optional. We could do this and it would work just fine, but the me keyword is a little bit more expressive as far as I'm concerned. It allows me to tell you, when you're looking at my code, that this year is actually defined as a member of the class. If I didn't, you might have a hard time understanding where this year magically came from, especially if there's a lot of code. So me says it's a member of this class, and I want to look at the current instance of the class and use its year property to determine something about the car value that will return back as a decimal. All right. So I strive to go overboard to make my code obvious and readable for my future self, as well as anybody else who might look at my code. And then finally, what I'll do, now I'm going to use that new method here, console.writeLine, and I'll do something like cars value, and we'll represent it as we learned about in the previous lesson, and we'll call my new car dot determine market value, like so. And let's run the program now. Whoops, what did I do wrong? Oh, we're missing a return statement. Return car value, like so. We have to actually return this out to satisfy the return type. So now let's run our application. And one other thing that I forgot to do is that we no longer need to pass in my car, because we're going to be working with this instance of the car class that's associated with the car class. Okay, so we don't need to pass in an input parameter. So now let's run the application, and we can see that the car's value is $2,000 because it was created or built before 1986. Okay, all right, so let's stop there. We've discussed the absolute basics of classes and objects, the role of the new keyword. We discussed properties and methods and a lot more. As I recap this lesson, let me point out that we use a very concrete example in this lesson, that of a car. A car is easy to conceptualize and represent in a class because it's tangible and it has a real-world equivalent. But most of the time, whenever you're working with the .NET Framework class library, you're going to be working with classes that do not have real-world equivalents. In other words, they're more conceptual in nature. For example, I might work with a class that represents a connection to the internet, or a stream of data, which is sort of like a pipeline of data flowing between one place and another. Or I might have a class that represents a span of time, again, conceptual in nature, the time span class. In these cases, we're not working with something tangible in the physical world. So keep in mind that a class can represent something tangible, but more likely, as you'll be using it, something that's intangible. It really depends on what you're trying to model. It can be challenging in both cases, both tangible and intangible, to decompose a problem into classes. Unfortunately, there are skills that you can develop to help you identify different classes in a system and then delegate responsibilities to them. This process is called object-oriented analysis and design. Again, that's not something that we're going to cover in this series of lessons, but you can learn more about them through books, and I also cover that topic on my own website, www.learnvisualstudio.net. So to recap, a class is a data type in .NET similar to those basic data types that you've been using up to now, like string and integer. You can define custom classes with properties and methods and then create instances of classes, or rather create an object using the new operator, which we said was the factory that actually stamped out a new object and put it into the computer's memory and retrieve back a reference to that object so that now we can work with that object in memory. More about that in the next lesson. You can access the object's properties and methods using the dot operator, which we know is the member access operator. So there's still quite a bit to say about classes. We're going to pick up this idea in the very next lesson. We'll see you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. In this lesson, we're going to talk about the lifetime of object references and how the .NET runtime manages the memory that your objects will use. And we'll talk about constructors, which are special methods that fire when you create a new instance of a class, like we learned about previously. And finally, we'll talk about shared methods and properties. So let's do this. We're going to create a new project called Object Lifetime. And using the technique we learned from the previous lesson, I'm going to add a new car class. So I'm going to right-click, select Add Class. We're going to call it car.vb. And then what I'm going to do is I'm going to add the 4 properties for the car class that we used in the previous lesson. I just have them already copied to my clipboard. I'm going to paste them in like so. Okay. And now what we want to do is go to the module1.vb and create a new instance. So I'm going to go dim my car as new car. And first of all, let me ask what you think is happening whenever this line of code is executed. Well, the .NET Framework has to go to work. It has to create a spot in the computer's memory that's large enough to hold a new instance of the car class. The computer's memory has addresses similar to the street address of your home, where it temporarily stores values during the lifetime of the variable, or in this case, the object. The .NET Framework creates a place in memory large enough for the particular data type, in this case, the car class instance. It takes note of the address of where it put that information, where it put that new instance of the car class. And then it serves that address back to you, the programmer, so that you can get to that information in memory anytime you want to. So where does it give you the address? Well, that's what this variable that we create, in this case, my car, but whatever we want to call that identifier, it simply holds an address, a reference to an instance of the car class in the computer's memory. So whenever you need to work with the instance of the car class, you just use my car, the my car identifier, and the .NET Framework takes care of the rest. It gives you the illusion that you're working with the object, but really you're just holding onto a reference. You're working with a reference, okay? So an analogy that helps me understand references to objects in memory is the old bucket analogy that we've used before. So a reference is like a handle to the bucket. When you store an object in memory, .NET gives you, the developer, a handle to hold on to so that you can hold on to that bucket. If you let go of the handle, you'll no longer be able to access the bucket. The bucket will no longer be accessible. But why will it no longer be accessible? Well, the .NET Framework runtime cleans up memory every once in a while by counting references. If we're no longer holding onto a reference to that instance of the car class, then it will remove the data that's stored in that spot in memory. And this process is called garbage collection. So you can do something like this, where we actually set some properties like we saw previously, and then I can do my other car as car equals my car. And now you have two references, or two handles to that one object in the computer's memory. We've essentially attached a second handle to the bucket, so we can use either one to retrieve the data that's inside that bucket, so to speak. So another analogy, think of it like a string to a balloon. After you cut the last string that's holding onto the balloon, it floats off into space and you can't get to it anymore. Okay? Same thing is true with references to objects in a computer's memory. So as references go out of scope, in other words, the current thread of execution leaves the current code block, or those object references are set to nothing, then the number of references to the object in memory goes down to 0, known as the reference count. And at some indeterminate time in the future, the .NET Runtime's garbage collection feature will go around and remove those objects from memory and free them up for other applications to use, or for your application to use. So they, in essence, empty the garbage buckets out, and that memory can be used for some other purpose. So in this case, what we'll do, just below this, is go my other car equals nothing, and then my car equals nothing, and then there's other code here, okay? And so at some point, the object reference will be removed. Since we have set these, we basically cut ties or removed the handles to this new car in the computer's memory by setting these handles equal to nothing, to null, all right? So when will this happen? When will that actual object be removed from the computer's memory now that we've called nothing on both of the handles? Well, it happens whenever the .NET Framework gets around to it. In some situations, this indeterminate period of time can pose a problem, especially when the object in memory is holding on to some system resource, like the network or a file on the file system, or holding access to a connection to the database. In these cases, you want to take a more deterministic approach to requesting that .NET remove the object from memory immediately. So in these cases, you want to learn more about deterministic finalization in .NET. That's a little bit of an advanced topic. We're not going to cover that in depth here. However, a quick search on the internet for deterministic finalization will provide plenty of discussion about what it is and the scenarios where it will actually be useful and where it's important. Okay, so we're doing great. We're understanding more about what's going on in memory whenever we create new instances, how we can set a reference to nothing and essentially cut all the references to the object. What happens when there's no references left? It gets removed by the garbage collector and it frees up the memory. That's all great. Let's talk about this line of code one more time. We've almost exhausted everything about it except this little open and closing parentheses operator. And we've talked about this for being the method invocation operator, right? Well, whether you realize it or not, you're calling a method whenever you create a new instance of the class. This method is called the constructor. It's a special type of method. It allows you, the developer, the option to write some code at the moment instantiation happens, at the moment when the new instance of your class has been created in the computer's memory. So constructors can be used really for any purpose. They're just a method, but you typically use a constructor to put the new object in the computer's memory into some valid state, meaning that you can use it to initialize the values of properties on the object, and maybe even to perform some other logic that you have. All right. So a quick example of this, let's go back to our car class and actually implement a public sub new. So whenever you see public sub new in Visual Basic, think, oh, that's the constructor that gets called whenever we use the new keyword to create a new instance of that class, right? So let me just type a quick note here. You can choose to do this or just watch. You could load this from a configuration file, a database, etc. But in this case, I'm just going to hard code the make property of the new instance of the car class to Nissan for no particular reason. So me, again, I'm using the me keyword here to indicate this instance of the class, me.make equals the literal string Nissan. All right. So now, whenever we create a new instance of class, let me just comment out. Let's comment out all this. And below here, I'll do console.writeLine mycar.make and console.readLine. So now, what would you expect to be printed to screen? The value Nissan. Where did we set it to Nissan? We didn't use the property. We didn't set any properties here in module 1. It's in the constructor. We hard-coded it and set it to Nissan. Again, typically wouldn't do this. You'd retrieve this potentially from some configuration file, a database setting, whatever the case might be. Or let's talk about what really is a more a use case that is more typical out in the real world. So we talked about overloaded methods previously whenever we were looking at the console.writeLine method. I mean, remember there are like console.writeLine, and we saw there's 18 overloads for this method. There's 18 different ways to call that method, and the reason there's so many ways to call it is to make it flexible enough to accommodate all the different data types without having to call a toString on that given data type, or without having to create 18 different WriteLine methods, WriteLine string, WriteLine integer, WriteLine new line, or whatever the case might be, okay? So the flexibility makes it more useful without changing the core purpose of that method and without having to memorize 18 different names that essentially do the same thing, write a line, with any data type that you have available. So you can create your own overloaded version of methods inside of your classes. We've already seen how to do that with helper methods. The same applies with your own methods that you create inside of your custom classes. And it's really easy to do. How did you do it when we worked with the helper methods? Yeah, you just change the method signature. In other words, you either change the number of input parameters or the data type of the input parameters, right? So the method signature includes the name of the method, the return data type, as well as the number and the data types of the input parameters. And we'll just need to change those in order to create multiple versions of the same method. And what you can do is combine those techniques. The technique of overloaded methods with constructors, and you can create overloaded constructors. So let's do this. Let me get rid of that. And let's go back to our car class. And here we're going to create another public sub new. And this time, we'll allow the user, the one who's creating new instances of the class, will allow them to pass in the default values that we want our new instance of the car class to be set at the point of instantiation. Here we go. And now that we have those input, we just need to do this. And so now whenever we attempt to create a new instance of car, IntelliSense, let's comment this out. So dim my car as new car, open the parentheses. Now it shows us that there are two overloaded versions of the constructor. There's a version that takes no parameters, input parameters, and then there's a version that takes 4 input parameters. And so I can use, again, just how we always do it, use the arrows on the keyboard to move between two versions in IntelliSense. All right, so in this case, I will use the second overloaded constructor to put the new instance of this car class into a valid state. So we'll do something like this. Forward. Notice how it highlights the property as we move through and set that given property. Okay, now whenever we attempt to console.WriteLine, what will the make be? It's a forward this time because we used this version of the constructor, not this version of the constructor, all right? So what if we were to attempt to create yet a third version of this constructor and it had the exact same input parameters? Well, first of all, what's the point of that? And then secondly, the same rules apply to overloaded constructors that apply to all overloaded methods. When we attempt to compile our project, it will fail because the car class already defines a member called car with the same, defines a member called new with the same parameter types. So again, the method signature has to be different. We could create as many different overloaded versions of our constructor as we want, or any method for that matter, but we just have to make sure that they're different. Different number of input parameters or different data types. All right, so what happens if I don't create a constructor in my class? So let's comment out both public sub new and public sub new, the second one. What happens when we go to create a new instance of the class? Well, first of all, you can see that that no longer works. Let's go back to this. And will this application run? Well, it ran. We didn't have anything in our make property. Basically, nothing happens. What happens behind the scenes whenever we compile our code is that a default constructor with no input parameters and no method body is created for you automatically by the compiler. So you still, no matter what, you have a constructor. You still have to use the open and close parentheses no matter what. It just won't do anything. The implicit default constructor has no input parameters, no method body. It's generated for you at compile time. Of course, as we've just seen, by defining one or more constructors, you're merely taking control of the process of instantiation. Also, many times, classes that we'll work with related to building .NET applications don't require you to create a new instance of them. So you might wonder at odd how we were able to just do console without creating my console, dim my console equals new console, and then call the WriteLine method. We've seen this in array.reverse back when we were looking at arrays, or date.now. How is it that we were able to call the now method of the date data type, or how were we able to call this format method of the string data type without creating an instance of those data types first? Well, they just kind of seem to pop out of nowhere and are available instantly for us to utilize them. How is that even possible? Well, it's only possible because when Microsoft created them, they defined certain methods as shared methods, or they defined the entire class as a shared class. And you can create your own shared methods and classes as well. So just one quick note here, you might see the term static used. C# uses that term static. Most software development languages use the term static. If you hear that term, it's typically the same as shared in Visual Basic, okay? So again, our objective here at the outset is to help you utilize the .NET Framework class library. So just know that some classes you want to work with require you to first create an instance of the class, and others will be available to you as shared members of a given type, a given class. In other words, their shared methods will be available without requiring you to first create an instance like console.WriteLine. But just so how you can see how these work, it's really simple. You just add the Visual Basic keyword shared to a method. So in this example, what I'm going to do is create a second class, and I'm going to do it right beneath the definition of this first class. Yes, you can create multiple classes inside of a single file. Typically, however, you separate them out into separate files. But I just want to show you that this is possible, and it prevents me from having to go and create another file. All right, so here we go. And in this particular case, I'm going to create a public sub, add to inventory, and I'll say by val new car as car. And then inside of here, the body of the method goes here. But what I'll do is add the shared keyword to this method declaration. And now I can use this anywhere in code. So for example, I can go, let's see, do I have, yeah, my car. I'll go a car lot dot, see it shows up, add to inventory. I didn't have to create an instance of car lot. And I was just able to get to the add to inventory and just pass in my car to satisfy it like so. And we're not really doing anything with it at this point, but you get the idea. We were able to access add to inventory by simply using the shared keyword. So it's pretty easy to create a shared method in Visual Basic. What's a bit more complicated is to understand why you might want to create your own shared methods on your classes, and that would require a longer discussion of design patterns, coding heuristics. The why behind it is a little bit more advanced. I just want you to know that for now that you can use the shared keyword, that you'll encounter shared methods whenever you work with the .NET Framework base class library, and you can pick up the rest later whenever you're designing your own code libraries. Okay, so in this lesson we talked about the lifetime of an object, including what happens when there are no more references to an object in memory, and how the .NET Framework runtime employs the garbage collection feature to remove those objects at some point during the execution of the application. We looked at constructors, and we looked at overloaded constructors to put the object in a valid state before we're ready to use it. We also talked about the shared keyword and how to use it to create essentially utility methods, right, that are available without having to create instances of classes. And we've seen those many times using the various utility methods in the .NET Framework class library, like console.writeLine, .readLine, and so forth. All right, we're not done with classes yet. We've got a lot more to say. So we'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps of the world's best companies as quickly as possible. As I stated at the outset of this series, half of the battle to learning to develop software is learning the Visual Basic syntax, and then the other half of the battle is learning how to utilize the .NET Framework class library. The .NET Framework class library has a second name that it's also known by. I may have accidentally slipped it in occasionally. It's known as the Base Class Library, or the BCL. And I'll explain why this is actually a very interesting way to describe the library as a series of base classes. And we'll talk about base classes and inheritance in this lesson. So what we want to do is to create a new project called Understanding Inheritance. Inheritance is another tenet of object-oriented programming. We've already said that encapsulation was the first tenet of object-oriented programming. And so now I want to add a car class and I will use the properties that I've used in the past. So I'll just paste them in. Make sure you pause the video and follow along. Type these in if you want to. And then I'm going to also create a method called formatMe, and it will be used to create a string that has all of these properties properly formatted for display on screen of some sort. All right, and then back in module1.vb, I'm going to create an instance of this car class and set its properties, and then I'm going to call one of its methods, the method that we would expect. And actually, let me do this. We're going to upgrade for this example. And we'll go console.readline. And I'm going to create a helper method here called printCarDetails. So sub printCarDetails. And I'll pass in a car, or I'll allow it to pass in a car. So underscore car is car. And here we'll go console.writeLine. And here are the car's details. And we will call the car.formatMe, like so. And then we'll just call print car details, passing in my car. Now before we do anything else, let's make sure this actually works. And it does, great. So let's suppose for a moment that our car class here is great for cars, for describing cars, and even representing cars to screen like we see here. But we might need something different for trucks. Now, trucks are in some ways almost the same as cars, but in some ways they're just a little bit different. The types of information that I might want to store or display in my application might be slightly different than the way I want to handle cars. So I suppose I could just copy and paste, Control C, Control V, and create and then change the name of public class car to public class truck. But if I do that, there's potentially a couple of problems with that. First of all, it violates one of our rules to never write the same code twice. It's not just a matter of having twice as much code to maintain, although that certainly will be the case. If we copy and paste the code, and what if it's buggy? What if we've done something wrong? Now we need to fix the problem in 2 or more places. Or we could even rewrite the code from scratch. It essentially is performing the same logic. However, if we weren't careful and the logic is inconsistent, then we're going to need to fix the logic in 2 or more places. So from experience, I can tell you that's not a really good idea. Okay. Second, our application might need to deal with both car objects and truck objects. Are we going to have to create 2 versions of every method? For example, this print car details. Am I going to have to create print car details, print truck details, print motorcycle details, print semi-truck details, print, I mean, the list can go on and on depending on how far we blow out this application. So it'll quickly become unwieldy if we need to add all these other similar kinds of vehicles. So ideally, we could merely borrow the things about a car that make sense for a truck, and then overwrite the parts that don't make sense anymore and add parts that trucks need that cars really don't need. Maybe like bed size or towing capacity. So we can do this by creating a new class file called truck.vb and then adding the properties and methods that specialize a truck. Now, because truck is different than a car in some small ways, at least in our application, I'm going to specialize the truck class by adding a property. So we'll start off by doing this. Right-click, select add new class, and we're going to call this truck.vb. And the first thing I'm going to do is say truck inherits car. And now I'm going to add to the properties from car by saying public property towing capacity as integer. All right. Now when we go to module 1 and we attempt to create, so dim my truck as new truck, my truck dot, and notice now that I get all of the properties and methods from car, but I also get towing capacity, all right? And so let me set the properties of truck, like make equals Ford. Wait a second. I hate using extra keystrokes. Visual Basic has another keyword that I can use that'll make this a little bit simpler. Let me get rid of all this. And I'm going to use the with keyword. So with my truck, dot make equals Ford, dot model equals F950. See what's going on here? I don't have to type my truck every single time within the context of the with and with statement. Very cool. It's built for these situations where you're trying to set a bunch of properties like so. And here I can set towing capacity to 1,200 units. Towing capacity units. I don't know what that means, okay? All right, so as an aside, let me say my car dot towing. You can't get to the towing capacity property from car because it's specialized in the truck class, all right? All right, so there are a bunch of benefits to this inheritance model where we're inheriting everything about a car but specializing it in the truck class. The most obvious is that you can save some code. I didn't have to define all those properties and the format me method again. But another benefit is much deeper than that. Anywhere a car works, like as an input parameter to a method, like we have here, anywhere a car works, a truck will work also. So we can do something like this and pass our truck into, so print car details, my truck, and let's see if it works. Let's run the application. And we not only now can print out the car, but anything that inherits from car. So we can print out truck as well. All right? So it's only possible because truck is a type of car. There's actually some different terminology that we can use to describe the relationship between a car and the truck. For example, the car class is referred to as the base class, and the truck is the derived class. Or the car class is called the parent class, and the truck is called the child class. Or the car is called the superclass, and the truck is called the subclass. All of those different terminology usages will be found as you look around, depending on who's writing and what their background is. But they're all kind of describing that same relationship between those two classes now, based on their inheritance. So our purpose in this lesson is to talk about how the .NET Framework Base Class Library is just one massive collection of base classes and derived classes. Why? Why do they use this or employ this technique? Because it creates this flexible way of working with classes in the framework. Again, it goes back to that polymorphic behavior. What was that? Wherever the car works, anything that derives from car will also work. That's the third tenet of object-oriented programming is polymorphism. All right, you don't need to know that. All right, so at any rate, one example, and there are many examples to look at in the base class library, we're just going to pick one, is to look at the stream reader class. We actually use the stream reader in the read text file while project way back. The stream reader class was utilizing functionality that's defined in the file stream class because stream reader derives from the file stream class. And if you want to follow along, here's the web page that I'm currently looking at, all right? So you might want to navigate to that shortcut and it'll take you to this page. So by the way, I'm looking at Microsoft Developer Network. I often refer to this as MSDN, the Microsoft MS Developer Network, DN. And it contains many resources for developers. Most importantly for our purposes, it contains a page describing each class in the .NET Framework Class Library in the standardized format, including kind of a brief explanation of what the class is there for, its inheritance hierarchy, the syntax that would be used to define this class, so you can kind of see where it derives from and all that. Its constructors, the different versions of the constructor that you can use, the properties that it defines, the methods that it defines, a longer explanation in the remarks area about what it's for and how to use it, and then some coding examples in different programming languages of how you would actually use this in a practical case. All right, some other more version information, what platforms they target, and also other related MSDN pages that would talk about file stream or one of its inheritors or its inheritance hierarchy. Okay. Here we see that the file stream has an inheritance hierarchy. You can see that a given class, what it derives from. In this case, it goes back several generations. File stream inherits from system.io.stream. And if we go back far enough, we see that it inherits from system.object. In fact, every class in the .NET Framework class library ultimately derives from system.object. It's the kind of the genesis of every other class in the base class library. So if I were to click on the system.io.stream link, as you can see, the stream provides a generic view of a sequence of bytes. Now, when we were working with a stream reader, we were working with a sequence of bytes that were stored in a file. All right. If we were to click More, we can see all of the children of the system.io.stream class. All these classes derive from system.io.stream. And we see our file stream class right here, but it has a number of siblings. Each of these derive from the same base class, system.io.stream. In other words, they all work with streams of bytes, even though how they work with those bytes might be dramatically different. Some of these streams of bytes work with streams of bytes in database data like Oracle or SQL Server. Some of them work with streams of bytes that are stored in zipped files, some with bytes that are streamed over the internet, and a lot more. Okay, so what I understand when I look at all of these classes is that they will help you work with bytes of data. They're all similar in how they work because they all derive from the same parent, the system.io.stream class. But the way that they work internally and what they do for you is just a tiny bit different, all right? So from a practical standpoint, once you learn about how streams work generally, you can expect similar behavior as a user of the various stream classes that we see here. Instead of just memorizing the specifics about each class, you can kind of fumble your way around, associating things you know about other stream classes to a new usage of a stream-based class that you need to work with now. So inheritance is a core concept in the .NET Framework class library. It benefits you and I as users of the base class library because now, once we get the notion of a stream under our belt and working with stream, we can work with all different kinds of streams in a similar fashion. All right? Let's minimize that. All right, so let's move on now. I want to go back to the car class. You can see here I have this format me method that we've created. And it just happens to be called from this print car details helper method right here. Great. But suppose there's something about this format me method that simply won't work for trucks. After all, at the moment, its formatting is really geared towards cars. It doesn't even consider the fact that there might be other properties that could be implemented. So not to worry. You can override the implementation of this method in the truck class, in the derived or child class, by using the same method name and signature like so. And in this case, we'll make it show the make, the model, and the towing capacity. All right? But we're not done. In order to really make this, to make this work, we're going to have to go back to the car class where it's overriding this function, and we're going to need to say that you can override it. So we'll make it overrideable. The overrideable property or attribute means that if you want to override this, go ahead. If you don't, that's fine too. We have a base implementation for you to use if you choose as an inheritor of our class to not implement it. But if you want to override it, go right ahead like we've done here. All right. So when you run the application this time, notice that the information that we print out between the car and the truck, it's different. We're actually printing out, in this case, towing units or towing capacity as opposed to just the year and the color. Okay. So we can also change this declaration in the car class from overrideable to must override. So let me comment this out and do something like this. Public override, public must override function format me as string So I'm going to change overrideable to must override, which basically says if you derive from me, that's cool, but you have to change this method to suit your needs. I'm not going to support any crazy idea that you come up with. You got to create your own format me method if it's anything but car. All right, so that would force us to create this overrides function format me in the truck class and any other class that comes after that also inherits from car. Okay. Now, if you make that change, you're also going to need to modify the definition of the car class to must inherit. You can see if we hover our mouse cursor over the car, you can see that car must be declared must inherit because it contains methods declared must override. So we can just click this to insert the must inherit, in which case we wouldn't provide a return or an end function because we would only say this is basically an abstract base class in object-oriented programming parlance. It's basically saying this isn't a real instance of a car. It's just the concept of a car that you have to inherit from. All right, so it changes the dynamics quite a bit. Now, using the must inherit in this particular context is not appropriate because we still need to define an implementation for the car itself, but that does bring up a larger issue. Maybe we shouldn't derive our truck directly from car, but instead maybe we should have them both derive from a higher level base class. And so what we'll do is create an abstract base class. We won't use the car as the abstract base class. We'll make it derive from, let's call it a vehicle class. So again, in this case, simply deriving truck from car might not be quite right. Some properties and methods available in car might not be applicable to truck. We may not care about, for example, the color of the truck. We just care about its towing capacity, okay, for example. So admittedly, in this simple example, it really shouldn't matter, but what if we had a more complex scenario? There might be some things about the car that doesn't apply to the truck. Well, in these cases, the best thing that you can do is back up a little bit and you create a special type of base class called an abstract base class. And the difference between a regular base class and an abstract base class is that you cannot create an instance of an abstract base class. The only way that it really becomes useful is when there's a concrete version of that class created. So this is exactly how the stream class that we just looked at works. Back in MSDN, if we look at that web page one more time, and if we take a look at the very top here, the sample implementation of the stream class, if it were to be implemented in Visual Basic, you'd see that it implements this must inherit class. So even if you take a look here in all of the properties, when overridden in a derived class, when overridden in a derived class, all right, all these properties have to be overridden in order for them to actually be used in a derived class. So in this case, the notion of a stream is just a concept. And the way that it's defined is simply a template, something that you can't create an instance of. However, if we were to go back to file stream is something concrete, something that we can actually work with and create an instance of and use, all right? So in the example that we've been using up until now, we might choose to create a vehicle abstract base class and then have both the car and the truck and maybe even other vehicles in the future, such as a motorcycle or a boat or a semi-truck or whatever the case, inherit from it. So let's introduce a new abstract base class. And when we do that, it's going to cause ripple throughout our entire code example. Let's start by adding a new class, and we're going to call this vehicle. And here, we're going to take all the properties we define in car and implement them in vehicle. And then we're going to take this public must override function format me as string. I'm going to copy that and put that in vehicle as well. Now we don't need a body for this because again, this is just an abstract must inherit class, all right? Now, back in the car class, what we'll do is remove must inherit and we'll say it inherits from vehicle. And that will cause some ripples. I'm going to get rid of this and put overrides instead. And now in the truck class, think we'll, instead of inheriting from car, we'll inherit from vehicle, like so. Great. And then back in module 1, what I want to do is I'm going to change this. Now you can see when we call print car details, it no longer works with my truck. Why not? Because truck is no longer derived from car, it's derived from vehicle, and only a car will work here. So we want to change this print car details. In fact, I'm going to call this print vehicle details, and we'll work with something called a vehicle as vehicle. And we'll say, here are the vehicles details, and we'll use the input parameter vehicle, like so. And now we'll change it here where we're printing vehicle details and print vehicle details. Okay, see how many ripples that made through our entire code base, but now when we run the application, we can see that it works once again. And so we were able to introduce an abstract base class that is just an abstract concept that's made concrete by those classes that inherit from the abstract base. Okay? So the antithesis of an abstract base class or a must inherit class is the sealed class, meaning that you cannot inherit from it no matter what. So you might never want another class to be able to inherit from your class, so you could mark it not inheritable, like so. Let's take the truck class, for example, and we'll say you can't inherit class truck. So now if we were to attempt to do something like this and create a semi-truck, like so, let's go below it, public class semi inherits truck, we're going to get a blue squiggly line that says semi cannot inherit from class truck because truck is declared not inheritable. All right, so the reason why you might want to do this might not be obvious just yet, but know that some classes in the .NET Framework class library are marked not inheritable. And so I think whenever you work with classes in the .NET Framework class library, be aware that almost every class is part of an inheritance hierarchy, and sometimes that points you in the right direction as to how they intended that class to be used. So if a class has a method or properties which are not readily apparent, it might be because it's inheriting the method or the properties from a base class or an abstract base class. You might learn a lot about a given feature of the base class library if you simply stop and take a moment to understand a little bit more about the parents of that class or its siblings or even the children that inherit from it. Oh, I'm not supposed to use this class. It's merely an abstract base class. Silly me. For all these other specific implementations, I'm supposed to use one of those instead of, for example, the string class, right? So you can certainly utilize inheritance in your own projects, and I think you will as time goes on, but frankly, that might be down the road a little bit from now. If indeed this is your first attempt at learning to program, regardless of the programming language. However, perhaps you're going to work at some point on a large project in the future where it makes sense to create some library of business rules and logic that can be applied and shared across the entire application or a suite or family of applications within your company. In those cases, you'll undoubtedly be in need of a good inheritance strategy. And again, there are good design patterns for properly utilizing inheritance in your application's designs. But for now, your focus will probably be on consuming and utilizing the libraries that are created by others, like the .NET Framework Base Class Library or others that are within your organization. The other takeaway from this is that there are a number of Visual Basic classes and method modifiers that the creators of the base class library have used in an effort to guide you or to push you in a certain direction when using their classes. By that, I mean that they create abstract base classes or sealed classes or use other modifiers in an effort to help nudge you, the consumer or the user of those classes, in the right direction and prevent you from doing something that would break those classes. It forces you to use them the way that they were originally intended. It's just a matter of realizing, I can't create an instance of this class. It's marked must inherit, all right, or it's static. Or, I can't derive from this class because it's marked not inheritable. It's sealed, all right. So once you understand a few of those key terms, you'll be able to interpret the MSDN help and understand what you're supposed to do with a given class or what your options are, all right. So hopefully that made sense. If not, watch this video again. There's no shame in that. Make sure you understand these ideas before we move forward. or at least understand them to the extent that you're able to duplicate this example and see what's going on. Don't move forward until you really get it, okay? So that's great. I'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps of the world's best companies as quickly as possible. So I've spent quite a bit of time in the past few lessons talking about classes because they're so integral to .NET. In fact, just about everything you do in .NET somehow involves a class. And we talked about how the .NET Framework Class Library is really just a collection of classes that contains functionality you can use, but you don't have to write yourself. Microsoft has already spent tens of thousands of man-hours writing code that you can just borrow by merely referencing the class name that you need and then calling the method associated with that class. And that was really the purpose of learning more about inheritance in the previous lesson. We said that Microsoft has created the classes in such a way that there's this rich inheritance hierarchy. It's a means of specializing and extending base classes. In some cases, it's beneficial to Microsoft because this allows for code reuse and ease of maintenance. In other cases, it's beneficial to end users like you and I because we can leverage knowledge about, for example, how streams work to all types of specialized stream classes. Stream classes for working with file data, network data, database data, and a lot more. And so we can leverage what we already know about streams and work with all kinds of different streams because they all inherit from a single base class, system.io.stream, I think it was. So the .NET Framework Base Class Library is composed of a rich inheritance hierarchy between classes. But because I really want you to understand how the .NET Framework Base Class Library was put together and how it works, and most of all, how you can get the most out of it, I want to talk about one final topic related to all of this, and that is to better understand how the code is organized and how to access some code that isn't just added to your project by default. So we're going to talk about namespaces, we're going to talk about assemblies, and we're going to talk about adding references to external assemblies using the tools in the Visual Studio IDE. So let's start by creating a new project, and we're going to call this namespaces, let's spell that right, namespaces, and referencing assemblies. All right. And so first of all, within the .NET Framework Base Class Library, all the classes are organized into namespaces. Well, what is a namespace? I mean, we've seen how we were using the import statement and I identified that as a namespace, but what really is a namespace? What's its purpose? Well, think of a namespace as a last name for classes. So, for example, my first name is Bob, but there are literally hundreds, if not thousands of Bobs just in the little town that I live in. If somebody were to say, Bob likes coffee, you might ask, okay, which Bob are you talking about? There's like a billion Bobs in the world. And if they reply with my full name, they're like, oh, no, I'm sorry, Robert Theron Tabor likes coffee. Well, now you should have a pretty good idea who they're talking about. I mean, I'm pretty sure that my middle name and my last name combined are pretty unique. So that might only identify one person in the entire world. The same is true with classes in the .NET Framework Class Library. With tens of thousands of classes in the library, it's possible that a single name of a class is actually shared by several different classes. However, by using the namespace of the class, it removes the ambiguity. While you might know which class you intended to use, when you go to compile your source code, the Visual Basic Compiler, as it tries to make sense of your code, as it tries to create an executable file, an assembly, it tries to resolve the reference to each class that you reference in your code. And we saw that a few lessons ago whenever we typed in the word stream reader in the IDE, it complained, it said, I have no idea, I don't recognize that class name. Where did you get that from? So when the compiler is confused, it stops immediately, it refuses to continue on the process of compilation until you explain further what you meant, and that is called a compilation error. So when I wanted to reference the stream reader class, I had a couple of different options. The option I chose was to use an import statement, but I could have done something like this instead. Dim my stream reader as new system.io.streamreader, and then I can give it some file name .txt. Okay. So you can see here that I'm using the full name of the class name itself, as well as its namespace. So first of all, this system part is a top-level namespace that many other namespaces and classes belong to in the .NET Framework class library. Secondly, the IO namespace, the sub namespace, I guess you could call it. I don't think it's usually called that, but it contains namespaces and classes that deal with IO, in and out, or rather getting data into the application and sending data out of the application. And so then third is the actual class name, stream reader. So this system.io namespace, when you combine it together, first of all, it shows you that namespaces can and often do contain other namespaces. So the IO namespace is actually part of the system namespace, kind of a sub namespace. Again, I'm not sure if that's the right terminology, but you can use any number of additional namespaces. So we could continue to build on to a third namespace, a fourth namespace, and so on, as deep as we'd like to create it. However, the developers of the .NET Framework class library realized that too deep of a nesting structure with the namespaces would add too much complexity. So I guess the takeaway from this is, first of all, most of the namespaces in the .NET Framework class library are either they either have two components or possibly three, but generally never more than three. And so, again, the takeaway here is that if you're ever in a position to create your own libraries and you want to use namespaces to disambiguate the class names, then you probably should strive to use as few namespace, sub-namespaces, I guess you could say, as necessary to help those who are consuming your code find what they need. So, again, as we take a look at this line of code, you might be asking if you always have to do this sort of thing. We said there were two ways to resolve that stream reader issue. The first was to use the entire namespace every time, but that's a lot of typing and it's unnecessary. The other option is to use an import statement to shorten the amount of code that we really have to write from this point on. So an import statement provides access to all the namespaces and classes that belong inside of that namespace so that you don't have to type it all out from that point on. So you're telling the compiler, hey, I'm importing these namespaces. Look here at the top of the file. It'll apply to everything inside of this file. So before you complain and you say, I don't recognize one of the class names, please check these namespaces first to ensure that the class that I'm referencing in my code belongs to one of them. If it doesn't belong in there, then go ahead and complain, okay? So as it turns out, Visual Basic hides all of the imported or the default imported namespaces from you to reduce the code clutter. But you can access them. You can see which ones are added by default for a given project type, like the console project type that we've been working with, by looking in the Solution Explorer. Let's pin this down for a moment. And if you take a look at this My Project icon and double click it, it'll open up the property pages for the project. And there's all sorts of things in here related to, I guess you could call metadata, things about the project that may or may not be compiled into the final assembly or might affect compilation. Now what we want to do is take a look at the References tab here, and you can see that, first of all, there are actual files that are referenced. So these are the files where basically the .NET Framework class library is implemented. And inside of those files, you'll see a number of namespaces that own classes. So if we were to look here near to the bottom of this list, these are the namespaces that are imported by default, the ones that have little check marks next to them. Now here are other namespaces that are available from this list of assemblies here that have been referenced, but they have not been imported. So if we were to scroll down and take a look, you can see that the system.io namespace probably lives inside of either, I'm guessing, this system.dll or system.core.dll, or possibly one of these others, but I think it's probably one of those two. But it has not been imported by default. If I were to select and click this and put a check mark next to it and then save, and now I could get rid of this system.io part and it would work just fine. We'd be able to compile our application. Let's actually build it, and it would succeed. Why? Because Stream Reader, the class name, can be found through this imported namespace. But if I were to deselect it, and you can see immediately the IDE complains with the blue squiggly line, and it gives us some options. We've already noted how we can resolve this by using an import statement. So typically I don't type import statements. Typically I just click the little option to add that line of code, import system.io. Notice when I do that, the blue squiggly line disappears. Again, I can build the solution. It succeeded in building, and so all is well. Now let me remove this line of code just to show you one other thing. If I was on this line of code and I typed it out, I knew I needed the stream reader, and then I realized, oh, I need to add an import statement. Typically what most developers do is hold down the control key and then the period on the keyboard, and that will pop open that little dialog without having to remove my hands from the keyboard. I can just use the down arrows to select the import system.io, and then I can be on my merry way, continuing to type. And I can move on from there, for example. Okay, so that control period is a way to add an import statement without having to use the mouse. Hover your mouse cursor over that little red dash that opens up the little red X dialog for the contextual menu that popped open. Okay, so let me just say this as well. Occasionally you'll attempt to use a class in the framework class library, but you'll get an error that says something about there being ambiguity. The reason is that you might have two import statements, or you might, through the use of the references tab in your property pages, you might be referencing two namespaces that have the same class name inside of them, okay? And you just happen to have imported both of them into your project. So when that happens, you merely have to type out some or all of the namespace before the class name. It's a simple way to resolve it. It just means that you just so happen to use two import statements or have imported two namespaces with this exact class name in it, and it still didn't know which one you meant. So we're going to type out the full system.io.streamreader in this case. Okay, doesn't happen very often, so don't worry about that, but just in case you ever see that. Okay, so one last tip. If you need to look for help on a given class name or a method name, sometimes in the search, whether you use Bing or Google or whatever the case might be, you might want to add the entire namespace. Otherwise, you might be looking at the help for a version of the class that belongs to another namespace. So if I was interested in the system.io.streamreader class, I would type in system.io.streamreader in search to find the MSDN article for that specific class. Not taking the chance that there's a stream reader defined somewhere else in the .NET Framework class library with the same name stream reader. And then I'm looking at the methods and they're not lining up with what I'm trying to work with. It happens occasionally, again, not often, occasionally. All right, so before we close the discussion of namespaces, let me point out a couple of things. First of all, every class that you create on your own, when we created the car class, for example, it will be contained in a default namespace. The default namespace will be the name of your project. And for simple applications, you will never need to modify or add additional namespaces. Secondly, if you don't use the project name as the default namespace, you can set it in the project properties. So if I go back up to the application tab of the project properties, you can see that the root namespace is currently set to the project name, namespaces and referencing assemblies, but I could change that to something like Tabor, for example, okay? And then from that point on, any of my classes, for example, if I add a car class, let's go ahead and do that. I'm going to go ahead and add a new class called car. And I'll just create one property, public property make as string. All right, and now if I want to use that, I can reference it like Tabor dot, and then you can see Tabor.car, all right? And of course, we're not doing anything with this. I'd have to call, a method, or create a new instance of car, but you get the idea. So that's the second thing. If you want to change the root namespace, you change it in the property pages on the application tab under root namespace. Otherwise, it'll be the name of the project, all right? And then third, likewise, you can create new namespaces for your own code using the namespace end namespace. So if I were to do this, for example, let me do a namespace Theron all right? And it automatically created the end namespace, and I'll paste that in like so. All right, now I should be able to reference the car class like follows. So dim my car as new tabor.theron.car. All right, see how that works? I was able to create additional sub namespaces by using the namespace end namespace structure. All right. So again, the technique is very simple. Now, the reasons why you might choose to do this, why you might choose to even introduce namespaces into your application architecture is a little more advanced. Again, if you set out to build large software applications and you needed to organize your code into namespaces, or organize your code in such a way that there won't be collisions between class names, then this will become more important to you. If not, don't worry about it. Again, advanced concept, you don't need it until you build bigger applications. All right, so let's move on. As we learned a moment ago, in an effort to keep the .NET Framework class library manageable, the creators split up the .NET Framework into a number of classes, or rather, a number of individual files. So there are tens of thousands of classes of code, and they split them up into a few dozen files. Why did they split them up? Well, if you had to load up one monstrous file with the entire .NET Framework class library, in most of which you'll never use, into memory, each and every time that you ran a .NET application, it would take up the entire computer's memory and be extremely slow. So instead, they put related functionality across many different namespaces into individual assemblies. And you can see them listed here by default, the ones that have been added to this project type, the console project. So when you create a new project, the template for that project includes references to several core assemblies by default. Of course, we've already been talking about the console window project type. If I wanted to create a WPF, or rather Windows Presentation Foundation application, you know, with a little bar on the top, and I can resize the windows, and I can actually work on the Windows desktop and create a graphical user interface using this portion of the .NET Framework class library called Windows Presentation Foundation that allows me to create those windows and the buttons and the text boxes and so forth. Then I would choose, when I go File, New Project, I would choose a WPF application template. And that template will contain and add references to several important assemblies required to build WPF applications. So again, just wanted to point out that these are the default assemblies that are referenced by the Visual Basic Console application template. So what do you suppose happens whenever you realize that you need a part of the .NET Framework class library that hasn't already been added? It's not part of this list of assemblies that have been referenced by default. Well, then you have to add a reference to that assembly. In fact, this is not only true for assemblies that are created by Microsoft and are part of the .NET Framework class library, but it's true of third-party assemblies that you want to use in applications, whether they're commercial products that you've purchased, open source libraries, or even libraries of business rules that are specific to your company or organization. You have to first add a reference to the assembly in the project so that when you reference the namespace and the class names, it will know which files to look in for the actual code implementation. So since I want to keep this as simple as possible, I've created a super simple library of my own called Tabor. In fact, to make sure this works, I probably should remove some things here. Let me go ahead and switch this back to the root namespace. Just leave it what it was by default. I'm going to comment out everything here just because I don't want there to be any conflicts or any problems. All right. And then I want to go back to the references dialog, and I want to actually add a reference to an assembly that I created, and it's available for download wherever you are currently streaming this video or from wherever you originally downloaded the video from. I unzipped that file into my documents directory, and there's a tabor.dll that I want to add a reference to in my project so I can use some of its functionality. So I'm going to click the Add button here below this list of assemblies that have been referenced in my project, and this will pop open the Reference Manager. And what I want to do, and you can see that there are just a bunch of files. Some of them have already been added, right? Like system and system.core, system.data. They've already been added, but there are just literally dozens of files, and some of these are for things like ASP.NET or creating Windows applications or working with data and so forth. All right? And we're going to ignore almost all of these. Instead, we're going to go to the Browse tab here on the left-hand side, and I'm going to click the Browse button. And I'm going to go to my Documents directory where I've unzipped Lesson 18 source code. And there should be a tabor.dll file in that directory after you've unzipped it. I'll click Add. And then I'm going to click OK to add that reference to that assembly. So now you should see that we have added a reference to the tabor.dll file. Furthermore, if we were to scroll through the imported namespaces, there's now this Tabor namespace that's available. And that Tabor namespace includes a class called Bob. So let me save what I've done so far. I'm going to go to the module1.vb here, and I'm actually going to comment all this out. Let's comment that out. All right. And here, we're going to write the following code. So dim Bob as new Bob. All right, so the first thing that might look odd is that I'm using the name Bob, capital B-O-B, as the identifier for a new instance of the Bob class. And that's completely acceptable. The compiler can figure this out. Typically, I would do something like my Bob, but I just wanted to show you that this was possible, all right? And so now we can work with Bob from that point on. But notice that Bob is not defined, so if I can import the Tabor namespace, and now it seems to locate everything just fine. And what I'll do next is I'm going to dim HTML as string equals bob.lookup. And what this method will do is allow you to pass in any URL, and it will go out to that URL on the internet, and it will download the HTML for that given web page or that website. So I'm going to give it the home page for my website, http://www.learnvisualstudio.net. And then I'm going to do a console.writeLine with the HTML that we've returned back from the lookup method of the Bob class in the Tabor namespace in the tabor.dll assembly, and then console.readline, like so. Now let's run it to see if it works. And after a second, it sure does. It brings back a bunch of HTML from my website. Awesome. And I also want to point out that while we reference that assembly from the Documents Lesson 18 subdirectory, once I create a debug or release version of my application, it will be found in the bin/debug or bin/release folder. So let's go to Projects, Namespaces and Referencing Assemblies. We'll go in the Project folder, in the bin folder, in the debug folder, and now you can see that it's copied that assembly that it will need for this application to run. It copies it into this folder so that we can package the whole thing up and distribute it onto somebody else's computer, knowing that this executable file relies on the existence of tabor.dll. And you might be wondering, okay, well that's cool, but where are all the .NET Framework assemblies? Well, that's why that whoever uses your .NET framework, your .NET application, whether you build it in Visual Basic or C# or C++ or F#, whatever the case might be, when they have to install the .NET Framework runtime on their computer, and it will contain all the assemblies. And you can just rely on those base assemblies being part of the .NET Framework class library that are already installed on everybody's computer, everybody's Windows computer, and your application will work, will reference the assemblies that are already installed on their computer, and then any additional assemblies that are needed by your application will just be copied over in the same folder as your executable, and there's a number of different deployment strategies, but that's the most basic one, okay? All right, so let's go ahead and recap what we talked about in this lesson. We learned how classes are organized into namespaces to help disambiguate class names, or rather, to help avoid name collisions between two classes that are named exactly the same thing. We talked about the import statement that allows us to shorten the full name of a class by telling the compiler that it should first attempt to resolve all class names against those namespaces that we've added into the import section at the very top of our code file. I also demonstrated how to use the IDE to help find namespaces for classes that we want to use within our application. We also looked at the control period technique, or the drop-down contextual menu to add import statements. We looked at how we're able to make changes inside of the properties for a given project on the References tab. We talked about the topic of how code is packaged into assemblies, and that when you create a new project from a template, part of the job of the template is to add references to commonly used assemblies. The .NET Framework class library is so large that it wouldn't make sense to load the whole thing up and to reference every part of it every time that we needed to run our application, when we only need a little part of it. So that's why they split it up in all these different assemblies. Additionally, many companies have created their own libraries of code that you might need to use if you go to work for them, and they encapsulate the business logic that are necessary to work in a given area of the business. Also, there are third-party vendors as well as open source projects that provide libraries that you might want to use within your application. In these cases, you have to add a reference to the assembly that contains the given library of code that you want to utilize. Okay, so up next, we're going to talk about those mysterious private and public keywords that we've seen, I've referenced, but we've largely ignored up until now. So we'll discuss that in the next lesson. We'll see you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps to the world's best companies as quickly as possible. So we haven't spent much time talking about scope with regards to variables. So I want to more fully explain that concept and then use that as a launching pad to explain the keywords private and public that you've seen several times in relation to writing methods inside of classes. Now, before we jump into that topic, let's talk about variable scope. Let me start by saying that whenever you declare a variable in a code block, that variable is only alive for the life of that code block, meaning that when that code block is finished executing, the variable that was defined inside of that code block is no longer accessible, and its values are disposed of by the .NET Framework runtime. So let's take a look at how that applies to common code blocks that we've worked with up until this point. Let's begin by creating a new project called Understanding Scope. So while I'm just going to start with talking about like strings or integers or something along those lines, I guess integers for the most part, these concepts that we talk about will also apply to object variables, the variables that hold references to new instances of classes, all right? So just keep that in mind, and we'll elaborate on that a little bit later. But let me start off by just doing a for. In fact, I'm going to go ahead and go for I equals 1 to 10. And console.writeLine the value of I, and console.readLine. Great. And as we would expect, this will just print out 1 to 10. All right. Now, what if we were to try this? Console.writeLine I. Well, you can see, first of all, as I try to type in the letter I, I'm fighting IntelliSense. It doesn't let me just type in the letter I. It wants me to do int or int16 or something like that, right? So if I just hit escape on IntelliSense and move my mouse cursor off, I see a blue squiggly line, and I see a little red X icon, and it's asking me if I want to generate a stub for I in module 1, or if I want to generate a field for I. And so here we see that the result of trying to access a variable that's declared inside of this code block will not be accessible outside of that code block here in the remainder of my submain. All right? So I'm going to comment this out. I'm going to try another little test here. Let's go here, and we'll do a dim j as string equals empty string. And then inside here, I'll go j equals I dot toString, and here I'll do console.writeLine the value of j, and I'll actually do this j equals and then I'll use the ampersand and J, like so. All right, just another way to write a string using concatenation as opposed to like the replacement syntax that we've been using up until this point. All right, so we run the application and we can see that at the very end of the iteration that J equals 10 because that was the last time J was set. If we look at our code, J was set inside of the for loop. However, it was declared outside of the for loop, kind of in the same area here as the rest of my sub main. Let's take this one step further, and we will try doing this. We'll create a private field, private k as string, and we'll set k equals to I.toString, and we'll try to access k like so. K equals. All right, will this work? Will we be able to retrieve the value of k and display it? And we can. And why is that? Because even though k was declared outside of the scope of submain, it's within the scope of module 1. So k is available inside submain and would be available even outside of submain in any additional helper methods that we wanted to create. And we'll do that in just a moment. So just to reinforce this idea, let's, inside of the for loop, let's try to do this. If I equals 10, then dim_l as string equals I.toString. And then we'll attempt to read out console.writeLine L equals, and then we'll ampersand L. And you can see that I'm already fighting IntelliSense. It doesn't recognize the variable L. It wants me to type the letter long. I'll hit escape, and I'll try to move off of that line of code with my arrows, and I see the blue squiggly line. So L is not available. Why? Because it was created inside of this if statement. Is it even available outside of that if statement? Let's take this line of code, and let's attempt to move it up into the for loop like so. And I still see the blue squiggly line because once again, it's not usable outside of the scope in which it was declared. It was defined inside of this code block, and yet we're trying to access it from the outer code block, and that's not possible, all right? The only thing that we could do in this case is to move that into the same code block like so, at which point it should work. And it does. You can see L equals 10, okay? So let's take this idea one step further. I said before with regards to K that it should be accessible not only to submain, but to anything else kind of at that same module level. So if I were to do this, private sub helper, lowercase h in helper method, and console.writeLine, and we'll set K from helper method equals, and then K. Does this work? Well, we have to call it actually. So let's call helper method right here, like so, and now we can see that K is accessible from within the helper method. It is set equal to 10. All right, so hopefully if you've had any confusion or misconceptions about variable scope, we've cleared it up in this little example. Again, you can only access variables or object variables or whatever the case might be inside of a certain scope. The scope has to be within the declaration of the given variable. So in this case, with private k, a string defined at the module level, it's accessible to anything that's a sibling to where it was defined, or any child of the module 1. As we've declared I inside of this for next statement because of its declaration right here, we can only use it inside of the for next statement. We can't use it outside. As for J, we're able to use it inside of the for loop and outside of the for loop because we defined it at the main, sub-main level. All right? So hopefully that makes sense. And let's continue on from there. So in the methods that we've written in previous lessons in classes, we've always started with the words either public or private. And so let me just add a class. And again, we'll work with car, like so. and I'll paste in from my clipboard. We've used the word public for the class name, public for the property name, and so on. So these are called accessibility modifiers, or they're also known as visibility modifiers, and they're used to implement the tentative object-oriented programming called encapsulation that we talked about previously when we created the long form of the property and showed the private field that actually stores the value, and we use the get and the set of the property to allow access or restrict access to that hidden private field value. All right. So in a nutshell, classes should be black boxes. So when I think of a black box, and when I think of an example for this, I think about the old style television sets like when I was a kid. When I was growing up and when I was a kid, we had a simple television set. It had an on-off button and it had two dials, one for volume and one for the channel, and that was it. If you wanted to actually change the channel, you had to get up from your chair, you had to change the channel on the television set, and that's what kids were for, right? So it also maybe on the back had a place where you could attach an antenna and an electrical cord with a plug on the end, and that was all. Everything else about the television was self-contained. As a kid, I was fascinated once or twice when my dad would take the back off the television set to replace a tube. I still don't know what he was doing inside of there. It seems like a magical device with all these tubes and wires running every which direction. All I needed to know how to operate the television was through its public interface, the dials, the button, the power cord in the very back. And frankly, to use the TV, that's all I needed. The same should be true of classes that we create. All the important behind-the-scenes functionality should be encapsulated behind public methods and public properties. That's really the interface from a programmatic standpoint that other code should use to interact with our class. They should know about how our class is implemented under the hood. All right? The class might have private properties. It might have private fields, in other words, as well as private methods used to enable all the magic that goes inside of the class. But the consumer of the class shouldn't have to know anything about the inner workings of the class in order to work with it, to operate it. All right? So in a nutshell, private means that the method can be called by any other method inside of the class, but not outside of the class. So you use the term private helper method just like we learned about several lessons ago. So let's create a private helper method. Private function helper method as string, and we'll just return howdy partner. All right, and then we create public methods, whether it be a sub or a function. Do something, and inside of there we can do console.writeLine, and we can call the private helper methods, but the only way we can get to the private helper method and any other code that might be contained within is to use it through any of the public properties or public methods that have been declared. So if we were to come over to here and right above the console.readLine, we were to go dim my car as new car and my car dot, and you can see all we can get to are the four properties that were made public, and then this public do something. And I could console.writeLine, well, I don't even need to do that, do I? I can just call it like it is, like so. And you can see we get howdy partner. Now, where did that come from? How was that implemented? From all I know, as the consumer of the car class, the do something method works some magic internally and returns the value, and that's all I care about. I don't care about how it's implemented internally. All right, so that's the notion of encapsulation. Now, let me just say this. In a real project, I would never do this. I would never actually print anything out to screen. That's the responsibility of presentation code, not, in this case, the car code, the domain class. And I realize you have absolutely no idea what I'm talking about. Just never do that. I explain the reasons for this in a series on application architecture on my own website, www.learnvisualstudio.net. And so that's kind of an advanced topic. But just know that you probably should never call console.writeLine from a class. Okay. Okay, so in a sense, the consumer of the car class has no idea that the helper method even exists. All it knows is that to accomplish its task, it needs to call do something. Obviously, now we as developers, we can go into this car.vb file and we say, oh, I see how they did it. All right, but that's not what we're talking about here. If we became, in a sense, the submain, and we looked at it from its perspective, we wouldn't be able to see how do something worked internally. Now, admittedly, this is an extremely mundane example. Its only real value is to illustrate the notion of encapsulation and hiding the implementation while exposing a public interface, and that's all I really intend for that to be. All right. So the next thing I want to do is talk about the naming convention that I used, and we spoke about this a couple lessons ago. I just want to reinforce it now. Whenever something is public, whenever we define something as public, whether it be a property or a name of a method, it should start off with a capital letter and then use camel casing from that point on. Whenever something is private, it should start off with a lowercase letter and then use camel casing from that point on. And this is just a naming convention. Are you free to break the naming convention? Absolutely. Knock yourself out. You don't have to pay attention to this at all, but you might do so at your own peril. Other programmers are going to look at your code and they're going to say, what were you thinking, man? And so it's just an easy way to identify the accessibility of a given method or property field by looking at its name and deriving from that whether this is a private or a public method, a private field or a public property. All right. The same would be true for variables and things of that nature. Notice that all the variables that I use here in my example in what I would call the local scope, local to submain, I use all lowercase letters, even this private K here at the top. Why? Because again, they're either private and local to submain and cannot be seen outside of submain, or they're private to the module and cannot be seen outside of the module in the case of K. All right. So what's the purpose of this pithy little example that we've gone through? I really want you to be thinking about primarily using this information with regard to the .NET Framework class library. However, if you ever were to build your own custom classes, you should strive to expose public methods that give a simple, straightforward, obvious usage while keeping other helper methods and functionality privately tucked away and unavailable from prying eyes. You don't want developers fiddling around with your innards of your classes and potentially using your class. You want to give them a way to use the class properly through public methods and public properties through the methods that you design. All right. This also removes ambiguity and it makes its usage obvious and clear. So in the .NET Framework class library, methods and properties are exposed using the keyword public. They might also use private methods and fields, but you'd never know. They may use other types of accessibility modifiers, such as protected, which is a third accessibility modifier we didn't talk about. Basically, a protected method in a base class is visible to its derived classes, but no other classes. And private methods in a base class cannot be seen by its derived classes, so that's why you needed the notion of protected, so that you can make those helper methods available to any of the derived classes. So as you can see, the accessibility modifiers like public, private, and now protected provide different levels of visibility depending on what the author of the class deems necessary. So just be aware of this. If you can't access something that you think you should be able to access, it might be because that particular method is hidden or by private or protected on purpose. All right? So in this lesson, we talked about variable scope, how variables have a lifetime, I suppose you could say, based on the code block in which they're defined. When the current code block is part of the current scope of execution at runtime, then the variable will be available. When the current scope of execution no longer involves the code block, so in this case, in the for statement, when we've moved out our scope of execution no longer involves the for and we've moved past it, then the variables that are declared inside, like the I variable, for example, will no longer be available. And we also talked about accessibility modifiers like public, private, and then finally protected, and how that might impact the way in which we use the .NET Framework class library. And perhaps even someday, whenever we sit down to create our own class libraries, making sure to hide the implementation details and the private helper methods behind public method interfaces. All right? Hope you got that. You're doing great. We'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps, the world's best companies, as quickly as possible. So in this lesson, we're going to harken back to those simpler days when we were learning just the if-then statement and the while loop and the for iteration statement. We'll talk about another decision statement called the select case decision statement. And then we're going to talk about a different data type that you can create called enumerations that limit the number of values that can be set for a given instance of that type. And then I'm going to show you how these two ideas kind of dovetail together nicely and how you can use them to work together to accomplish what you want in your applications. So if you recall way back in our discussion of the if, then, else statement in lesson number 7, I believe, we used a number of if, else if statements like so. If user value equals 1, then do this. Else if user value equals 2, then do something else. Else if user value equals 3, then do this other thing over here. Else, and this is the catch-all case, so do something in case none of those were true. And then we had finally an end if. Well, honestly, that syntax works just fine. But generally, if you have a lot of potential values that you want to evaluate, say 10 or 20 or even more values, then you can write the same intent more succinctly by using the select case statement instead of the if, else if, so on. So in this case, that we just talked about a moment ago, there are only 3 cases that we're checking for plus an else. But what if we had 10 or 20 or 30? Well, that passage of code would be really long, and you can shorten it up a little bit using the select case. So let's do this. We're going to create a new project called Using Select Case. And we'll create the following here. Okay, so I'm guessing that if you stared at this for just a moment, you could probably figure out how this works. However, in a moment, I'm going to explain a couple of aspects in more detail. So let's start running this to see the results. Type in a superhero's name to see his nickname. I'm going to type in Batman, and it returns Caped Crusader. All right, and I could try the same thing with Green Lantern, Emerald Knight, and here I'm going to try Aquaman. Does not compute. Okay. Alrighty, so just to leave no stone unturned, we're evaluating the value of the user value variable. And we see a very succinct syntax that allows us to evaluate, again, several known possibilities. Could it be Batman? Could it be set to Superman? Could it be set to Green Lantern? Also, I want to point out that we're using the 2-upper so that we're comparing apples to apples and oranges to oranges. Remember way back when we attempted to compare a lowercase word and an uppercase word, said if lowercase word equals uppercase word, then say true, else say false. And so we were able to see that in Visual Basic, strings that are have different cases but have the same basic letters, they are not equivalent. So we want to compare apples to apples. We're always going to do a 2-upper on any value that we retrieve from a user so that we can compare it against something we expect. All right. And just so you know, I mean, there's some indentation level here. This would be considered the code block that is contained by this particular case statement. So while we only have 1 line of code, we could have 10 lines, 20 lines of code, whatever it took until we hit the next case statement. All right. It's just that we have kept things simple here. Once we hit the evaluation of our case, no other cases are evaluated. So for example, if we were to run this and type in Batman and hit enter and start stepping through our code like so, we see it evaluates the case Batman and then it jumps all the way out to the end select and no longer will consider any additional cases, just as we might expect. Okay. Now there is a code snippet for this as well. If we typed in select and then tab, it creates this snippet for us. We can use again our tab key to go between the variable name that we're evaluating as well as the various cases using the tab and change those up if we like. It's not as useful in Visual Basic as it is in C# if you were to watch that version of this video, but still helpful nonetheless. All right. So what's the difference essentially between the if, then, else if, else, and if statement and this select case, whatever, and select statement? Well, in some situations, it can improve the clarity of your code, especially when there are many possible values that require an evaluation. In this simple example, because I don't want to type for several minutes, I just use 3 cases. It may not look all that impressive, but the if-then statement can handle more complex situations, and it's generally a bit more verbose whenever you need to evaluate many possible scenarios. But let me show you an example of where the if statement shines. I've created this project. It's available for you to download wherever you're currently streaming or where you originally downloaded this video from. It's called Complex If Statement. It's part of the Lesson 20 resources, probably in the after folder. And so here, let me just run the application. You can pick a number between 1 and 100, and it's going to tell you if you found one of the lucky numbers. So I'll type in 34 and hit enter on my keyboard, and it said you didn't find one of the special numbers. And if you take a look at the if statement here, notice that we're looking basically the compare value that the user types in to say whether if the value is less than 1 or greater than 100, then we'll give one message. If the compare value is equal to 42 or 23, or the number is greater than 90, then you found one of the special numbers. Otherwise, you didn't find one of the special numbers. So we're able to do some pretty complex and, ors, the else's, and we wouldn't be able to accomplish that in a select case, but we're able to do things, again, succinctly when there's a lot of potential values and they're rather simple in nature like we see here. Okay? So let's move on to another concept. I'm actually going to save this project and start by creating a new project called Understanding Enumerations. As we kind of transition here, enumerations. All right, enumerations are a data type, but they only allow a small list of possible values. Enumerations constrain the data, forcing it to comply to only one of several possibilities, and in so doing, make your code much more reliable. Generally, comparing magic strings like we've done up to this point, where we're comparing lowercase Batman to some magic string Batman that I've created, is a bad programming practice. So we've accounted for that possibility in our example by using the toUpper method for string comparisons to ensure that we're comparing 2 strings that have a chance to match regardless of capitalization. But what about Green Lantern? As we saw previously, I think I've already closed it down, I have Green Lantern as 2 words. Is there a space between those 2 words? Is there no space? And so that's why often in the .NET Framework class library, the creators of the library force you to set some property value equal to an enumeration that they've defined. And you see them all over the place, and this prevents errors from occurring in your code. So for example, if I wanted to set, for example, the console's foreground color, notice that immediately when I use the equal sign, it pops open an enumeration called console color dot some color. And so I could choose, for example, red. Or if I were to type in console color, color dot, it would show me all of the console color enumerations that were created. So somewhere there's a class defined as console color, and it's created a value for each of these colors we see represented here. And then foreground color, the property foreground color is of type console color, right? And so we can do this and console.writeLine, hello, and console dot read line, and now we can see that we've turned the color, the foreground color, to red. So again, a small example, but this sort of thing is used all over the place. So when you see that a given property is set to, and you can see the definition here, public shared property foreground color as system.console color is not string. Can't I do this instead? Just type in, give it the color red? Well, no, I can't give it a string. After a moment, let's see if it'll accept that. No, it doesn't. Invalid cast exception. It can't figure out the string red and that you want to turn that into a type of console color. Right, so let's turn that back. Console color. Let's turn it to red, like so. Okay, great. So the foreground color property, again, think of it this way. It's constrained to only offer viable colors. I can't just use a literal string red because foreground color is not of type string. It's of type enum console color. Somewhere there's an enumeration defined that's called console color in the .NET Framework base class library that defines all the possible color combinations allowed in the console .foreground color property. Again, the benefit is to you, the developer. It forces you to pick the correct value, and that leads to higher quality code. You can't make a mistake. It will find the mistake at the point of compilation. You might misspell the literal string red. I don't know. You might miss the E or the D, okay? And you might not catch that until runtime. However, using enumerations, that error would be caught at the time of compilation. So again, our goal here is to point out that sometimes you're going to deal with properties in the .NET Framework class library that are of some enumeration type that Microsoft created. So be aware of that. Pay attention to the IntelliSense, which will guide you in the right direction. Now, having said that, let me show you how to create your own custom enumerations in Visual Basic so you can better understand how this works. And yeah, maybe at some point you might even utilize them whenever you're creating your own frameworks, wherever you're creating your own classes and custom applications. So what I want to do is start by opening up the Solution Explorer, and I'm going to add a new class. And I will change the class eventually, but I'm going to start out by calling it superhero.vb. And by default, it has the name or the code snippet, public class and end class. And what I want to do is modify that and remove the class and use enum instead. Enum, like so. And now, let's see what this says. Enum superhero must contain at least one member. We're going to do it right now. Batman, Superman, Green Lantern. And we could add others if we wanted to, but let's just keep it kind of equal to what we did previously. And so when we go back into our module.vb and we start doing something like this, dim my value as superhero equals, oh, there you go. IntelliSense is pushing us towards one of those three values to initialize that my value variable. So very cool, right? So now what I want to do is rework that example from earlier where we allowed somebody to type in right line, type in a superhero's name to see his nickname. And what I'll do is I'll compare the literal string to one of the enumerations that we created in the superhero enum in the superhero.vb file. All right, so let me work on this for just a moment. Notice how IntelliSense helped me when as I was creating that case statement. It's giving me options to choose from there. With the code that we have so far, there's a little bit of an issue here. We retrieve a string called user value from the readLine method. However, we want to compare that user value string to my value, which is of type superhero. So how are we going to do that? Well, I'm going to need to add the following if-then statement around this. So if superhero dot try parse, and I'm going to give it the user value. I'm going to give it. I'm going to use the second version of this. So I know I'm going to give it true and my value, and I'll come back and talk about this in just a moment. Then we'll wrap the else if around it like so. All right, and honestly, we won't even need this anymore, but I'll go ahead and leave that in there, okay? So let's talk about what's going on here in line number 13 here. So this is hardly a foolproof approach, but it does demonstrate this try parse, which is a built-in method to enumerations. We're trying to parse a string, user value, into the data type superhero. All right, so this try parse is either going to return a true or false. You can see it returns as Boolean all the way there on the right-hand side. That means it's either going to return true or false, that we were able to successfully find a match between whatever the user typed in and one of our superhero enumeration values, either Batman, Superman, or Green Lantern. So if it's true, then we're going to take the value, the superhero enumeration value, and compare and say, well, which one did they use? And then fire off the appropriate code block as a result. However, if try parse returns false, they typed in Aquaman. Try parse can't find a match. The else statement will fire, unable to find superhero by that name. So try parse will return true or false depending on whether it was able to successfully find a match. Now this middle, you can see here as we go, let's see, try parse, let's see, yes. Ignore case, true. We don't want to evaluate the case. So if somebody types in all lowercase letters or all uppercase, we're not going to factor that in. We want to ignore the case whenever we're evaluating our literal string against the enumeration name, okay? So if we start debugging this application and we type in Superman and we see Man of Steel. So what's the real benefit here? I mean, it still seems a little bit on the fragile side, right? Well, yes, it is a risky proposition because now we're relying on our users to type in the exact value. This might not be the best way to use the select case, but it does illustrate what it does, all right? But the value here is that I'm moving away from relying on literal strings, comparing literal strings together, and I can rely on the fact that whatever the user types in will match one of the enumerated values, and if it doesn't, then we can catch it here, all right? So again, we're not working with unreliable magic strings, we're working with strong types within our code. And that's really what I wanted to get at with the select case and the try parse. Okay, so let's recap what we talked about in this lesson. We started off by talking about the select case statement, another decision statement. It's a little bit more succinct, but not as flexible as the if, then, else if style syntax that we've been using up until this point. However, it does great whenever you have a long list of potential values and you want to do something slightly different for each case. Then we looked at enumerations, especially those that we see in the .NET Framework class library. We use this as an example, but I promise you they are all over the place in the .NET Framework class library. Again, the value is that it restricts possible values that you can set a given property to, and that's a good thing. Restriction in code is a good thing because it ensures that your code is of higher quality. Then, just to prove how all this works, we created our own enumeration of type superhero, and we showed how to combine our enumeration with the select case. We used the try parse method to attempt to convert a string into enum values that we created. If it works, the try parse returns true, which allows us to evaluate against our select case statement. If try parse is false, then we're able to catch it in an else statement, right? So that's all that I've got to say for this lesson. We're working our way through this. You're doing great. Hang in there. I think the hard part's over. Well, I take that back. The next lesson's going to be pretty tricky too. We'll see you there. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. So in this lesson, we're going to talk about handling exceptions that occur within your application. We're going to discuss what can go wrong, why things go wrong, and how to build resilient applications that are impervious to crashes through the use of the try-catch block in Visual Basic. So when the compiler catches a data type mismatch in your code, when it catches any unresolved references to classes or any malformed Visual Basic instructions, it'll refuse to compile your application. It'll refuse to compile the Visual Basic code you wrote into .NET assembly until you fix those exceptions or those problems. These types of problems are called compilation errors. Those are not what we're going to talk about in this lesson. There are other kinds of errors that happen during runtime, or in other words, they happen whenever you have the compiled .NET assembly and it's actually being executed by an end user. So there's countless of reasons why a compiled .NET assembly can encounter an exception, but many times it occurs due to situations that are outside of the control of the developer. For example, if your application can't read or write to disk because the disk is full, or the file or the folder is missing, or it's somehow corrupt, or because network access to that resource is unavailable, or perhaps you're trying to access data in a database and the table that you need no longer works, or the login credentials don't work for whatever reason. All right, these are all reasons why the application might encounter an exception at runtime. And there are cases that the developer could have prevented but didn't foresee. They didn't account for it. A good example of this is doing any validation checking of data that's been typed into the program. This is something the developer should have been able to catch, but maybe they didn't do sufficient testing, they didn't have enough time, they just didn't have the experience or foresight to see what could possibly happen to any input forms on their application. So the user, the developer creates a field that would allow the user to type in the country and expects the user to type in the country correctly, but instead the user maliciously types in numbers instead of alpha characters, and it causes a runtime exception and it crashes the application because that exception was not handled by the developer. Okay, so as a software developer, your job is to make sure that you account for these possibilities. There's also typically in larger organizations a quality assurance team who test your application to make sure that it goes out the door without any defects. Also, sometimes companies run beta programs and have users test the application, but even at that, you can still have subtle bugs creep into an application because the developer, ultimately responsible for the quality of the application, didn't foresee the potential problem. So a friend of mine was fond of saying that 80% of code exists to solve or account for 20% of potential problems that could possibly occur. Generally, software developers should be pessimistic of the reliability of all outside input to the program. So if you rely on a file or a network resource, you should treat it with great suspicion. If you rely on an end user to type data into your application, then you should treat it as being evil, and you should do checks upon checks upon checks to validate that text that the user typed in. So this is the software developer's equivalent to driving defensively. You should be coding defensively. And the way, or one way, that a Visual Basic developer codes defensively is through the use of the try-catch block. So what I want to do is open a project that we've already worked on. We're going to work with the read text file while project from back in lesson number 12. And what I want to do is I'm going to perform a little sabotage on this application by renaming the values.txt file to something different. I'm going to rename it to values1.txt. So now when I attempt to run the application, you'll notice that we get this this exception. We've seen this before. In this case, it says system.io.file not found, exception occurred, and with additional information that it couldn't find the file. It was looking for values.txt in the debug folder, but it wasn't there. All right, so let's continue that, and actually I am going to build this solution. Great. So now let's take a look at what this looks like from an end user's perspective. Let's go to Visual Studio 2013's projects folder. We'll look for the read text file while solution folder, the read text file while projects folder, the bin directory, debug directory. Notice that we now have a file called values1.txt. When I double click the read text file while.exe, this is what the end user would see if we distributed this application to their computer. Now, because this is a console application, they're going to get this full text printout of what the problem is. However, they would typically see, no matter what kind of application it was, like a Windows Form or WPF application, something that looks like this. There was a problem that caused the program to stop working correctly. The dialog says that Windows will close the program and notify you if a solution is available. And so it's kind of an ugly situation, right? You don't want your users, your end users, to experience that. Instead, you want to be able to bounce back from these types of situations from occurring. And so we want to try to account for these, and the way that we can do that is through adding a try-catch around the offending code. And so what we can do is just type in the word try and then hit enter on our keyboards, and this will kind of create the try, catch, and try. So the try is where we're going to put the logic of our code. Anything that we want to ensure that it will work correctly and that we're suspicious of. The stream reader class is something that I'm suspicious of because it works with a string, first of all, string literal values.txt. It doesn't allow the user to pop open a dialog box and select a file. It's hard-coded in a magic string, the name of the file that we want to open. That's the first clue for me. Secondly, it works with a file, and I'm suspicious of anything on the end user's hard drive. They could have tampered with files or deleted files, and I need to account for the possibility that that value.txt file is not on the end user's hard drive. So to do that, what I'm going to do is take all of this code here that I suspect could be a problem. I'm going to cut it and paste it inside of the between the try and the catch. All right. Next up is this catch code block, and I'm going to delete this EX as an exception. We'll come back to that. But the catch is the code block that will occur, or that will be fired off whenever an exception happens. And we can do anything we want in here. Typically what you do is one of several things. You notify the end user. Maybe you write some logic to attempt to ascertain what the real problem is, and maybe you try to fix it yourself. That would be the ideal scenario. Depending on what the exception is, maybe you could ask the user, would you like to search on your hard drive for this file? Present them with the dialog, an open file dialog, let them look through, select a file, click open, and then rerun the code in the try. However, in this particular case, we're going to keep it very simple and just write to the console window just a message. Something didn't work quite right. All right. Not a very helpful error message, but it's an improvement over seeing the whole program essentially explode on the user's computer, like we saw a moment ago. All right. So we hit the exception. It pops us into the catch, where we actually then are printing to screen the error message. Now we can do a little bit better than this, and that's the purpose of this catch EX as exception. Now exception is a data type. It's a high-level class that all specific exceptions inherit from. And we'll see some examples of specific exceptions in just a moment. But all exceptions in the .NET Framework class library derive from this base exception data type. So that means any type of exception that occurs, we'll be able to get a reference to that exception, and then we'll be able to inspect things about the exception. So I should be able to add to this a string replacement code like so, and then use our reference to the exception that was thrown in the try. And there's a lot of different types of information we can get at. The source of the problem, a stack trace, so what methods were called prior to the exception being thrown. A lot of information that might be helpful for developers as they try to look through any telemetry information that lets them know what the user was doing prior to this exception to help them diagnose what the problem is in their own code. But for our purposes, we just want to display what error actually happened, or what the message, a friendly text message of what actually happened. So we're going to use this message property of our exception class. So now when we hit our exception, we get the something didn't work quite right, and then after the colon, we print out the message, could not find the file. And perhaps that's enough to allow the end user to self-diagnose, to look in that bin/debug/values.txt file and realize it doesn't actually exist by that name on their hard drive. But we can even do better than that. In Visual Basic, it's a little more difficult to find all of the potential exceptions that can happen. But as I look at my code, I want to look for those places where an exception could occur. One of the places it can occur is whenever we're actually creating a new instance of the stream reader. Here we're passing it the name of the file, and we know from experience and from this training session and from just reason that this could be a potential problem. Now, where can I go to learn about all the exceptions that could be potentially thrown by the constructor of the stream reader class? Well, hopefully you're immediately thinking about either a search engine or you're thinking about MSDN. And I was able to navigate to the stream reader class entry in MSDN. I've given you a shortcut here on screen to get there quickly. But you can do a search on Bing or Google to find this web page. After you've found it, then I'm going to go down to the list of constructors. You can see there's a bunch of overloaded versions of the constructor for the stream reader. I know that we're using this second version here that allows you to pass in a string as a specified file name. So when I click on that particular constructor, it gives me the MSDN page specifically created for this version of the stream reader's overloaded constructor. And look at what we have here, a list of all the possible exceptions that could be thrown by the stream reader's constructor that we could potentially handle. And so this is our guide. As we look through these potential exceptions, we should be thinking about handling these exceptions in our code. So a full-blown example would handle all of these. I'm just going to pick two of these, the file not found exception and the directory not found exception. But again, a more full breadth example would account for almost all of these exceptions. Okay, and so what I'm going to do is this. Above this catch-all, catch EX as an exception, I'm going to type the following. Catch EX as directory not found exception, and here I'm going to type in console.writeline the specified directory does not exist, and then I could perhaps give even more explanation on how to go about fixing this problem, but I'm just going to keep this simple. Then I'm going to create a second one, catch EX as file not found exception, and do something console.writeline the specified file does not exist. Check the folder, whatever folder it is, to locate the file. All right, and we're going to leave this final catch EX as exception. So generally, whenever you are adding catch statements to your try-catch blocks, you should start with the most specific exceptions first and then go to the most general exceptions that you would expect to see. So we're starting very specific, directory and file, and then moving to the most general, EX, which, as we said, is the base class for all exceptions. It's the most generalized of all the exceptions that could be thrown. So the next thing that I want to do, we'll go ahead and move this over. The next thing that I want to do is to trigger this first type of exception. I'm going to add a fake subdirectory called boo. And that, by looking in that fake folder that I just made up off the top of my head, we should be firing off this top exception to test our work. And you can see we get the error message, the specified directory does not exist. And so now let me remove that from the constructor and just look for values.txt again. And this time the specified file doesn't exist. Check the whatever folder to locate the file. All right, and so if there were other exceptions that were thrown, it would be caught by this catch-all at the very bottom. Okay? Well, there's one last thing that I want to point out about the try-catch block, and it's this finally block that we can add at the very end. And typically what you use this for is to, this is for code that should execute no matter what. And typically you would put here like closing database connections, closing file connections, any type of cleanup work that you would typically do, you would want to put it in this finally statement. Okay. And since we don't really have a complex example, we're not going to use it in this particular case, but you can see that's essentially what the finally statement is for. Code that must be run no matter what, whether this code works successfully or whether it fails. And we fire off one of the catches. Okay. All right, one last thing that I want to talk about before we wrap up here, and that is that as you look at this example, your first reaction might be, well, this is great. I'll just wrap a try-catch around every single line of code that I write, and I'll just add that at the very end of my software development cycle, and I'll be good to go then. And while some developers take this approach, frankly, it's lazy. Those developers are often ostracized by their end users for providing cryptic error messages that nobody can understand, not even the person that originally built them. So the reason that developers do this, however, is because they sometimes take that approach, that lazy approach, leaving exception handling to the very end of the development cycle, of the development process, instead of incorporating it in, identifying those potential errors or areas of the application that could experience problems, things that have dependencies on things that are outside of the developer's control, any connection to anything outside, whether it be the network resources, the file system, any hardware on the computer, you name it. If it's outside the control of the .NET framework or of the developer, if it's external to the application, then it should be created with great suspicion, and you should attempt to wrap try-catch around it and use the technique we use to find potential exceptions for that case and handle those. All right? So you should strive to put as much attention into protecting your user from guessing what to do next as possible. If you can fix the problem without the end user knowing it, then you should do it. If you can't, then identify the exact problem and then give the user some options. Ask them what they want to try to do next. So you should protect the user from losing data at all costs, and you should protect them from feeling stupid at all costs. That's what makes your application polished, and it's what users have come to expect, a reliable experience with no surprises. All right. So to recap, in this lesson, we talked about defensive coding through the use of the try-catch block in Visual Basic to plan for the inevitable problems that come as a result of trusting anything that's exterior to your control as a software developer. File system, network access, database, external databases, you name it. We talked about handling special cases first and then handling general cases last, like we did here. We talked about the mindset of the conscientious developer who seeks to advocate and protect the user from losing data and from feeling stupid and from making tough choices or feeling dumb. Using a catch-all strategy is really not ideal, and you should strive to examine each part of your application that relies on exterior resources and then wrap a try-catch block around those parts judiciously. All right, so that wraps up this lesson. We'll see you in the next one. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job, building Windows and web apps at the world's best companies as quickly as possible. So in this lesson, we're going to talk about collections, which are kind of like more full-featured arrays, full-powered arrays. I'll also talk about object and collection initializers, which allow you to initialize all of the properties for new instances of objects or collections of objects in just one line of code. Very cool. So previously we looked at arrays, and we said that an array is simply a sequence of data of individual elements of data that are stored in memory. And you can access any individual element in that sequence by using its index, which is its zero-based ordinal position inside of that array. We called it a bucket of buckets, and we can access any of the smaller buckets in the array by just saying, I want number number 3, which would be the 4th bucket in the array, right? So arrays are great, but we noted that they lacked a number of features. Like right out of the box, the length of arrays are fixed once you declare them. We saw that there was a helper method that would allow you to resize the array. But what if I didn't want to use an index, let's say, for example? Instead, I wanted to use some sort of key. And so by using, for example, a ISBN number, I could find the book that's associated, the book object associated with that number. I may not want to always do a lookup merely by the ordinal position in the collection, but rather use some other criteria. So, for example, what if I were working with customer data, I wanted to look up a specific customer by their last name or some other key that I've defined? Well, you can do that using collections with different types of collections. So to demonstrate some of the features and the limitations of collections, I created a setup project. It should be available from wherever you're currently streaming this video or wherever you originally downloaded this video from. You should be able to unzip it. Now, I've unzipped that file into my documents directory. If you take a look, for example, in lesson number 22 folder, where you should have unzipped this, the code for this lesson, there should be a before and after folder. In the before folder, there should be a project called Working with Collections. I'm going to merely copy that and put it into my Visual Studio 2013 projects directory. So I'll just right click here in the open space and click paste. And then to open this up, I'll drill into the solution folder and double click the SLN file, workingwithcollections.sln. That opens up Visual Studio with my project. And so let's take a quick tour of the project itself. You can see that there are several files here in the Solution Explorer. There is a car class and a book class, and then also the module 1.vb. The book class just merely has a couple of string properties, title, author, and ISBN. The car has just a make and a model, very simple in this case. And then in the module, I create instances of the car and the book, and I will be adding them to various types of collections to illustrate the differences between them. So here I'm creating an instance of car, an instance of car, an instance of book. All right. And so I want to start by demonstrating how the original .NET collections worked and why we now have a newer style of collections based on the concept of generics that I'll explain in just a moment. So you can see that, well, first of all, what I want to say is that there are many different types of collections available to you in the .NET Framework Class Library. So I'm going to start with a type of collection called an array list. So each collection features a unique set of functionality. Since I want us to just get our feet wet, I've chosen something fairly simple, and we'll start with the array list, which behaves a lot like the array, except for a few extra features that are added to it. Now, I don't want you to use these old style collections, so there's no real value in typing out what I'm about to type. I just wanted to show you this progression of thought. As I mentioned before, there's a new style of collections that we're going to use. I wanted to start with these original ones that were created in 2002 with the original .NET Framework Class Library and kind of walk you through the thought process of why they were problematic and what the new collections since 2005 give us and support that we were lacking originally. So don't feel like you have to type all this in. Just follow along for now. All right, so first of all, I'm going to work with the array list type, and I'm going to call this my array list as new system.collections.arraylist. All right, and then we will merely add items to our array list. So we called our car instances car1 and car2, and then the book b1. So let's add each of these to our array list. So car1. And then my array list, add car2, and then my array list dot add b1 for the first book. And now what I want to do is just do a for each my car as car in my array list, and we'll just simply console.writeLine my car.make. All right. Now, hopefully you see a little problem here that's brewing. I've added 2 cars, but I've also added a book. When we add objects into these old style collections, they're added in as type system.object. And you recall from previous discussions that system.object is kind of the class from which all other types all other classes in the .NET Framework class library and all other types that we create derive from. And so they get cast to object, and now we're casting them again back to cars here in our for each in order to retrieve some value from that object. But not all of the things that we've added to our array list are of type car. Here's something of type book. So when we run the application, we get an exception. This is an explosion of windows pop up. It says invalid cast exception, unable to cast object of type working with collections.book to type working with collections.car. Fundamentally, we're still working with a book here, and so when we try to cast it to a car, we get that exception pop up. So herein lies our first challenge, that our array list accepts type object, which seems great at first, but we're essentially working with loosely typed objects, not strongly typed objects, and therefore, because we can accept anything, getting it back out of system.object and into its original form is problematic. As you can see, we'll hit an exception. So there are some neat things about the old style collections. They did introduce us to the ability to do something like this. We can actually remove items from the list, and it should work correctly. In this case, I've added a book, and now I'm going to remove the book. And hopefully, by doing that, our application will run correctly. All right, and it does. Great. A collection size is not immutable like an array is. And there are some other great features too. If we were to just go my array list dot and take a look, we can add a range of items, we can search, we can clear out all the items, we can get a count, we can insert at a specific position, we can reference a single item in the array, we can remove at a specific position, sort the items in the collection, and even convert back to an array if we like. So there are some very neat features of the array list. However, it's problematic, as we noted, because it's not strongly typed. So let's go ahead and comment this out and move on to the next example. And this time what I'm going to use is a list dictionary. And so let me just start by typing, and then I'll explain what the difference is if you don't see it right off the bat. Okay, so hopefully you can see that the process of adding an item to the dictionary is different than adding something to the array list. We were able to pass in a key and the value itself that we want to store. So list dictionary is named after a family of collections called dictionaries because they have a key that we can use to reference a given item in the collection, and then the item itself, in this case, an object called car, an object called car, and an object called book. Okay, so what we can do then to find a given item is to just use its key. In this case, the make would be geo. We'd be able to find and convert that that object of type system.object back to a car, and then retrieve the model property and print it out. However, the same thing that plagued the array list is going to plague us here, where we're able to add more than one type to this list dictionary. And as a result, when we try to cast a given object to type car that's fundamentally a book, we're going to hit an exception. And we do. It's the same sort of exception that we saw before, that fundamentally we can't convert that type. So I said all of that to say this. What if we were to create a type of collection that was specific to either book or car, then we could only add instances of the correct type into that collection. And we could also treat all items in the collection as that given type. And we wouldn't have to cast objects upon retrieving them, and we wouldn't have to worry about if we were casting something that was incorrectly placed into the collection in the first place and hitting a runtime exception. So that's exactly what happened several years ago in Visual Basic 2005. Microsoft added a new set of generic collections. The concept of generics is a little bit advanced. In a nutshell, a generic type provides a basic implementation of some functionality, in our case, collections. However, you, the user of the generic collection, you make it specific by adding your own data type to it. So, for example, let me comment all of this. And let's create a new version of that first example. Now notice here, I'm going to give it of car. So we're creating a list of cars equal to new list of car. Now only cars can be added to my list. So we can do mylist.add car1, mylist.add car2, all's fine. Now let's try mylist.add b1, and whoops, we can see we get a blue squiggly line. The value of typed book cannot be converted to car. All right, so we're not even able to do that. So now whenever we do the next part for each my car as car, we can be confident that everything in this collection is a car. And so we can, with confidence, run our application. And we don't have to worry about there being a runtime exception. All right, so that's the benefit of using generics. It allows us to create strongly typed collections. All right, the same thing would be true of dictionary. So let's create that example as well. Now notice its definition in IntelliSense. We're creating a generic version of dictionary, and we have to give it two types. So the of keyword is followed by two types, t-key and t-value. T-key will be the type of the key, our lookup type. So we're going to make that of string, and the value will be of type car. So if we just read the IntelliSense and think what it's trying to do, we can generally figure out what to put after the of keyword. Okay, that's would be my encouragement to you. Now when we try to create or add our car, whoops, we'll add, and we look at the IntelliSense below. We want to add a key as string. So we'll go car1.make, and then car1, and then my dictionary add car2.make, car2. Now let's try to add, and I think you know where I'm going with this, and you probably already anticipate this not working. Author, and so at this point we don't get a blue squiggly line because the author is a string. As long as we satisfy that data type, then we're fine. But what happens when we try to give it the actual object? Well, now let's try to give it b1, the object itself, and you notice that's where the problem comes in. You can see value of type book cannot be converted to type car. So that is a benefit to us. Now we don't have to worry about another data type slipping into our collection. So in this case, we'll just do what we did before with console.writeLine, and then we don't even have to do the conversion of the type because it can only be one type. So we can do my dictionary geo, and you can see we don't have to use that ctype, that type conversion helper method in Visual Basic. Instead, we can just go directly to our model and run our application, and it should work fine. Great. Let's comment all that out. All right, so the next thing I want to do is move on to the final topic in this lesson. You might recall the initialization syntax for arrays. So we did something like this: dim names as string equals, we used the curly braces, and then I gave it the members of a popular band, like so. And now, all in one line of code, we've declared and initialized our new array. And this saved a few lines of code, first of all, and then secondly, we didn't have to tell it how many items were actually going to be inside of the array itself. So let's use a similar style to create a new car. So dim my car as new car with, and then I'm using the curly braces again, and I'm going to use the dot, and I can set make equal to go, and then comma dot model equals prism, like so. All right, and so here in one line of code, we're able to create a new instance, and then using the with keyword and the curly braces, we're able to set the individual properties of our new instance of my car to their initialized values. So that is an object initializer when you see this syntax, and it's used often out on the internet. So the syntax is easy. You just have to remember to use the with keyword and then the open and close curly braces with each of the property, name, and value pairs separated by commas. All right. So we can go one step further than that with collection initializers. So let's do this. So dim my list of cars as new list of car from, instead of using the with keyword, I use the from with collections. And now inside of the curly braces, I'm going to say I'm going to create a new car with, and I'm going to use curly braces again, just like we did before. So we'll set the make equal to Aston Martin, and the model equal to a DB9. We'll use a comma to separate each new instance of car Notice that I forgot the period there. All right, let's continue on. And then we'll end it up like so. So the syntax might look a little daunting at first, but you'll see it so often in code examples that I wanted you to be aware of it. I recommend that you simplify it and you understand that you can use the same object initializer syntax by initializing new objects with the initializer syntax within a context of collections like we've done here. All right, so while this looks like about 4 lines of code, it's actually just 1 line of code. Once you wrap your head around the object initializers like we saw here, then collection initializers are really easy. I just formatted this code by breaking it up into several lines, but again, it's technically just 1 statement. So after the declaration of our new list of car, then there's an opening and closing curly brace using the from keyword, opening and closing curly brace, and then creating new instances of car using the with keyword to set between curly braces as well, properties and their values. All right. Now notice that we don't give each of these instances of car a name that we can reference. There's no need for that. As long as we can create the reference, remember that this will now hold on to that reference, and as long as there's at least something holding on to the reference, it will retain in memory. But once we set my list of cars equal to nothing, there will not be any references to these objects in memory anymore because we don't have anything else holding references to them, and so they'll be removed by the garbage collector. All right. So that those same rules still apply, but as long as something's holding onto a reference, even if we don't have a name like car 3, car 4, car 5, like we created here at the very beginning with these, it'll still work as long as something is holding onto a reference of each of those new objects. All right? So you should familiarize yourself with the syntax, and you should use it right from the beginning so it becomes part of your personal style. So let's go ahead and recap what we talked about in this lesson. We started off by looking at collections as a robust alternative to arrays. But as we started using the basic collections that were available in system.collections, we saw that they weren't strongly typed enough, and therefore we discovered some downsides, some challenges. We were able to overcome them by using generic versions of those collections. A generic implementation of a collection that's made specific by supplying the data type that we wanted to work with for each of the parts of whether it be a dictionary or of a list, okay? So that's what a generic collection or method does. It allows you to define the specifics, and then it only accepts those types from that point on. So now we can work with collections in a strongly typed manner, and we saw how great of an improvement that was. There's no casting, no concerns about there being some type mismatch. It just works from that point on. And then finally we talked about the object initializer syntax, and we extended it to collection initializer syntax as a shorthand technique of creating instances of objects within a new instance of a generic collection. Looks a little complex, but really when you break it down into its component parts, it's actually really simple. Don't make it harder than it really is. Okay, so we're doing great. We're getting close to the end. Hang in there. We'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development jobs building Windows and web apps of the world's best companies as quickly as possible. So in this lesson, we're going to learn more about working with collections of objects. In the previous lesson, I demonstrated how to create a collection, an instance of a collection type, noted how to make it from a generic type into a specific by providing it the type of data we should be working with. We looked at simple procedures like adding items to and removing items from the collections, how to sort and do simple things like that. But beyond indexing into it and getting an item back out, or beyond just ordering and simple procedures like that, what else can you do with a collection? Well, suppose that you needed to filter that list of, say, 1,000 different objects in a collection to only work with a subset of them that met a certain criteria. So this is made possible through a new innovation that was added back in Visual Basic 2005 called Link to Objects. So in this lesson, what I want to do is explain the rationale behind Link, language integrated query, and provide a few examples to get you started with Link in your applications to filter large collections of data. So as you can see, I have opened up Microsoft SQL Server, which is a database server product from Microsoft. If you're familiar with relational databases and querying data in tables using SQL or the structured query language, you're undoubtedly familiar with selecting data from a database like I've done on screen here, where I'm actually selecting data from a database called AdventureWorks 2012. It's a sample database that's provided from Microsoft. And so this database contains literally dozens, if not hundreds, of tables, as you can see here, that you might find in a company. This is a fictitious company with lots of fictitious data, and it's great for practicing your SQL skills or to use as an example database whenever you're building applications, just to learn. Okay, and so here I've written a SQL statement that will choose products where the safety stock level is greater than 600 and the make flag is equal to 1. You can see that it brings back some, but not all of the rows of data. If I were to select, for example, all of the rows from the production.product table, it would bring back 504 rows, as you can see here at the bottom. But by adding a where clause, in fact, adding two where clauses and appending them together with the and keyword, I'm able to refine that to just a subset of that list, just 12 rows of data. And I might write this query to identify those products that would require me to start producing again in the near future. All right, this is just a fictitious example, but what I could also do is not only pull back all of the columns for a given table, and you can see it brings back quite a few columns, but what if I only needed a few columns for my specific purpose, like the product ID? I only need the product number to do a reorder, and then also the reorder point. from our table. I could furthermore restrict the data or filter out the data to just that those columns and rows that fit my purposes. Okay, so I'm merely using this as an illustration of what LINQ does, which is really the topic of this lesson. When you think about it, working with a set of rows in tables, like we just saw here a moment ago, is similar to working with a collection, or rather a sequence of objects that are stored in memory. They're similar concepts. So some smart people at Microsoft ask, well, why can't we use a syntax just like this that people are already familiar with, this SQL-like syntax, in order to query objects within our collections? And so that's exactly what they came up with in the form of LINQ. It allows developers to use a syntax that they're probably already familiar with, at least to some degree, in order to run queries against entire collections of objects instead of just, as we see here, rows in a given table. Okay, so now I'm back to the computer that I've been using throughout this entire series. And what I want to do is copy a starting point project that I created into my projects directory so we can get started. Now, I've unzipped the source code that's associated with this lesson into my documents directory. And you can find the source code wherever you are currently watching this video and streaming it from, or from wherever you originally downloaded this video. So there should be a folder called Lesson 23. Inside of that, a before and after folder. In the before folder, there should be an Understanding LINQ solution folder, and I'm going to copy that, and I'm going to put it inside of my Visual Studio 2013 projects directory. Just paste it in like this. And now I'm going to open up Visual Studio and then click the Open Project link on the Start page and navigate to my Understanding LINQ directory and select the Understanding LINQ.sln. And there are two code files in this project, CarVB and Module1VB. So CarVB has the definition for a class called car, and then also an enum. You can see that we have make, model, and year as strings and integers, sticker price is decimal, and then color is this enumeration that I created called car color. Car color can only be white, black, red, blue, or yellow. All right. And then in Module1VB, you can see that I've created a collection initializer syntax to create instances of the car class and have set each instance with an initialized set of its properties. And then after I've created a list of cars called my cars, I'm just going to iterate through each of the cars and printing them to screen. And so when I run the application, I simply get a list of all of the cars that are in the My Cars collection, which is a list of type car. All right. So let's do something very simple to start off with. I want to write a LINQ statement that'll retrieve all the BMWs from this list. So just glancing at this data, I can see that we have 3 BMWs. So the code to accomplish that is the following. And then I'm going to change this for each My Car in My Cars. I'm going to change it to BMWs. So now we're iterating through just this subset using this LINQ statement. So let's run the application now. We only get 3 results listed to our console window. So again, LINQ stands for the Language Integrated Query, integrating query operators into the Visual Basic Programming Language. So notice how the query that I wrote looks very similar to SQL. The largest difference here is the select statement, which is at the very bottom instead of the top, like we would have seen in our TransX SQL statement that we wrote at the very outset of this lesson. And at the very beginning, you see you set the result of the LINQ query to a collection of BMWs. And notice here that we're just using this implicit type declaration. We didn't define this BMWs as anything except whatever is returned from this LINQ query. We don't care. We're going to let the compiler figure out the actual data type. We'll talk about that more in just a moment. But here we're looking through each item in the BMWs collection and just printing it out the screen. The key here is the where clause, where we are looking for all cars where the make property is set to BMW. So hopefully it's evident what we're doing. We're selecting every car in the My Cars collection and adding it to the BMW's collection, which we then iterate through and print out to our console window. Great. What's more interesting is if we set our breakpoint in line number 17 and we start debugging. So we'll do that and we'll move a line or two in. And when I want to take a look at, for example, the type of the BMW's collection, as I scroll into it, notice that the type is just enumerable type. It doesn't seem like a very solid thing. It has these angle brackets next to it, and we can actually drill in and see each of the results. But in Visual Basic, it calls simply this enumerable type. So the real type is not easily ascertainable in Visual Basic. However, the type is known as an anonymous type because it has no name and no definition. The type is created dynamically at runtime as needed. So this gives you the flexibility to declaratively ask for whatever you need, and a type will be created for you via the implicit type declaration feature of Visual Basic, where we just dim BMWs and set it equal to something and let the compiler figure out what the actual type is. All right, so let's go ahead and deselect that and stop debugging the application. I want to continue looking at this from a pragmatic perspective. So instead of worrying about how it works internally, we're just going to go ahead and start learning some of the additional operators. For example, we can extend this statement that we just wrote. In fact, let me just copy this and I'm going to paste it again here and then comment out this one. And I'll add to this an and, where I'm going to set and my car, or rather and car dot year equals 2010 to further refine our select statement. And so this time we only retrieve one item into our BMW's collection. All right, so you can accomplish almost exactly what you can accomplish in Transact SQL, like we saw earlier, where we're able to add additional where clauses just by using the AND operator. Great. So as I demonstrated at the outset of this lesson, where we were looking at the Transact SQL syntax, I was able to not only filter out the number of rows, but I was also able to filter out the columns that were returned in the result. Well, you can do that in LINQ as well through a process called projection. So we're going to rely on Visual Basic's implicit type declaration to create an enumerable collection of projected types. Are they cars? Not exactly. We'll use three properties of car to create this new Frankenstein class, I guess you can say. What's the name of this new Frankenstein class that we've assembled together? Well, we don't know the name. It'll be determined by the compiler at compilation time, all right, dynamically. So we never have to worry about it. It'll just happen. So let me comment this out and show you what I mean. So here we go. We're going to create dim new cars equals from my car in my cars, where my car dot year is greater than 2009. I'm going to select or project out a new data type with the following properties, and we'll just use properties from our car to create this new Frankenstein, this new anonymous type. All right, so my car dot make, my car dot model, and my car dot year. Did you notice how I had to get rid of IntelliSense each time I hit the escape key on my keyboard because it wanted to auto type out my cars? For some reason it didn't recognize this my car identifier here. But now what we're doing, we're not working with cars anymore. We're working with something that kind of resembles a car. It has some of the same properties, but it's a whole new data type. And so we're going to work with a collection of those. What's their type? Well, we don't really care. Again, using our implicit type declaration style of syntax in Visual Basic, we're just going to have a collection of objects with these properties. That's all we know, and that's all we need to know, and that's just fine. So now we're going to iterate through this collection of new cars and print them to screen. There's just two, but they're both older than 2010, and that's all we really wanted to accomplish there. All right, so that's the process of projection. A lot more we could say about that, but we're going to move on from here. All right, so let me comment this out. We can also perform other types of tasks like sorting the same way that we would do it in SQL. Something like this. So dim ordered cars equals from my car in my cars, order by my car dot year, select my car. All right. And here we'll change this to ordered cars, like so, and then run our example. And you can see it goes from the oldest car to the newest car. All right, so 2008, 2009, 2010. Great. So in addition to this SQL style syntax, there's another way that we can harness the power of LINQ through a version of LINQ called the method syntax. It's actually, I prefer working with the method syntax over this style of SQL style syntax, this declarative syntax, because I'm already used to working with methods as a Visual Basic developer. So I'm going to create a version of all these queries, or some of them, using that method-based syntax. And some of this you'll find more familiar, more comfortable, and then some of it might be a little puzzling. So here I'm going to create that original query with BMWs. I'll name it something a little bit different. So dim underscore BMWs equals my cars, and I'll use the where method. And so I need to tell it what's the clause for the where. So I'm going to pass it a mini function. So I'll explain this in just a moment. Function car.year equals 2010. And then I'm going to chain that together with another where method. And I'm going to give it another little mini function here. And set the make equal to BMW. So I should be grabbing all BMWs that were created in 2010. All right, take a look at that syntax closely. And then we'll iterate through the list of BMWs. And you can see we just come back with 1. So this odd looking syntax right here that we pass into the where clause is known as a lambda expression. I don't want to explain much about lambda expressions. That's definitely a more advanced topic. However, think of it this way. It's a shortcut inline syntax that allows you to define a mini function. Okay, so here in line number 33, the where method allows us to pass this little mini function, a lambda expression, and we're telling it basically give us all the cars that match this condition, car.year equals 2010. So here's kind of the car, the method declaration. What's the name of that method? Well, we didn't give it a name. So that's one big difference. But we just want to, given a car, so for every car in the My Cars collection, return all those cars that match that condition, car.year equals 2010. And then the same thing is true here. This will return back a collection of cars, and using that collection of cars, we'll further whittle it down using this next where method, and we'll pass it a mini function. So given all cars that are returned back from this, then filter the list down even more where the car.make is BMW. And so the result of all that will be saved in this underscore BMW's collection, and we just simply iterate through it. There was only one item in there. Great. There's also a order by and order by descending method. So dim ordered cars equals my cars dot order by, and we'll give it a function car. So we want to order, given a car, each car in the My Cars collection, I want you to order them by car.year. All right, so that's what this little lambda expression, this mini method is doing, or mini function. And then we'll do ordered cars, like so. All right, so it gives us in order from the oldest to the youngest, 2008, 2009, 2010. And there's also an order by descending method that will do the opposite, 2010 to 2008. Great. Let's comment that out. And then also the LINQ query syntax gives us some extension methods. And these are kind of when you think of extension method, think methods that are bolted on the side of collections that weren't part of the original definition of a collection and all of its given properties, but have been added to that by LINQ. And so we can do something kind of neat like this. So dim sum, so I'm going to get a sum of all of the cars, and what are we going to use to determine the total value of all the cars on our car lot? Well, we'll type in another lambda expression, function car.sticker price. All right. And so here we can, let's comment this out, we can then print out the sum. So let's go ahead and console.writeLine total inventory value, and we'll do that, and then we'll format it like currency, and we'll pass in the sum like so. And so $250,000 worth of used cars on our car lot. So how do you know what to pass into one of these functions? Say, for example, you look at my cars and you find something that you want to use. Unfortunately, IntelliSense doesn't really help you out. I mean, you already have to know what a func is, F-U-N-C. Really where you're going to find the most benefit from this is by searching where in LINQ, something like this, and then looking at the correct MSDN article, like enumerable.where method, and kind of scurrying around for this. And you can see an example of it in use. And so here again, MSDN is extremely helpful when you're trying to learn how to use and how to really utilize the .NET framework, and especially in this case, LINQ and its extension methods and things of that nature, this method syntax. So I realized that some of the syntax might look foreign to you, and I hope I took the time to at least explain what it does so you can understand the basics and what we're trying to get to, even if you can't just off the top of your head now redo this whole lesson and you haven't just memorized it all. Hopefully this makes sense. You understand at least the thought process and what you can accomplish using LINQ queries within Visual Basic. Again, a new concept, but you'll see it often as you look at examples on MSDN and across the internet. So we're almost ready to wrap up. I believe we have one more lesson and then we'll be done. So you're almost there. Hang in there. We'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job, building Windows and web apps at the world's best companies as quickly as possible. So up to now, we've been focusing on several things related to Visual Basic, the syntax itself. We've looked at Visual Studio and its various windows that help us write code. We talked about the .NET Framework class library. We've talked about the .NET runtime. We've talked about compiling, running on users' computers. And so I'm sure at this point, you're itchy and you're ready to build real applications. You know, applications that have more attractive user interfaces. You don't want to just write console applications for your entire programming career, right? You want to build web-based applications or Windows-based applications. So in the second to last instructional video in this series, I'm going to discuss event-driven programming. And event-driven programming is really at the heart of all of Microsoft's presentation APIs. In other words, it's at the heart of those little neighborhoods of classes that are dedicated to building web pages or Windows forms or working with data and so on. All right. So an API is application programming interface, and in the context of .NET, the entire framework is an API, an interface that we can program against. But then there are these, again, little neighborhoods or subsections of the entire framework class library that are dedicated to a specific purpose, whether it be building Windows, web, apps, working with databases, and so on. Okay. So at any rate, event-driven programming is at the heart of all of these. And the essential idea here is that it allows you to plug in and handle key events in either the life cycle of the application's execution or handle key events that are raised whenever an end user interacts with the program in a certain way, whether it be clicking a button, hovering over a given area of of the web page or the web form or the Windows form or what have you. Okay, so it all starts with a fundamental understanding of how events work. So up to this point in our simple console window applications, we've really only been handling one key event. So when our application starts up, we've been handling the main method, and we've said that the main method is special in console window applications because it's the first method that fires off whenever the application is executed. So in a sense, it's responding to the application started event, even though it's not quite phrased that way. However, in a modern user interface, whether it be, again, a native Windows application or a web-based application, users can interact with the various elements that they see on screen. They can hover their mouse cursor over elements. They can press keys on the keyboard. They can type text into fields. They can drag and drop various elements that they see on the screen. They can click on things, and so on. And so as a software developer, you can write code that responds to these interactions. You can decide which ones you're going to respond to and which ones you're going to ignore. So when these interactions happen, the .NET Runtime raises events, and you can decide whether you want to respond to that event or if you want to ignore that event. And then you get to decide what should happen whenever the user clicks this button, hovers their mouse cursor over, or whatever the case might be. So speaking specifically about the user interface, every single control, whether it be a text box control or a button control or a drop-down list or a grid or whatever the case might be, they have different events that you can write to handle, and we'll show how that works in just a moment. So how does this manifest itself in the applications that you'll actually write? Well, in this lesson I'm going to demonstrate how you're going to get the same experience of working with events whether you write a Windows application or a web application. So using the techniques that we've learned before, we're going to create a new project. So to begin with, I want you to select the WPF application project template type. And you can see above it, there's this Windows Form application. It's actually an older API. It came out with the original .NET framework in 2002. And then in 2005, they introduced a new style of presentation framework for building Windows applications called WPF, Windows Presentation Foundation. And it's a little more flexible. I assure you that anything you learn in WPF can probably be transferred over into the older style Windows Forms application API. All right, so it has a little bit more momentum because it's newer and more people are using it, and it offers some improvements over the older API. So after choosing that, we're going to call this project WPF Events and click OK. All right, the first thing I want to do is display the toolbox. I'm going to pin it down. And I'm going to open up the common WPF controls here. And what I'll do is I'm going to drag and drop a button from the toolbox onto the designer surface in the upper left-hand corner. And you can move it around and resize it if you wish. That's fine. It won't really matter. And then I'm going to drag and drop a label and put it below the button. The first thing I'm going to do is select the button and go to the Properties window. Let me pin that down while I'm at it here and pin down the Solution Explorer too. All right, so it should be configured like what you see on screen here. I'm going to select the button, and then I'm going to give the button a name. I'm going to call this My Button. And I'm going to select the label, and I'm going to call this My Label. And then I'm also going to clear out the content for the label, so it shouldn't display anything whenever the application first loads. All right, so now you should see a second tab available in Visual Studio called mainwindow.xaml.vb. If you don't see this, then what you can do is go to your Solution Explorer and drill down. Beneath the mainwindow.xaml, there should be a file called mainwindow.xaml.vb, and you can just double click that to open it up in the main area. And the first thing you might notice is that this is called class main window. And if you look at the mainwindow.xaml and you look at the very top of its definition, you'll see that the class name for this is main window as well. So these are really two parts of the whole, and they define the two aspects of working with forms. There's the presentation, which is defined by all this HTML-like syntax called XAML, XAML. All right, and then there is the code that we'll write in Visual Basic that will handle, or that we will write logic with to actually do something meaningful whenever users interact with the various elements on our form. Okay, so that's all that I really want to say about that. This really deserves a discussion of XAML and WPF, and working and building Windows applications that we're not going to talk about in the remainder of this lesson. But it's important to see that this is a class, and so what we want to do is whenever a new instance of this class is created, so whenever your application is launched, what we want to do is in the constructor we're going to wire up that button control so that when you click it, something happens. So we're going to wire it up to a method called an event handler. And to do this, we're going to need to create a constructor. Now there's a couple of ways to do this, but the easiest way that I found is to select the object that you want to work with from this leftmost drop down, which in this case we're just working with the main window class. And then over here in the right hand side we can select which methods that we want to work with. In this case we're just going to create a new constructor, and whenever I select that, let me remove these, you can see that it creates some templated code for a constructor for this main window class. And so here what we can do is write some code like so in order to add a handler to the click event of the button on our form, and we'll do this. So we'll add a handler, myButton.click, and we will give it what's called a delegate. So address of me.myButton_click, a method, or in other words, an event handler we have not created yet. And when I hit the enter key on my keyboard, notice that we get the blue squiggly line. The problem is that we haven't yet defined this method in our class. So it says that myButton.click is not a member of WPF events main window. All right. So to resolve this, what I can do is hover my mouse cursor over the little red dash. It opens up to the red X icon contextual menu, and one of the options there is to generate a method stub for myButton_click in the WPF events main window. When I click that, here it creates a private sub myButton_click with some input parameters that will be sent in from the .NET Framework runtime. You can see that by default, this little template that was generated for us will throw a new exception. And this is just used as a placeholder, a reminder that we've not yet implemented this method yet. So I'm going to comment that out now that I'm ready to write some code. And the code I'm going to write is going to be pretty simple. Whenever somebody clicks on the button, we're going to set the labels content property equal to hello world. All right. So what attaches this event to the operation of clicking? It's this line of code that we wrote in the constructor. This gets fired off whenever a new instance of our window is created. So it automatically wires up the click event of the button to the address of this method. And so that whenever a user decides to click on the button, this method is fired off and our code block inside will be executed. So as you might expect, whenever we run the application, you can see we will click the button and our message will get printed to screen. We'll close the application. So what was the purpose of this exercise? Well, it wasn't to teach you about how to build WPF applications, although you might have learned a little bit if you've never done that before. It was really to explain the nature of handling events. Events are raised by the .NET Framework runtime, by end users, and more. So in WPF, each window, each control, and even those objects that don't have a visual component, like those objects that control navigation between windows, those objects that handle communication with the network or the file storage and so on, they all expose some events. So as a developer, you can choose which events to respond to by writing code in a special method called an event handler. What makes it an event handler? Because we've wired it up to a certain event that's raised by the .NET Framework. So what's so special about an event handler method? Well, typically their method signature is defined by the object itself, in this case by a button. So in the case of a button control, the click event requires an event handler to be defined that accepts two input parameters. The sender of type system.object that represents the caller that fired the event. And then second, a routed event args object called E that contains extra information about the call, who called it, how, and so on. So many times you can ignore these input parameters, but occasionally they will allow you to access important details that are sent by the caller of the event. So the key idea is that we've attached a new event handler to the click event of the button. We use the add handler statement to pair an event and an event handler together. And so, as I said earlier, this is actually, we're passing the address of the event handler itself. This is also known as a delegate. In other words, we're delegating a particular method to handle this specific event. So Visual Studio helped me write that code by automating some of it with helpful IntelliSense prompts and code snippets. I use the term attach an event. Some people call this registering an event. We can actually attach multiple event handlers to a single event and even programmatically remove event handlers by using the remove handler statement. So if I decided at some point I didn't want the MyButton_click event handler to handle the button click any longer, I could write other code to say remove handler from MyButton.click, remove it with this delegate. So remove the address of me.mybutton_click. Okay. So there are also declarative ways to attach an event to an event handler. We've purely been working here in the designer pane by dragging and dropping controls from the toolbox onto the designer surface. But when we did that, you'll notice that we were actually generating this XAML code that we talked about a little bit earlier. And this XAML code is really just it's just an XML-like syntax that allows you to create instances of objects that have some visual component to them. So in this particular case, we created an instance of a button class and an instance of a label class. Okay, and so by doing this, let me kind of separate these properties. So not only can you create new instances, for example, of a button class, but you can also initialize their properties like we've done here in the remainder of this XAML element. But you can also use this to wire up events. So I can do use the click property, I guess you could say, and you can see here that I can generate a new event handler, or I can go ahead and attach this to MyButton_click. If I select new event handler, it will automatically generate a new name, MyButton_click_1, and I can even write different code inside of here. So let's just, for fun, copy this line of code, we'll put it here, and hello world again, and we can comment out this line of code and then run the application. You can see that we're able to now use this other implementation that we wired up purely from our declarative code, this XAML code that we've created. Okay. So before I end this project and move on to the next one, I want to expand on what I said at the outset of this lesson. Every single control has actually quite a few events that you can choose to handle or ignore depending on what you want your application to do. So to see a comprehensive list of all of the events that are available for a given control, what you can do is actually select the control and then go to the properties window. You can see next to the little wrench icon, there's a little electric bolt icon. And when I click that, this is a listing of all of the events that are available to the button control. And some of these events deal with the layout and the positioning at the time that the window is first loaded and displayed to the end user, and it allows you to preempt that process and perform additional layout and positioning logic. Some of these events that are listed here, they deal with keyboard access or interaction. Some deal with stylus interaction whenever the user is accessing the app from a tablet. Some of these events deal with normal mouse operations like clicks and hovers or drag and drop. Some of these events work together, addressing smaller parts of a bigger operation such as drag and drop and a lot more. But you can see that there's dozens of events just for this single button that we can handle. And the same is true with the label control. If I can select it here, let me see if I can get my mouse cursor on it. There we go. So now we're looking at the events that are fired off by the label control, and it has many events as well. All right. So the challenge won't be getting access to a given control or element's events. It'll be determining the nuanced difference between the various events that are available and picking the right events that you want to handle as the application developer. Also, each event will be raised in a different order. Sometimes the logic that you write is expecting a certain order of these events to be fired off, and so oftentimes developers introduce subtle bugs into their application by not understanding the order of execution. So that's where a lot of testing comes in, setting a lot of breakpoints and then attempting different operations, whether it be with the mouse, keyboard, the stylus, whatever the case might be. All right. So there's actually events for the window itself. Like if I were to put my mouse cursor here, and you can see we're now looking at the events for the window itself. You know, we wrote code in the constructor of the main window class, but there are other events that happen as the window is loaded, as it's unloaded, as it's moved around, as it's resized. And there are events that are concerning the lifetime of the entire app itself. The app has started, the app is closing, and so on. So in the case of a WPF application, those events are handled in this application.xaml.vb file, okay? And I want to emphasize that these are just events for the user interface. There are other events that can be handled for data access, for file access, for network access, and a lot more. But the main point, the main takeaway is that there are events everywhere you look. And if you can dream up an action that you want your application to perform, your first thought should be, what event should the application be responding to? And then research in MSDN using your favorite search engine to locate the right event for that job, find the event, and write code to handle that given event in order to carry out the action that you want to, okay? So to reinforce this idea, I'm going to practically duplicate this example, and I'm going to do that by building an ASP.NET Web Forms application. So my goal is to show you that, first of all, understanding the nature of events is important whenever you're building applications in .NET. And secondly, much of the knowledge that you gain from understanding one API can be applied to other APIs as well. So in this particular case, we're going to transfer our knowledge of building a Windows desktop application with WPF to a Web Forms application that will execute on a web server and consumed in a web browser. So off camera, I installed Visual Studio 2013 Express for Web, and you see I have it opened here. You can download this and install it from the same place wherever you downloaded Express 2013 for Windows Desktop. So I just went to the download page and went through the same operations before. I'm not going to demonstrate that in this lesson. If you want to follow along, by all means, go ahead and install Express 2013 for Web. If you already have Professional or Greater or Visual Studio, you can follow along by just choosing the right template as you create a new project. So we're going to go ahead and start by creating a new project. We're going to select ASP.NET Web Application. So Visual Basic ASP.NET Web Application, we'll call this ASP.NET Events, and click the OK button. And here on the new ASP.NET project dialog, I want to just select the empty template and then click the OK button. We're going to ignore all the other options here. All right. And once we have the project loaded up into the main area, I'm going to right click the project and select add a new web form. So choose web form here, and we're going to name this web form default and click OK. And you can see in the Solution Explorer, it'll create a default.aspx page. It will load that page into the main area here, and I'm going to switch from the source view to actually the design view. We're going to ignore the combination of HTML and the ASP.NET declarative syntax. We're just going to work purely with the designer, and we're going to repeat the steps that we took earlier. Let's go to the toolbox. I'm going to pin that down, and I'm going to drag and drop a button control into this little blue div area here at the very top. So I'll drag and drop it inside of there, and I'll put my mouse cursor next to it and create a space on my keyboard, and then I'll go to the label control and drag and drop that and put it right next to it. So since I have the label control selected, I'm going to go to the properties window here, and I'm going to call this, I'm going to give this the name, the ID rather, of my label, and I'm going to clear out its text property, which is the equivalent of the content property in the WPF version of the label. And then I'm going to select a button, and I'm going to name that my button. All right, like so. Save that. The next thing that I want to do is just go into this blank area, and I'm going to double click. All right, so I'm going to do this, add handler, and I'm going to work with my button dot click, comma, and I'm going to give it a delegate, the address of me, and I'll give it a name, my button underscore click. All right, and when I hit enter on my keyboard, notice that we get the blue squiggly line. I'm going to hover my mouse cursor over the little red dash, which brings up the red X icon contextual menu. I get the same message that I saw on the WPF side of things, generate method stub for MyButton_click in ASP.NET, ASP.NET events._default. Here we get the same or a very similar event handler stubbed out method. I'm going to comment out the throw new not implemented exception. Here I'm going to write my label.text equals hello world, and I'll save everything, and I'm going to click the run. Notice that instead of it saying debug, it says Internet Explorer next to the little run icon. So when we run this application, our application will be deployed to a special web server that's able to run locally for testing and development purposes, and it will also load up Internet Explorer and then tell Internet Explorer to request that web application that's been loaded up into the Internet Information Services Express, that little mini web server that runs on my local computer. So we'll go ahead and click the run button. Internet Explorer pops up. You can see in the Windows taskbar over here that IIS Express popped up as well. If I click on it, you can kind of see that it has a site deployed to it called ASP.NET Events. Great, and it gives us the address. You can see the address matches whatever we're looking at. And we can also stop the site and do some other things, but I don't want to do that. I want to actually click this button in the upper left-hand corner, and we get the word hello world pop up into our web app. All right, awesome. So just like we saw in the WPF example, we can also wire up the event handler declaratively by going into the source code for our default.aspx page. And I can, for example, do onClick equals, and then I can create a new event just like we did before, or select one of the existing events. So I'm going to go ahead and let it create a new MyButton_click1. I'm going to comment out this line of code where we added the handler imperatively through the Visual Basic Code, and I'm going to do my label.text equals hello world again. In this case, I'm going to rerun the application. It redeploys my application with all the changes I just made to IIS Express. It opens it up in Internet Explorer. I click the button and I see the new message, hello world again. So we can wire up events either declaratively in our ASPX, or we can wire them up in our aspx.vb file, the code behind for our default web page. Okay. And then finally, if I were to go back out here to design and actually select a button, and then I can, in my properties window, I can see that it also has this events button next to it. When I choose that, I can see all of the events for this button, and these are just the server side events, not the client side events. If you want to handle client side events, you'll have to handle them using JavaScript, and that's a whole other series of videos. Let's recap what we talked about in this lesson. Whether you're interested in building a web form or a Windows form application, at this point it just becomes a matter of learning the different controls that are available for each, and then learning the different events that are raised by those controls. What's the behavior of those controls that I as a programmer can write to handle? So in my experience, about 75% of events are common across those controls. You can click on it, you can drag something over it, you can, type into it, things of that nature. In most cases, you can anticipate the events that will be available to you without having to memorize a list or anything like that. So here's what I recommend. Whenever you need a particular control in your application, simply peruse the names of the events, like we did here, where we scan through the various events for a given control. And if you find one you're not sure what it really does, you can, in some cases, like here, you can click on it and you can see a mini explanation at the very bottom of the events pane for the properties window. So this command event fires whenever a button is clicked and an associated command is defined. What does that mean? Well, we might need to go to MSDN to learn a little bit more about commands. Okay. Sometimes that little message can be a little cryptic. So that usually means that I need to get more information, a comprehensive understanding of a particular concept as a whole, whether it be about data binding or the life cycle of a form or a web page or the purpose of a given control or some big picture idea. And once I have that in place and I have a mental map of how a given idea works, then the individual events will make a lot more sense to me. All right, so I rely on MSDN. I search in MSDN a lot during this process. There's probably not a day that goes on that I don't spend at least a half hour, an hour in MSDN learning more, researching more to find out what I need to do to make my idea a reality by utilizing the events or understanding just the big picture of how all the pieces kind of fit together to accomplish a larger task. Okay. So also fundamental to learning any API is learning the life cycle of events that occur during the execution of the application. Not just the individual controls, but the application itself and all the steps that it has to go through from initialization to the point where it actually displays a window to the end user. So for example, this URL here, it discusses the ASP.NET application lifecycle for Internet Information Services 7.0. And this URL discusses the ASP.NET page lifecycle. So understanding not just the entire application, but then individual pages, what their life cycle is as well. Again, at a much higher level than just individual controls. And understanding this is really the key to understanding how to build powerful web applications using ASP.NET. So admittedly, these are very meaty topics, but they're the key to understanding what's going on under the hood to deliver a dynamic page via ASP.NET. Similarly, there are good jumping off points for learning about the lifetime of WPF applications. So I found that this URL and this article, Application Management Overview, if you were to scroll down, it talks about not just some topics that may not be so interesting, but about midway or about a quarter of the way through, talks about the application lifetime for WPF applications. So at some point, becoming either a web developer or a Windows desktop developer means getting a grasp of these topics. And it all starts with understanding events like we discussed in this lesson. So hopefully it was beneficial. Hopefully you can see how you're able to leverage the knowledge of one API and how we're able to take essentially the same actions in these two different APIs, even in these two different applications, and yet come to very similar types of features. It's all due to the fact that Microsoft has designed them this way to make it easier on us to learn and leverage and utilize in our own applications. All right, so definitely want to move on from here in the direction you want to go and learn more now about the specific presentation API that you plan on using, whether you want to become a Windows developer or a web app developer. And then you'll also want to add to that some knowledge of a data access technology or API like ADO.NET or a sub API called the Entity Framework, which is probably the most popular option that you can choose today. Okay, so just one more lesson left. If you made it this far, you're doing great. Hang in there. It's a short lesson and you'll learn a lot. So we'll see you in that lesson. Thank you. Hi, I'm Bob Tabor with www.learnvisualstudio.net, where I teach beginners the skills they need to get their first software development job building Windows and web apps at the world's best companies as quickly as possible. So in previous lessons, we looked at parts of the .NET Framework class library to perform a number of different operations like file and directory access, string and date manipulation, working with collections, and a lot more. So years ago, in an attempt to make the Visual Basic programming experience even more accessible to absolute beginners, Microsoft decided to provide shortcuts, I guess you could say, to some of the very popular .NET Framework class libraries that were needed to do important stuff. So admittedly, the Framework class library is so huge that it can be difficult to find exactly what you're looking for without spending a lot of time just perusing through namespaces, just so you can get a little clue or a little hint as to which classes you're going to need in order to do something fairly basic, like look at information about the user's computer or read and write from the file system or just get a list of directories and things of that nature. So in order to unlock the most powerful functionality related to common tasks, like the ones that we just noted, files, directories, managing settings for a given application, getting information about the user's computer and so on, the My namespace was born. Again, the My namespace is unique to Visual Basic. it provides a shortcut to commonly used classes in the .NET Framework class library. So in this lesson, I want to show how the My Namespace makes it easier to find some common classes, things that you'll probably want to do inside your applications. And I'm only going to demonstrate how to use a few of the classes in the My Namespace. As we type in the code, you're going to see IntelliSense pop up, and you're going to see the various classes and methods that are available that we don't demonstrate. Just take note of them, make mental note, and you can possibly utilize this whenever you go to build your own applications and you wonder, well, how can I get to working with the file system? How can I get to working with the user's computer? Think My Namespace, start there, and then start navigating through IntelliSense to find what you're looking for. All right, so let's create a new project called, well, let's just call it My Namespace. Let's come back to console application, call this My Namespace, click OK. And so probably the quickest and easiest way to get started and explore what's possible is just type my and period, and then you can look at the various high-level classes. In fact, let's go ahead and use the all here so we can see everything. We can look at web services, which will allow us to exchange data over the network using an XML syntax. User, so we can look at things particular to the user of this program. Working with settings, which we'll do in just a little bit. Working with things about the application. I think we're going to use that one as well. The computer itself and so on. All right. Well, first of all, notice that the My Namespace came for free. All I had to do is just type my, and I'm ready to go. We don't have to include it at the top of our file using an import statement. We don't have to do anything special. It's just part of the project template whenever we create a new Visual Basic project. And secondly, as you can see that there are a lot of classes and other namespaces at this level. That's neat. So we're going to start with the computer class, and I'm going to attempt to access the name of the computer and its available memory. So we'll do something like this. So we'll get the name, for example, of the computer. So console.writeLine, and we'll just pass in my computer.name and console.writeLine. And we'll go my.computer. And here, look inside of the computer. We can get to the audio, the clipboard, the clock, the file system, info about the computer, the keyboard, the mouse. We've already looked at the name. We can get to the network, any ports, the registry, work with the screen, and so on. And so in this case, we want to go to info about the computer. And now we can get to available physical memory, available virtual memory, the name, the version of the OS, and so on. So let's go available physical memory, and then toString on that. Great. And then we'll do a console.readLine, like so. Get rid of that properties window, and then we'll hit start. And so here's the name of the computer, and as you can see, I didn't really take time to name this computer. It's one of the defaults that they generate for you. And then this are the number of bytes that are available on my computer right now. So pretty interesting. And so the next thing I want to do is work with the file system. And in order to set up this project, I've created some example files that you should download from wherever you're currently streaming this video or wherever you originally downloaded it from. And I've unzipped that into my documents directory. You can see here I've unzipped lesson 25 into my documents directory. And there's this little folder called test. I'm going to right click it and copy it and paste it to my C drive, so it'll be right in the root. And if you open up this test folder, there are 3 test files, test1, test2, test3.txt, and each of them have just a simple quote. Now is the time for all good men to come to the aid of their country. It's better to be lucky than good. And then finally, best is the enemy of good, a quote from Voltaire. And so each of those have one thing in common. Did you catch it? Yeah, they each have the word good in them. So what we can do is, first of all, I'm going to write an application that allows us to look through a folder and find any matches for a specific string. In this case, I'm going to look up the word good and have it return back a list or a collection of all of the files that have that word good in them. All right, so I'm going to go dim files equals my.computer.filesystem, and now look at all the things that we can do in this file system class. We can copy files and directories. We can delete files and directories. We can determine if a given directory exists or drives. Look at all the drives on the system. We can determine if a file exists. We can find in files, which is what we're going to do here in just a moment. And if we just scroll down, I mean, there's so many different things we can do. Renaming, opening files, and reading their contents out, and so on. We're going to focus on this find in files method. And there's two overloads. The first thing I'm going to do, though, is I'm going to give it a directory to look in. So in this case, I'm going to look in this directory, C:/test. I'm going to give it a string to look for, so good. We're going to look for the word good. Then the next thing we want to do is determine whether we should ignore the case or to actually honor the case of our search word good. I'm going to say true. I want to ignore the case, whether it's capitalized or all in lowercase. Either way it works. And then we get this option to for our search options. Should we search in the top level directory only or search in all subdirectories of C:/test? For this purpose, I know that we only have one folder and no subdirectories, so I'm just going to search the top level only. All right. And so now to make this a little bit more readable, I'm going to separate these onto to new lines, but you can see through the indentation it's all kind of related back to this one top line where I'm creating this collection of files. So now I'm going to go for each file in files, console.writeLine, and then just the file. All right. So this will return back to us a read-only collection of strings. So that's why we're able to just pass in this, because this should represent a string called the file name. So let's run this application. And you can see it brings back all three of the files. Let's use the word time instead. I think that should only appear in one. Yes, just the first file. Okay, pretty neat. Let's go ahead and comment all that out. And the next thing we want to do is use that same My Computer file system. And this time what I want to do is copy all of the files from this test folder into a test2 folder. So just copy or create a new folder and copy all the contents of this folder into a new folder. So let's do this. my.computer.filesystem.copy directory, and we'll give it the original directory, and then we'll give it the new directory we want to copy the contents into. And then the last option is whether we should allow it to overwrite existing files and directories, and I'll say go ahead and say true to that as well. So now when we run it, nothing will really happen on screen unless something is wrong. But now whenever we look back in our Windows Explorer, we can see that there is a new subfolder called test2 that has all three of the files in there. Awesome. All right, so this My Computer file system, very powerful, lots of cool things we can do with that, but let's continue on. So the My namespace makes many features of .NET applications readily available. For example, we can accept and work with command line arguments to our applications. So a command line argument is a comma-separated list of values that are passed into the application. They're usually typed after the name of the application. So hello world.exe space, my first argument, comma, my second argument, comma, my third argument, comma, and then we can use those, that extra data that's passed into the application in our app. So we'll do the following. We're going to write this code to work with my application.command line arguments. Okay, so we're getting here a collection containing the command line arguments as strings for the current application. All right, great. Then we'll just for each through them. For each argument in arguments console.writeLine argument. All right, so when this runs, let's see, okay, nothing will happen this first time because we don't have any arguments that we passed into the application. And how can we pass in arguments to our application? I mean, we're not actually typing in on the console window my namespace.exe to execute the application, so we can't easily pass arguments in. However, fortunately in Visual Studio, they give you a way to test this functionality. And again, you'll go into the My Project icon entry here in the Solution Explorer, which will open up the property pages. And if we go to the Debug tab, you can see there's this area to add command line arguments. And here I'm going to add Mo, Larry, Curly, and Shemp, comma separated list of arguments. And so what would you expect our application to do now? Whenever we run the application, it'll see that command line argument passed in. It'll get those arguments, turn them into an array of strings, and now we're looping through that array of strings or that collection of strings and printing them to screen like you see here. Great. Now let's take this a step further. I'm going to remove those and save everything and then rebuild the application. So now I'm going to go to search and I'm going to type in CMD to find the command prompt in Windows 8.1 and open that up. It looks like I'm already in the user folder, so I know that I can get into projects. So CD documents, CD Visual Studio 2013, CD projects, CD my namespace, right? So that's the solution folder. I should be able to go CD my namespace one more time, get into the project folder. I should be able to go CD bin to get in the bin folder. I should be able to go CD debug to get into the debug folder. And now I should be able to go my namespace and then type in the following arguments here. Maybe members of a band that I'm familiar with, like Pete, Patrick, Joe, and Andy. And now when I do that, notice that I was able to pass in the command line arguments to my application. It retrieved the command line arguments, it put them into an array of strings, we iterated through that collection or that array of strings and printed them back, echoed them back out to screen, and now we're out of the application. All right, and I can do a directory to see all the files inside of that directory and so on. And I'll just get out of that. Great. You learned two things there, not only how to work with command line arguments using the my namespace, but then also how to work with these with the debug tab of the properties for our project. So in addition to working with command line arguments, we can also work with application settings. So in the applications property pages, since we're already here, we'll want to go down to the settings tab. And you see this little grid, and you can see from this text, application settings allow you to store and retrieve property settings and other information for your application dynamically. So for example, the application can save the user's color preferences, then retrieve them the next time it runs. And you can go beyond this and save any kind of data. So what I'm going to do is, just for fun, I'm going to change, or I'm going to add two settings. So I'm going to call this the first value, and then I'm going to give it the value lister, and then second value, and I'll give the name Rimmer. All right, and I'll save these. And now I'm going to go back to module 1. Let's comment all this out, and I want to retrieve those values and then even change them. So we'll do before and after. So console write line before, as we're retrieving these values, console.write line. And how do we retrieve them? We use the my namespace, my settings dot. Now notice that we created the words first value and second value inside of the settings pane of the properties. And yet we're able to access them in a strongly typed way by just hitting the dot on the keyboard and then, typing them out. So that's very, very neat, very convenient for working with settings. And I work with settings in just about every application to save connection strings to the database. You can use them for lots of purposes. Again, not your actual application data, but something that's generated or used by the application, but usually things that set up the environment. They give you control of, for example, like the colors that the user chose, or their preferences, right? So second value, and then I'm going to actually, that we got those values, let's set them now by setting how we would set any property. So we'll set the first value to Crichton and the second value equal to Kuchansky. And then I'm going to call my settings.save. And then I want to display a blank line. So let me just copy this, paste it a couple times here. and we'll call this the after. And here, let's go my settings dot first value and my settings dot second value. All right, so now watch what happens when we run our application. We've retrieved those values, Lister and Rimmer, from the first value and second value that we preset in our property pages, and then I change them, save them, and retrieve them again for the after. Now the real test here is to run the application a second time. So the user closes down their application, they run it again. Will those settings that were changed persist? And they do. You can see now in the before we have Crichton and Kochanski, the settings that were changed the very last time that we made those changes and saved them. So as I promised, this is just a small smattering, a small example of everything that's possible with the My Namespace, as well as a couple of extra features of the properties pane that we've been looking at here throughout our entire series. Just shortcuts to get deep inside of the .NET Framework class library so that you don't have to memorize all the long namespaces and search around for those things about the computer, the network, the user, and so forth. They're just right there for you in the My Namespace. So if you're just getting started and you need a quick way to get to the classes required in the .NET Framework class library to perform common tasks, then you can try to use the My Namespace, see if it has what you need to get you pointed in the right direction very quickly. Okay, so we're done. Got a couple of closing comments in the next lesson, and then we're finished here. Thank you. Okay, so let me congratulate you on a job well done. You made it all the way through this course. That was a serious commitment of time and effort that you put in, and you made it to the end. You know, a lot of people, whenever I look at the usage statistics or the views for a given series, I'll see the first couple of videos, there'll be a lot of views, and then it begins to trail off from there. Maybe it's me, hope not. But what I think is going on here is that people commit to learning something, whether it be a language or a technique or an idea, and then other things get in the way and drown out that initial enthusiasm. But that's not you. You made it all the way through this series, and so I congratulate you. You have my respect. You're the kind of person that will push through to the very end, and I encourage you to continue on in your understanding of Visual Basic and the .NET Framework class library and learn everything you can in the coming days, because the more information that you have at your disposal, the better decisions that you'll make from this point on. But I suspect that you're going to do just well, just fine. So in this lesson, I simply want to wrap up the series and provide a few suggestions about where to look for answers for your questions and how to address issues that will inevitably pop up as you work at learning more about .NET and as you start building your own applications. We'll also talk about the right way and the wrong way to ask for help on the internet, and a few suggestions on the key topics that you should be focusing on in your self-directed training. First of all, let me say that some of these ideas, especially the more advanced concepts that I discussed at the end of the series, they might take weeks or months of really thinking about to digest completely. I mean, honestly, there's things that I learned 10 years ago that I'm still trying to wrap my head around. It's important to keep pushing forward, keep learning, daily baby steps. Commit yourself to that. Many times I need to read what many different blogs and books and even watch videos and see what each different person has to say about a given topic before it begins to resonate with me and I really understand the concept and the power behind whatever the idea is that's being expressed. Each person who talks or writes about a given topic can say things in a slightly different way, which helps cement or clarify these ideas in my own mind. So life has many teachers. Find many different sources of information, consume them, think about them in the shower, as you're driving to work, as you're mowing the grass, whatever the case might be, and really wrap your head around these ideas, and that helps them to be cemented in your mind. You don't need to know everything right up front, and I think that's one of the mistakes that a lot of developers make. Before they get started, I need to know everything before I can write applications. You don't really need to understand everything there is to know about object-oriented programming. You don't need to know every class in the .NET Framework class library. It's impossible. A lot of things will become a lot more obvious after you've made some mistakes. I see now the value of blah, whatever that is. Now it makes sense to me because I'm having this problem, and that would have solved my problem that Bob talked about those many years ago. Okay? So I hope you kept in mind that the intent of this series was to supply the information as a means of explaining the code examples that you might see in other articles or books or even seen videos, or provide some insights that'll help you to better understand how the .NET Framework class library is structured and how it operates. Okay, so where do you go from here? Well, let me address that in two ways. Where do you go whenever you have a problem? Well, chances are at some point while you're learning or while you're building applications, you're going to run into an error message that you simply can't make sense of. It happens to everybody. Don't fret. In fact, I think a big part of what makes programming a valuable skill is the experience that you've gained from working through all the various problems and issues that you will inevitably run into. So the good news is that there's a large community of other developers inside and outside of Microsoft that can help nudge you in the right direction to help you push past these sorts of problems. In my experience, there's really just a few common problems that beginners run into. The first is configuration, installation of software like Visual Studio or of the Windows operating system, some permissions issue. They don't have the right permissions for their computer to install a certain a certain program or whatever the case might be. So this could be a strange error that happens in Visual Studio whenever you're attempting to load up a project, to compile a project, to debug a project. And so whenever I hit errors like that, that I've never seen before, I usually take 4 steps. And I've never really written these down, but now that I'm having to articulate them, this is really the process that I go through. First of all, I research. Using the key phrase from the error message is vitally important. I'll usually try to copy the entire error message and paste it into my favorite search engine. So also any error numbers or the exact phrases surrounded in double quotes will get you closer to a solution. So I might spend 10 to 15 minutes just scanning through various blogs or forums on MSDN to find a potential solution. If I'm mindful about the search terms that I use, I can almost always find a solution to what I'm looking for. I think a lot of beginners fail with finding solutions to their problems because they become impatient with the error messages, or they don't know quite how to perform a search correctly. In 2014 and beyond, it's vitally important to understand how to use double quotes around a phrase in order to find that exact phrase using a search engine. Using exact phrases inside of the error messages that you see on screen surrounded with double quotes will get you closer to finding other people that have had similar issues who have resolved the issue and they posted how they were able to resolve it. So research is the key in doing the right kind of research. Again, using phrases and ideas inside of the error messages you see to perform searches. If you can't find the solution, sometimes a simple reboot will help. So before I do something potentially time-consuming and destructive, I'm convinced that this is an issue with Visual Studio and not my code, then I'll typically shut down Visual Studio and restart it to see if that fixes it. If that doesn't fix my problem, then I reboot the computer and see if that resolves the issue. If that doesn't fix the problem, then I might attempt to uninstall Visual Studio and reinstall it. Now let me stop you right there before you get the wrong idea. It's been years since I've had to do this. I almost never have to do it. You should not start here, but it is an option if you're convinced that something was corrupt during the installation of Visual Studio. But I'm telling you, if you didn't get any error message during the installation and you haven't installed any potentially malicious software programs to your computer, then that's probably not the issue. But if that doesn't fix the problem, then I might even, as a last resort, attempt to completely reset the computer, reinstall the operating system, reinstall Visual Studio, everything. So I call this the nuclear option because you'll spend hours or days going through this exercise. It's been years since I've ever had to do something quite this drastic, so don't start there. That's your last resort. But typically, by resetting the computer, you'll be able to get back to the original state and continue on. So whenever I've had to reinstall the operating system or Visual Studio, it's been so painful that I've begun to become very regimented with how I work with my computer. I generally try to keep the computer that I use for work inside of Visual Studio pristine. In fact, I keep the computer I surf the internet with or play games with separate from the computer that I use for work purposes like Visual Studio and Office and things of that nature. It's not a matter of Visual Studio being temperamental. It's just that there's a lot of resources that Visual Studio is counting on to be unadulterated. So I try to keep that machine updated with new operating system updates using Windows Update. I try not to install anything on that computer that I don't absolutely have to have in order to do my work. So short of something that's wrong with my operating system or Visual Studio, most of the issues that I run into or I've seen beginners run into and experience involve one of several broad categories of problems. So maybe it's the unexpected order of events firing. In a simple application, this might not seem like much of an issue like the ones that we built using the console window application. But as you probably learn when you focus on a display technology like the Windows Presentation Foundation or ASP.NET Web Forms or some other presentation API within the .NET Framework Class Library, there are many events that are potentially fired that occur for what might seem like an innocuous operation like a form load or a button click. It's not performing the way that you would expect it to. So the solution to these sorts of issues is to set breakpoints in multiple places in your code to better understand when the various event handlers are firing and what order they fire, and identify how the code that's handling two events are battling each other. Perhaps one that's displaying data on screen and the other one that's clearing data from the screen. Okay, maybe they're not happening in the order that you expected them to happen in. And this actually happens to beginners more often than you might first imagine. The other issue that I see beginners running into often is connecting to outside resources like a file or a database or a website. That often presents challenges to those who are just getting started. Again, reading the error messages closely and doing a search on the internet for the exact terms in the error message is the key to determining exactly what's to blame for the given issue. So beware, if you copy and paste an example from an article or a book, you might have to modify the example slightly, taking into account the connection information for your environment based on where a resource is on your hard drive or the network that you're currently on, and replacing whatever that code example had as its connection string or its default locations looking for things on the computer. Okay. Another common issue that beginners run into is using the wrong tool for the job. So shoehorning a technology that you're already familiar with into a situation where it really doesn't fit, in lieu of learning a better technology that's well suited for the task at hand. So this might be because you have a fundamental misunderstanding of the technology and what it was designed to do, understanding its limitations as well as other good options that are available to you. So what I recommend here is to continue reading books and articles, keeping up with blogs on MSDN, and stay abreast of new developments and new technologies and APIs that come out from Microsoft. So I have, as you can see behind me, and this is not nearly even a drop in the bucket, I have a large collection of books on programming. Now, I haven't read every single one of these books. Instead, what I do is when I get a new book here, I got this book recently here. I'll take the book and I'll start looking through it page by page and just make a mental map of the kinds of information that it covers. And I might spend 10 to 15 minutes doing this, looking over the table of contents, looking over each of the pages, the examples, the screenshots, in order to make a mental map of what's in this resource. And then whenever I need it, I can come back to it at some future point in time, knowing I can say, oh yeah, this book has something I need and that book had something I needed in it. And I recall reading something in this book that might help me address whatever it is I'm trying to build at that time, okay? So you can do the same sort of thing with blogs and articles online. In fact, I subscribe to about 100 different blogs and use a service online that sends me updates from the blog via email, since for me, I know I check email every single day. So it's in my face. I have to deal with the email, either delete it, at least read the headline, skim through it. Now, if it's something that I think I might need in the future, then I archive it, I save it off, and so that I can search for it in the future. So in these cases, I'm building a library of resources and an overall framework that new and existing technologies fit into. So when I need to utilize that given technology in an application, at that point I dig deeper and become an instant expert at it, okay? And there are a few geniuses out there that have photographic memories. They can look at something one time and they just know things. But for the rest of us, the majority of us, we simply have to be organized, and we have to have a general knowledge of a lot of different areas and then dive in deep whenever the occasion calls for it, okay? So I think one vital skill as a modern software developer is to become great at searching on the internet to help solve issues that you run into. It might sound easier just to ask a question for a problem that you're having, but I assure you it'll actually take longer to type up a question and ask a friend, or type up a question on a forum and then wait for the responses to roll in, than just searching, refining your searches to find a solution, and so on. I almost never have to ask a question in the forums for any software, because a simple search will almost always yield a clue as to what I did wrong or what the issue is. So keep in mind that there are literally millions of people working in the .NET framework and in Visual Studio on a full-time basis every single day. This means there's a huge body of knowledge out there that you can tap into whenever you need it. Virtually any issue that you run into, I guarantee it, somebody else has already experienced it and they've already figured out the solution to it. They've already posted that solution online. So let's suppose you are at wit's end. You can't find any solutions online. Nobody's ever run into this particular problem that you're having right now. You've patiently worked through the search results. Nothing you've tried actually works. You need to ask for help. Well, here's what you need to do to get a resolution to your problem. First of all, become an empathetic requester. In other words, give the people who are trying to help you enough information so that they can pinpoint the issue. This means that you need to clearly state your request. And so here's a checklist of things that you should include in your post. Start by posting your question in the right place. Find the right category to post in. Posting a Visual Basic question in the C# forum is not going to be all that productive, okay? Secondly, choose a simple, clear title for your post so that it attracts attention to the people who can potentially help you, and it saves everybody a lot of time. If I see a forum post that says, "Please help," I skip it, okay? If it says, "Link to object query yielding unexpected results," I think, well, that's something I know a little bit about. Maybe I can help that person out, all right? So that's number 2. Third, a short synopsis of the issue, including the exact error message or behavior that you're experiencing. Describe what you expect to happen and what actually happened. So I get emails almost every day from people that are asking for help, and I love helping people. Some days a little bit harder than others, depending on how much work I need to get done that day, but I generally try to help everybody who asks. So when people say, "I have a problem, it doesn't work, what did I do wrong?" I'm like, well, show me some code, all right? Pinpoint, what have you tried already? Tell me a little bit more about the problem you're having. Give as much information as you possibly can to me, and then maybe I can help you out, all right? And so continuing on, here's a couple of things can help. A screenshot would help, all right? Ideally, you use some image editing program to draw a box around that part of the screenshot that you want to call my attention to. Include the code, a code example. Change up any super secret information in your code that you post to forums or when you send it to somebody else. But without a code snippet, we're not going to be able to resolve or help you resolve your problem. And then be choosy about which code you actually post. Nothing's more frustrating than looking at somebody who posts like 200 lines of code in their request. You need to help us and identify those lines of code that might be involved in the issue. In some cases, forums have special HTML tags or shortcodes that you can add to help format the code and help it stand out in the post, or help to highlight the given lines of code that you think are problematic. That would be helpful, all right? Tell us, what did you do to try and solve the problem on your own already? What did you try and what hasn't worked? Did this lead you to rule out several possibilities? Again, empathize with the reader of your post. This will result in a faster resolution. Otherwise, people will start with the obvious issues and move forward from there. Do you know why when you call tech support, the first thing they say is, well, is the computer plugged in? That's because it's what most people fail to realize, the most simple stuff first. So we start with the simple stuff, then we move up in complexity from there, okay? So if you want to skip all that and the back and forth and the time required, then tell us what you know works and what hasn't worked up to this point for you. Also, tell us which operating system you're using, which version of Visual Studio, which programming language you're using, which updates or service packs have been applied. This actually can matter more than you might realize, especially for more complicated issues. Suppose that there's a resolution to the issue. You figured it out, somebody helped you figure it out, whatever the case might be. One of the suggestions that somebody made was helpful, it got you pointed in the right direction. Awesome. Now, take a moment and go back and describe what you did to resolve the issue step by step as a means of helping others in the future and as a means of articulating for your own future self and for your own understanding what the issues were and what that meant. So chances are you're going to experience a similar issue in the future, and it'd be nice just to search for your own solution online. I can't tell you how many times I've searched for my own username and said, I know I've faced this before, I know I've solved this before, and I can search online and I can find what I did to fix it. All right, so I help myself, not just everybody else. And then finally, and most importantly, be polite. People don't owe you an answer. I'd love to help you, but if I can't get to your question today, don't be mad at me. I'm helping you, and people who on forums are helping you in their spare time as a means of furthering their own understanding, as a means of just being nice. So say please and say thank you. All right, so you might be wondering where to go to ask your questions. It really depends. I recommend that you start here at msdn.microsoft.com/forums. All right, that forum is monitored by Microsoft employees and Microsoft Most Valuable Professionals. These are knowledgeable people who have demonstrated their willingness to help. A more comprehensive, even if less beginner-friendly place to go is Stack Exchange. So you can go to programmers.stackexchange.com. And I only say that this is less friendly because you're going to be critiqued for how you ask the question. So just follow the rules. First of all, you're going to want to search and search and search before you ask a duplicate question, and don't take offense if there's criticism about your question. I'd recommend that you search long and hard before you ask a question on Stack Exchange. Virtually everything you can imagine has probably already been asked by somebody. You just need to spend a little time finding the answer yourself. Okay, so I said I would answer the question, where do you go from here, in two ways. I've already answered the question, where do you go from here whenever you have problems? Next, I want to answer, where do you go from here in order to learn more about application development? So you should now have a basic knowledge of the Visual Basic Programming Language. You're not done here. There's still a lot of opportunity for practice, a lot of opportunity to grow from here. But now you should have at least a solid base to build on. So no matter what type of applications you want to ultimately build, there are a few fundamentals that you should really become acquainted with. First of all, you should learn how to work with relational databases like SQL Server. You should learn how to access the data stored in a database using ADO.NET or the Entity Framework. Both have visual tools that you can start with to drag and drop and configure your settings and your selections, but you'll quickly want to grow past the visual tools and learn how to write code and rely less on visual designers in Visual Studio. But still, that's a great place to start. Next, you'll want to choose a presentation technology to master. Now, you have no lack of options in this area, including things we've already looked at like ASP.NET Web Forms and the Windows Presentation Foundation. There's also ASP.NET MVC, there's Windows Form, there's the Windows App Store style, modern style interfaces. If you're not sure, let me suggest that at the very least you should learn HTML and CSS and JavaScript. And I've created several fundamental series on Microsoft's Channel 9 aimed at each of those topics. Then I recommend that you learn the basic tenets of application architecture, particularly how to split your code into layers of responsibility. Splitting your code into layers of responsibility will help you build applications that can withstand the impact of change. And change, as you'll come to learn, comes from various places. For example, change of business requirements. Change comes from changes in technology. Change comes from defects in the software, and so on. In each case, you can mitigate the impact of making changes in your code by encapsulating responsibilities behind well-established APIs. Now, I spend a lot of time thinking about and talking about application architecture on my own website, www.learnvisualstudio.net. But from application architecture, from there, what you'll want to learn is more about basic software design patterns and tactics and techniques. And so there's a few keywords that you'll likely want to learn more about. Each of these could spawn an entire book or video series. And I've already alluded to object-oriented programming. That's the biggie. You should learn as much as you can about object-oriented programming. But beyond that, you want to learn about principles like DRY, don't repeat yourself, or DRY, or YAGNI, YAGNI, you ain't gonna need it. So this is a principle that says you shouldn't be planning way ahead for the future and building all this extra infrastructure in your code for something that you might never need in the future, all right? That didn't make any sense. A longer explanation of that might be beneficial. There are more advanced concepts that are important, like dependency injection. It's a pattern that guides you towards building loosely coupled objects that can be swapped out, implementations that can be swapped out at runtime, and you'll want to understand why this matters. You'll want to learn about a set of principles with the acronym SOLID. It's 5 principles that help you realize the promise of object-oriented programming in your applications. There's also GRASP patterns, G-R-A-S-P. Again, another set of principles that help you assign responsibilities to your objects as you're designing them for your application. And there's virtually no end to the number of things that you can learn with regards to patterns and practices and things of that regard, and to continue to practice those. You want to learn about workflow, especially you'll want to learn about working in teams and sharing code and using a source code repository. You'll definitely want to learn about building unit tests, which are tiny code-based tests that are continually testing the code that you write. Some have gone even as far to suggest that you should be writing those little tests first to drive the development of your production code in a process that's called test-driven development, or TDD. You want to learn about agile project management and agile software development techniques. You want to learn about defining requirements and user stories, playing planning poker to determine what we can do in this short time frame and what will have to be left out. You may want to learn about agile boards and project planning to assign tasks to various programmers on the team. You want to learn about the nature of iterative development, about developing a spike of functionality all the way through the application to demonstrate a particular architectural decision. Oh, and there's so much more from there, okay? All right, so there's the path that I've given you. Actually, it's going to take you the next couple of years just to learn the things that I recommended, not to mention the things that I failed to add to that list. But fortunately, again, you don't have to know it all in order to get started. But yeah, there's so much to learn, so little time, regrettably. I've even gotten some people at Microsoft to confide in me that it's a challenge for them to learn it all, and they work and they're surrounded by that environment every day. So nobody just knows all this stuff automatically. But this is what makes software development so fun and so challenging, and maybe a little bit daunting at times. So there are a bunch of resources out there on the internet, not the least of which is Microsoft Virtual Academy. Make sure you keep moving down in that direction, and they'll have a lot more great courses for you to work through. There's also Channel 9. There's also all the resources that are available at MSDN. Allow me to make one last plug for my own website, www.learnvisualstudio.net, which at the time I record this has over 150 hours of training that's geared towards getting somebody who's a beginner to the point where they can interview for their first job or maybe their first promotion. Geared at getting somebody who's a beginner up and running as quickly as possible, pointing out what I feel are the key ideas for software developers and what's in demand today on the job market. There are homework exercises, interaction with me via Q&A for each lesson, and so on. So please check that out when you have a chance. All right, so as I close, I hope you found the time we spent together valuable. If there's anything that I can help you with, please let me know. As I said at the outset, you can post a question. If there's a comments area wherever this video is found, then please feel free to ask the question. Or you can write me at bob@learnvisualstudio.net, and I'll try to help. All right, so I wish you great success in your career as you move forward. I know you'll do fine, and good luck.